Hey guys, Pankaj here. Welcome back to my YouTube channel. In this video, I'm going to start with Numpy, that is numerical Python package. So this package is heavily used in data science. Okay, so be it image manipulation or TensorFlow, deep learning, artificial intelligence. So in so many places, this is going to be used heavily. So you should know each and every bits and pieces of Numpy package. Okay, so how to use and where to apply, what are the various functions which can be used. That I'm going to explain with the examples. Okay, so let me share something. Okay, so yeah. Okay, so so those who are using Anaconda, right? So this package will come by default, and those who are not using Anaconda and they might be using standalone Python, so you may have to install it. Okay, so how to install I have already explained in functional and module package, but let me just show you. So go to your command prompt and just type pip. So I have pip all the versions, so I'll use 3.9 and just type install, just put numpy. Okay, so since I already have, so it may not install. Okay, sorry for the typo. Okay, yeah, so it is already satisfied. So right now what version I have is 1.2.0. Okay, so you can also go to your command prompt. Those who are using Windows, just go to Windows command prompt, just type this pip. Okay, and in Mac or Linux it will be same. Okay, so once it is installed, you can just type, let's say, Python 3.9 import numpy as np. So I'm going to use alias as np, which is like very standard, everyone using, but you're free to use any name. Okay, so if numpy is installed, it is going to create the alias of np. Let's wait for it. So it's a huge library, right? So it is taking some time. Okay, come on. Yeah, now it is there. So I can just check what is the version, np dot version. Okay, so 1.20.2. So you may have some more minor based on the US OS compatibility. So you may have 120 or 119 or something, and .1.2.3 whatever. Okay, but don't worry, it is going to have almost all the functions whatever we are going to use. Okay, so that's how you install and use the NumPy. Okay, so let me show a couple of detail what and all it supports and what and all APIs are there. Then we'll go with all the APIs detail with some hands-on. Okay. So as I mentioned, it is a scientific computation library, right? So that's why it is used heavily in all the data related or all scientific computation related stuff. Okay, so by far the most commonly used package are those in the SciPy stack. So SciPy stack is nothing but it has a couple of other supported libraries also. Okay, that's why I mentioned SciPy stack. So we'll focus on these packages include NumPy, SciPy. Okay, so NumPy which we are going to start today, and SciPy we'll see later, and matplotlib for data visualization. Okay, so let's not worry about this IPython. And pandas, once numpy is completed, we'll go to pandas, that is for data analysis. Okay, so whatever tabular data you have, right, either CSV or Excel sheet, those things can be processed using panda very easily. Okay, yeah, so let's start with numpy. Okay, so this is a powerful n dimensional array object. Okay, so if you guys remember, I have talked about list, right, in first second or third video. Okay, so list was like one dimensional array you can treat. Okay, but here using numpy you can create n dimensional array. Okay, it is basically a list, or you can say array, but it is it can be converted to n dimension. Okay, and this will be heterogeneous, not heterogeneous data, basically homogeneous data. If you have integer, all data has to be integer. Okay, but unlike list, we could have heterogeneous data, right? Inside list, you can have list, you can have string, tuple, float, complex, whatever data you have. But here it will be homogeneous data. Okay, so Tools for integrating C, C++, and Fortran code. So these are like internals, so you don't have to worry. It is used for heavily for linear algebra, Fourier transform. This is under basically a signal processing and random number generation capabilities. Okay, we are going to see all those examples. Don't worry. Okay, so the key to NumPy is the n-dimensional array object. Okay, so we will see very shortly. NumPy arrays have fixed size. Modifying the size means creating a new array. So we can see like how we can modify different sizes, how we can create in the runtime with different sizes of array. NumPy array must be of the same data type, which I already mentioned. It is homogeneous data. More efficient mathematical operation than built-in sequence data type. Okay, so you will see the magic of this NumPy, how you can do very large operation in one shot. Okay. So let's see what and all data type it supports. So before talking about NumPy data type, let me go back to list. So there it was like by default, there was no data type to be mentioned in the list creation. Okay, but in NumPy by default it will create mostly integer 64 or float in mostly integer 64 or float 64, right? But user has given choice like whatever data type you want. Okay, so you guys should know very well like how you can change the data type during runtime or during creation. Okay, why this is important you will understand when you use very huge data for processing. Okay, so I can just take one example. Let's say you have simple image. Okay, and image, let's say black and white image. So in black and white image, mostly all the pixels will be there and their color will be mostly 0 to gray, right? And various different variations will be there between 0 to 1, that is white to black. Okay, so due to various variation, mostly it will support 2 raised to 8, that is up to 255 colors, correct? So if you are going to read the black and white image and you check the data type, by default it is going to consume either integer 64 or 64 data type, right? But do we really need that much data? It's not required, right? We just need integer 8-bit data, correct? So that's where you need to save the data when you read very large image. Okay, and that too it is black and white, because 0 to 255 will suffice this purpose, correct? Only 8-bit representation is there. Why to waste memory for 64-bit, correct? So that's where you can typecast data into lower bit, that is integer 8-bit. Okay, so we have integer 8, 16, 32, 64, integer 8, u in unsigned integer, then float, then complex, and boolean. Okay, so couple of them we will be using during hands-on. Okay, so these are example. Don't worry, this is mentioned in the presentation. I'll upload in my GitHub also, so you can download and just refer it. Okay, so there are a couple of mechanisms for creating arrays in NumPy. Conversion from other Python structure, that is listable. So we'll see either you can define standalone NumPy array, or there are some other data. Let's say you have list or you have tuple, right? How you can convert list and tuple into n-dimensional array or NumPy array. Okay, built-in NumPy array creation using arange function, ones, zeros, everything we are going to see. Reading arrays from the disk, it could be CSV file or any file, right? Okay, so in general, any numerical data is stored in an array-like container and can be converted to an n-dimensional array through use of an array function. We'll see how to use that and how to convert a single dimension with n-dimensional array. Okay, so these are various examples here which is mentioned. We'll see a lot of other functions which is very heavily used for scientific computation, like linear space, then calculating the sine function, sine of the given data, cosine of the given data. Okay, generating random number. It is not just simple function which will generate random number between 0 to 1. You can give any kind of data or any number between, let's say, 0 to, let's say, 100. Okay, you want one number or you want 100 numbers, 100 random numbers, or maybe different float numbers, that too was random. Okay, so this function will help you. Okay, then we'll do indexing slicing the way we did indexing slicing in list. Same way we can do in the n-dimensional array also. So I'm not going to talk about this right now, but I'm going to show in the examples. Okay, so array operation, we'll see we'll see a lot of arithmetical operation you can do in the array. Okay, so one thing to remember, guys, those who are watching this video first time, or NumPy is completely new to them, or mathematics is completely new to them, I would suggest just refresh your knowledge, of basic mathematical operation like all arithmetic operation, and little bit of matrix. Okay, and just 2 by 3 or 3 by 4 matrix is good enough. Just see what are the basic operation you can do, because here it is completely matrix operation. Okay, so if you understand matrix, then definitely you can do any kind of image manipulation also, because image is what it is, just 10 by 10 pixels, 100 by 100 pixels, and couple of data in that pixel that you need to just manipulate. Okay, then we'll see a couple of linear algebra functionality. Okay, yeah, so these are things which it is not very limited to this, but I'm going to show a lot of other functionality, what and all you can do. Okay, so let's go to notebook and see what and all functionality I'm going to cover. Okay, so we will see what are supported function, how to create array, what are specific data types, what are different attributes. Okay, so once you have created n-dimensional array, what and all different attribute you should know, and what and all n-dimensional array holds those attributes. Okay, how we can do conversion from list to array or tuple to array, or given array, how you can convert it to different array. Okay, then how to convert 1-dimensional, 2-dimensional, 3-dimensional, 4-dimensional, or n-dimensional array. So everything we'll see here. Okay, so this video is going to be very long, right? So I will not going to record everything in a single video, rather I'll break in 2 or 3 parts. Okay, so let's see what and all I'm going to cover in this video. Okay, so first of all, whenever you are going to do any NumPy operation, you need to do import of that library, right? So we have import NumPy as NP. As I mentioned, NP is just alias, you can give any number. Okay, so let's see. It is loading first time, it will take some time. Okay, now it is loaded. So this is the one, module NumPy, and from this package it is loading. Okay, now let's see how to get the version. I have already shown the command prompt. Let's run in the notebook also. np dot version. Okay, 121.2. Okay, you might have seen 120.2 in the command prompt, but here this is notebook, right? So my Anaconda is maintaining different version. Okay, so right now I have 121.2 latest version. What are supported functions? So let's print dir of np. There are n number of functions. So it's not like you need to know every bits and pieces of this or every function of this, but yeah, a lot of function we are going to cover in this video, so that should be good enough. And once you are familiar with all the basic function, of course you go to each function and understand the help and just use based on the need. If you want to count, then let me just show you. So this is the list of function, right? So I can do length dir of np. So total 612 functions are there, including attributes or whatever, attributes plus methods. Okay, so now first thing is how to create an array. Okay, so as I mentioned, we have seen in the list, right, it was single dimension. Now we are going to do either single dimension, 2-dimension in the form of array object. Okay, so we have something called, since it is array, so I'll just mention a equal to np dot array. Okay, let's see its help. So understand what and all parameter it has. So array is the function which are going to create the NumPy array. Okay, so this is the object. So object could be either you are giving runtime object, or like object is nothing but like it could be a list or it could be tuple also. Okay, but here I can show with everything using list, using tuple, and in case you are going to provide directly all the numbers. Okay, then data type. So as I mentioned, by default it is none, and it is going to take, I think, integer 64. I'll show you. Then we have copy and what are orders. So let's not worry about this. What are those? Okay, I can cover these things under different examples. So if you don't do anything, right, and you just create any NumPy array, what happens? Let's see. Okay, so I'm just going to give symbol. Okay, so as I mentioned here, it needs object, right? So object could be anything, either list or tuple, right? So I'm not going to give any argument here or any element here. I'm just going to pass simple empty list object. So what it is going to get, you see here. A is nothing but an array which is empty, and its data type is float 64. So that's what I told. So if you don't mention any data type during runtime creation, it is going to take the maximum data type. Okay, that is float 64. Okay, so that's the way you create. And let's say I have passed some element 1, 2, 3, 4. Okay, so this is an array which is holding 3 or 4 elements, right? Now let's say, remember once again guys, it needs list or object type. Okay, so I can give list or tuple type, so I can give tuple also. Okay, so this is the list and this is tuple, and my array is created. Okay, now if you see the help, as I mentioned, it is taking object, right? So right now I'm just giving runtime data. Okay, now assume that I'm taking another example here. So L equal to, there's a list 1, 2, 3, 4. So instead of passing 1, 2, 3, 4 direct element, I'm just going to pass an object, that is list object. Okay, so from this also it is going to create an array. That's good. Now I can mention tuple. Okay, so let's mention this as T tuple. Okay, so any whichever way you would like to know, or you would like to pass based on your need, right? So you are free to do anything. Okay, either pass list or either pass tuple object, or you can give runtime data. Okay, so that is the way to create the array. Now I'll show one more thing here. As I mentioned, you can use specific data, right? So that is the next one. So by default, it is creating the data as float 64, which we have already seen here. Okay. Now I'm going to use with the specific data type. So here you have one parameter called d type, right? So as I mentioned, if you don't mention any data type, by default it is going to take float 64. But I'm going to use one of these data type which I showed you in the PPT. So yeah, so integer 8, 16, 30, right? So I'm going to take only integer value, right? So let's mention minimum one, that is integer 8. You see here, the moment you mention what data type you are going to use, it is going to print here also. Data type is integer 8. Okay, that's how you. Now let's see various attributes. What are the attributes which you can use? Okay, so first let me create this once again. Okay, so print a dot d type. I'm going to explain everything. Let me share again what happened to this. Where is the screen? Yeah. Okay. Yeah, so we have d type, then what else we can use? Let me just write it here. So we have size, then we have atom size. What else we can use? Size, atom size, d type, and then number of dimension. Then we have flags. Okay, so let me explain all the things one by one. So the moment you create the array, right? Let me print the array also. Okay, so array is your 1, 2, 3, 4, and what is the data type? So as I mentioned, you have given data type integer 8, but you can fetch using attribute also. So integer 8 is the data type. Okay, now what is this size? This size is nothing but how many elements are there. Okay, so let's say you give 5. Okay, you are getting 5. So it is same as like length of the list. So using length function, you get how many elements are there, right? But in the n-dimensional array or normal array, you can use size attribute, which is going to return total number of elements used in the array. Okay, what is this item size? This is very interesting. So it is returning 1, means it is exactly taking 1 byte of data. Okay, it means each element of this n-dimensional array or one-dimensional array is going to consume 1 byte of data. Oh, sorry, 1 byte of size or 1 byte of memory. Okay, so in case you would like to see like how much memory is consumed by this particular array, so get the size 1 byte and multiply by size of the array. Okay, so 5 by multiply by 1, that is 5 byte is going to be consumed by this array. What is the number of dimension? It is single dimension. Okay, I'll show 2 by 3, 3 by 4, all those things. Flags are like it has different flags, which is by default true. See, it is like continuous memory, then photon style. You really don't have to worry, but yeah, just be aware, like we have some flag which can be manipulated later. I'll show in some of other examples. Okay, so let's see another example. Generate an array based on range values. Okay, so I'll write here to np dot. For that we have range of value, right? So you can use a range. Okay, create an array with the range. So here it takes what is the start. It is like a range function of the list, right? Same thing. So start is let's say 1 and stop is let's say 10. What else? Step size also you can give. Okay. Now let's print a. So from 1 to 10. So of course last value will be excluded. So 10 minus 1, that is 9. Okay. So 1 to 9. This is array. This will be very helpful when you are going to create some large array for learning purpose. Okay. So you can easily create instead of writing manually 1 by 1. So again, here also you will have similar data type object you can mention here. Okay, so let me take another example here. Every two or every second element. Okay, now I'll take one more. Starting from 0, I want every second element, that is even number. Okay, so that's how you create it. Now if I take d type, equal to integer 16-bit. Okay, so you are going to take 16-bit. So let's see the next one. Convert a list into Numpy array. Okay, so I think this I have already shown. List into Numpy array. You can take list and use this as an object. Okay, so what else we have? Let me just show. One, two, three, four. Select data. I'll just write it once again. Print type of L equal to np dot array L print a print type of A. Okay, so first one is list. Now I got the array and I converted list into one-dimensional array. Okay, that's why you see type of A is nothing but NumPy n-dimensional array. Okay, so we have something called as array method also. So whatever data you have, you can convert into array using array also. Okay, so how to convert? We'll see that. So we have list equal to, let's say 1, 2, 3, 4. We have np dot as array. Let's see the function. Yeah, so what it needs as array A. This is nothing but your array. Okay, and data type, again you can mention that. Okay, so L and let's say B equal to this. So anyway, it's fine. So basically this is also converting. The internally it will be doing same what we have done here. So as array method you can do, and you can take data type also. Mostly this parameter will be exactly common across almost all the functions of numpy. Okay, integer 32. Okay, so that's how you create the number. So now let's create the random number. So this function is very, very important. Whenever you go to like machine learning or deep learning or using TensorFlow library, right? You will be, let's say you don't have any data, right? So you need to generate a lot of data. How you are going to convert, use the data? So you convert or you use the data from the NumPy, which is generated by random number, very huge data. Then you use them as a data input for your functions. Okay. So in this we have a lot of variety here. So first I'll take p dot random dot rand int. Yeah, so this is my favorite function. Why? Because mostly it helps to create almost all kind of data, whatever I need for learning purpose. Okay, so random integer, what it is, low, that is what is the lower number you want, what is the higher number, and what is the size you want. So by default size will be 1. Okay, so I'm just going to show you. So let's say between 1 to 10 I want. Okay, and print it is just going to generate one number because I have not given how many numbers I want. So by default it will be one number. Correct. You see here, every time I'm running, it is giving different number. Now, if you want, let's say 10 numbers or maybe 5 numbers. So between 1 to 10, it will just pick the random number and it will just generate. Okay, so this number, why I'm telling it is very helpful and it will be used heavily because let's say you are going to simulate during, when we talk about statistics, you may need some data. Let's say user is throwing the fair dice 100 times or 1000 times. It is very tough to throw the dice 1000 times manually and note down the number and prepare a data set. So that is not suggestible. It is very foolish decision to throw it randomly and manually. So better to use this function, give the 100 times or 1000 times or whatever million time you want, and it is going to help you and generate the random numbers. Okay, so let's say, sorry, so I'm going to throw a dice. Okay, so dice number is between 1 to 6, right? So last number is always excluded, so I'll put 7 and I'm going to throw it 10 times. Okay, so each and every throw it will return me a number. So in first throw I got 3, second throw I got 5, and so on, and last throw I got 6. Okay, similarly if you want 100 times. Okay, so I'll use these functions again and again wherever it is required to do some mathematical calculation or some statistics function. So that's where a random integer will be very helpful. Okay, so let's see what and all we can use. We have random dot random also, so we'll see what we can use. So this is about random dot randint. Now we'll take random dot random. Let's see what it does basically. So it just take the size, right? So if I don't provide size, it is just going to provide the number between 0 to 1, that is float number, correct? If I'm going to provide size, let's say I want 5 number. So between 0 to 1, it is going to provide all the float number, five different random number. Okay, so that's what it does. So let's see if any other function is there. Random dot rand is there. Oh, random is there. Random values in a given shape. Okay, so if I have what it does basically. Oh, okay. So I need to provide a shape. Okay, so I think it is also going to do same thing, but I'll provide, let's say 2 by 2 or 2 by 3. Yeah. Okay, so this is the shape. So I want 2 rows and 3 columns, right? So this will be first row and this is second row, and total 3 columns. The first column, second, and third column. Okay, so whatever size you want, right? Let's say I want a square matrix of 5 by 5. Okay, so it is going to create 5 by 5 arrays, 5 rows, 5 column with all the random number between 0 and 1. That's what it does. Okay, so these things will be very helpful when you go for machine learning and all. So please remember that. Okay, let's talk about reshaping an array. Okay, So why this reshaping comes into picture? This is again will be very helpful when you go to machine learning. Okay, so because machine learning will have a lot of tabular data, and there you may have to filter the target value, okay, target column, and based on that, based on their shape, you may have to do the dimension conversion. Okay, similarly in the TensorFlow or in deep learning concept also. So we'll see in the example, but first you be aware like how to do reshaping. Okay, so let me take one random number here, np dot random dot randint. So between 1 to let's say 50, I am, let's take some smaller number, 20, and I'm going to generate, let's say 25 number, or maybe let's take 50. I want 25 numbers. Okay, so what is the dimension of this array? Basically it is a single dimensional array, correct? Because you see one continuous values, not continuous, basically it is different values, but it is in a single what to say, stretch of memory. Okay, so it is just a single list of single dimension. So in case you want to check number of dimension, it is going to return 1. Okay, so now I have 25 values, right? So I'm going to convert this into different dimension. So one dimension could be like 2 dimension, where couple of rows and couple of columns will be there, right? Another is 3 dimension, like Rubik cube. So Rubik cube, what we have in the front face, we have 3 by 3, right? In the back, in the top, bottom, everything, correct? So that 3 by 3 matrix we can convert, we can, let's say, we can produce in a 3 different phases. Okay, so front and middle and the back one. Okay, so 3 by 3 matrix 3 times, that is nothing but a 3 dimension. Similarly n dimension. Okay, so why this n dimension? Basically you can build an array by using Rubik cube, keep side by side and keep one top of other, right? So this will be becoming n dimensional array. Okay, so let me show one example, then it will be clear. So I'm going to use this value, and using this I'm going to create various array. Okay, so remember guys, whenever you are going to convert a given array which is single dimension to n dimensional array, make sure that whatever rows and column you are using, right, multiplication of that should be equal to total number of values in the single dimensional array, because those numbers only going to be arranged in those many rows and those many columns. So let's see example. So we have something called a dot reshape. Okay, so reshape, it needs shape, and what is order? That is C. Okay, so let's see what is C type. I think I already have it. Let me just put it somewhere. I'll put it under attributes. Okay, so C stands for continuous, that is data in a single C style continuous segment. F contiguous is the data is in single photon style. Okay, then own data, the array owns the memory it uses or it borrows from another object, writable, align, and updated copy. Okay, so that's what it is. You really don't have to worry, but sometimes what happens, C and F will be helpful. So that's where I'm going to show you. Okay, so first argument is shape. So what is the shape of this? Let's say I want total 25 elements are there, right? Okay, I can use, let's say 16 element, so that I can create any other shape also. Okay, so I want shape of 2 by 4. Okay, so you cannot reshape array of 16, oh sorry, 4 by 4. So 4 multiplied by 4, that is 16. So total 16 elements are there, right? That's what I told. Whatever row and columns you're using, multiply that, and whatever number you're getting, it should be matching with the number of elements in the single dimension array. Okay, yeah. So this is what it is. You see here 7, 35, 4, and 31, right? So it is going to take first 4 element and going to create a row, first row, another 4 element and another row, right, and so on. And that is what is your C style. Okay, so let me just show another style, that is order is F. Now see here, see the magic. So in the photonic style, what it does, it will take the array, like first 4 element, and it will make the column measure. Here it was row measure, and here it is in the F style, that is column measure. So 735, 431 will be part of the first column values, not the row, unlike in C. Okay, so here let me mention. Okay, so that is the difference between C and 4. It is like row measure or column measure. Okay, so this is about 4 by 4 array. Now, what other shape we can generate? 8 by 2, 2 by 8. So 2 rows and 8 column, right? Now, if I make 8 and 2, right? So what is? You see here 8 rows and 2 columns. Okay, so that's how you change the shape of the array. Now, if you want to change, check what is the shape. Let me just use. Okay, so b dot shape. It is not a function. Remember that it is a attribute. Okay, so this shape attribute will hold what is, how many total number of rows and total number of columns are there. Okay, so this was your 1 dimension, and these things were 2 dimensions. So let me copy paste. So this is your 2 dimension. Okay. So 1 dimension, 2 dimension, then let me show 3 dimension. Okay, so for 3 dimension, what I need to do, I just create a similar kind of element, but I'll just take 9. Then it will be easy to understand how Rubik's cubes can be represented using 3-dimensional array. Okay, so I'll just take, let's say, 20 and create total. How many values are there? 3 by 3 by 3, total 27, right? So let's write 27 and generate the array. So this is 1 dimension array and 27 values, right? So now let's make it 3 dimension. So how we can mention this as a reshape? Equal to a dot reshape. So it needs shape, right? So I want 3 matrix of 3 by 3. Okay, so total I want 3 rows, 3 column, and total how many such matrix? 3 times. Okay, because Rubik's cube has 3 phases: front, middle, and back. Okay, now let's see. You see here, this is your front face, 3 by 3 matrix. This is the middle one, and this is the last one. Okay, so that's how you change the shape of any matrix. So b dot shape, if you check 3 by 3 by 3, b dot number of dimension, it is going to give 3. Okay, and here if you are going to check, okay, so I have overwritten, so let me just run this one. Okay, you see here dimension is 2 because it is just like a plane. Okay, so x axis and y axis, correct? So 2 rows, 2 column, 3 rows, 2 column, right? But here column will be there, rows will be there, and in that direction also your array will grow. That's why this third dimension is there. Okay, so yeah, that's about 3 by 3 matrix. Let's do 4 dimension. Okay, so in 4 dimension, what you can do? Similar thing. So you keep multiple Rubik's cubes on top of each other side by side. So that will be your 4 dimension. Okay, so every element of that 4 dimension array is your 3 by 3. Okay, so how you can generate? Let me make this. So I'm going to create 3 by 3 and 3 by 3, and let's say total 2 Rubik's cube I would like to put. Okay, so 3 by 3 total 27, and maybe I'll put 81 values. Okay, so this will be 81 values, and I want 3 by 3 total 3 times, and another 2 matrix. Three times. Okay, you see here. So these are first Rubik cube and second Rubik cube and third Rubik cube. Okay, so you just imagine I have put first Rubik cube and the second Rubik cube and another third one. Okay, so that's for your 4 dimension. Okay, so how you can check? B dot shape, B dot n dimension 4. Okay, so this is about your shape manipulation, and it is not just limited to 4 dimension, 5 dimension, 6 dimension. You can create any kind of dimension. That is the beauty of Numpy array. Okay guys, I think that is good enough for this video, and I would suggest please pause the video and take any example, or maybe from top to bottom you just go through it, run in your notebook. If you don't understand, watch the video again, and if you still don't understand, leave the comment or put your question in the Telegram channel. I'll definitely help you. Okay, remaining one I'm going to cover in the next video. Okay, so please understand this concept very well, otherwise you will get stuck in OpenCV, that is image processing, machine learning as well as deep learning. Okay, so make sure that you are very well and you become expert in NumPy, then only you can go to different videos and you can watch machine learning and deep learning. Okay guys, thank you so much. Happy learning. Okay, and please, those who have not subscribed my channel, please do subscribe and leave out the comment and like the videos. Thank you so much. Bye-bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. Today I'm going to continue NumPy part 2. So those who are watching this video first time, I would suggest please complete NumPy part 1 first, then you come back to this video. Otherwise, you will not be able to understand what I'm going to talk. Let me share my screen. Okay, so in previous video, I have covered up to converting one dimension array to n dimension array, right? That is matrix reshaping. Okay, so today I'm going to talk about how to create array of strings. So let's start with the example. So the way you were identifying or you were writing the array for integer or float, right? Same way you can create with the strings as well. So as I mentioned, NumPy array are heterogeneous, not heterogeneous, homogeneous array, right? So if you have integer, all should be integer, or if you have float, all should be float. If you have a string, all should be string. Okay, so here is the example. Let me run this. So remember, if you have mix of values, right? Let's say string and integer. So string type will take the high priority. So other integer will automatically get typecasted to integer. Sorry, string. Okay, so I'm going to show an example. Then I'll be talking about what is this data type. Okay, so let's create another array. So here what I'll do, I'll just add some more variable, 1, 2, 3, and some integer and some string, right? So let's see what happened. So what it will do, it will convert these integer also to a string type, because string type will take the precedence over integer or float. Okay, so let it create. You see here, though I had given integer, but it has typecasted them to string type. Okay, so what is this data type? So this is nothing but U stands for Unicode and 21 is nothing but it is just a number. So this number can be anything, any integer number. Okay, I'll show some examples also what is the significance of this number. And this is nothing but little Indian and big Indian representation. So those who doesn't know about this, so I would say just Google it a little bit and understand what it is. So in short, little Indian, big Indian is nothing but having MSB at the first or MSB at the last, or LSB at the first, or LSB, that is least significant bit or most significant bit at the end or at the front. Okay, so yeah, so what I was talking is, like, if you have integer or float along with the string, so string will take the precedence and other data type will automatically get typecasted to string type. Okay, now let's take a look at this integer, this data type, how you can modify. So this, as I mentioned, this Unicode, and this is number, like how many set of how many character it can hold at once. Okay, so assume that I'm just giving here A, B, C, D, E. Okay, and here assume that you have given data type. Let's take D type equal to U, and let's say I take 3, right? So it means it is going to be truncating all the character whatever is having more than 3 character. Okay, so these are having less single character, that's fine, but what about those elements which is having more than 3 characters? This is going to be truncated. It is going to have only A, B, and C. Okay, so let's run this and see. D type. Why this error? What is missing here? A, B, C, D. Oh, I forgot to put the close bracket. Okay, yeah, you see here. So I'm redirecting, or I'm giving instruction to this array like hold only max 3 character. Okay, not more than that. So those who are having more than 3 character or more than given number, it is going to be truncated. Okay, now another example is, as I mentioned, if you have anything other than integer, other than a string type, then that will be typecasted. So let's say you have this value as 3.5. So what will happen to this? This is also going to be typecasted as string type. Okay, so that's about this. Now let's say creating array of string with other data types. So I think this is already covered. That is nothing but this, giving data type with different number. Okay, so I'm just going to paste here. Okay, so this angle bracket is nothing but, as I mentioned, it will be little linear or big linear, right? So you are free to use other bracket also. So let's say I can give this as well. Okay, so you will hardly notice any difference here, but internally what computer understand, right, it will be changing the order of MSB and LSB. That's all it does. Okay, so let's see another thing. I'm going to delete this. Manipulating one element of an array and its impact on other element. Okay, so what is going to happen here? So this is nothing but, as I mentioned here, if you are having, let's say, a set of integer character as well, float as well as integer, right? So it is going to be typecasted. That is nothing but, it is already covered here. So you just manipulate any data and you see the impact. Everything got typecasted to string type. Okay, so let me just put it here. But most of the cases, right, you are going to handle either integer data type or float data type. You will hardly will be using string data type. Okay, but what about heterogeneous data? Let's say you have an array where integer is there, float is there, and string is there, right? So that's where your pandas library will come into picture. So which I'll be talking about pandas in the next video, or next to next video after completing NumPy. Okay, so let's see another one. Yeah, so you may notice I will be using just inbuilt function, right? Why exactly it is used? So guys, NumPy is nothing but just it is basically using of all the given function and serving your purpose, whatever kind of data you are handling or whatever kind of project you are making, right? So it will be just manipulating all the data based on given functions. Okay, so you should understand how to use those functions, where to apply, how to use it. That's the only important thing. Okay, so next we have linearly spaced values. So far we are creating different integer values, right, using random integer function. Okay, so you have given some low value and high value. Between that, all the values will be randomly chosen. Okay, so what if you want to have linearly spaced value? What exactly linearly spaced means? Equally distributed difference will be there between minimum to high value. Okay, so for that we have direct function called a equal to np dot linspace. Okay, so let's see what it does. So this is going to take a start, stop, and we have, like, by default it is going to generate 50 different numbers, okay, between start and stop. Okay, endpoint 2 by default endpoint will be including. In case you want to exclude, then you just make it false. Okay. And data type and X is also, this I'll talk about later. So I'm going to use between 1 to 10. I want to have value, right? So what it will do, between 1 to 10 equally, it will distribute 50 different numbers. And that is what is this. So whatever array it is providing, that is nothing but 50 different values. Okay. So now let's take another example. So between 1 to 10, I want exactly total 15 numbers. So 15 equally distributed values will be given as an array between 1 to 10. Okay, so if you see here between 1 to 10, right, by default last value or the end value is also getting included, but there could be some cases where you don't want to include them, right? So for that we have something called endpoint equal to false. So you see here up to 9 or just before 10, whatever possible values which is equally distributed is coming, that is going to be given. Okay, so that's about linear space value. These things will be helpful when you are going to create a lot of graphical thing related to signal processing and all time-based data, right? So that's where you will be using linspace. So other than linear space value, we have something called logarithmic space. Okay, so for this also we have direct function. So let's take a look. So what it will do, it will take the log of those values and array will be created. Okay, so instead of linspace, you just mention log space. Very simple, similar function to the linspace. Only thing is it is going to calculate the log of those values. Okay, and rest of the parameters are same. Start, end, you see here, num, endpoint. Okay, so let's talk about how to create various kind of arrays, right? So those things will be helpful when you are going to do a lot of matrix related operation, right? So let's say you would like to have zeros. Okay, so what we can do, we have direct function called zeros. np dot zeros, let's see what it does. So zeros, what it take, it just take the shape. Okay, so and data type, order C, those things are common. As I mentioned, right, numpy function, almost all the function will have these parameters available. Okay, so let's say I give shape as 2. Okay, so let's see what it gives. So 2 is nothing but it is just going to provide me 2 elements. Okay, so now let's say you would like to have, I want to have 2 by 3. Will it give? Okay, so cannot interpret 3 as data type, right? So it needs shape. So guys, remember shape is always a tuple. Okay, so instead of giving 2, 3, you should give as a tuple. So 2 rows and 3 columns, correct? Similarly, you can have 5 by 5. It is all based on your requirement. So it will be creating one square matrix 5 by 5, where 5 rows and 5 columns will be there filled with zeros. Okay, so similar to this, we have another function called ones. Okay, so let's see what ones does. I'm just waiting for this help window to open. Yeah, once again, as zeros, it is taking shape and data type, right? So it will be just filled with one. Instead of 0, it is going to fill with ones. So I'll just take one example, 3 by 3 matrix with filled with ones. That's all. Okay, next is identity matrix. So guys, those who doesn't know about matrix, right, I would suggest just Google it and brush up your knowledge about matrix. Then you will easily understand all those things, what I'm talking, zeros, ones, identity, I matrix, empty matrix. Okay, so identity matrix is always a square matrix. Okay, so here you don't have to really provide the exact shape. You just mention how many number you want, that's all. So let me just create it. np dot identity. So I want number as 4, right? So it is going, since it is a square matrix, so definitely if you are giving 4, then 4 rows, 4 columns will be provided. Okay, as a square matrix. So in this identity matrix, always diagonal elements will be always 1. Okay, so if you want 3 by 3, then exactly 3 rows, 3 columns will be provided. Okay, let's talk about I matrix. So here what it does, not necessarily a square matrix, only diagonal elements are set to 1. So unlike identity, it will be exactly square matrix, right? But in I matrix, only diagonal elements are going to be set as 1. So even though you have 5 by 6, so under 5 by 6, whatever diagonal elements are coming, that is going to be set as 1. Okay, so let me just show one example. np dot I want 3 by, let's say, 5. Okay, so what is this? Why it is not giving output? It has come, right? Yeah, so and return 2D array with ones on the diagonal and zeros elsewhere. Okay, so whatever diagonal comes first, so this and its diagonally opposite element will be this, and this for this particular element, diagonally opposite value will be this. Okay, after that, nothing, there's no element, right? So other than these, whatever elements are coming, that will be by default set as zeros. Okay, that is what is your I matrix. Okay, let's talk about empty data. So we have np dot empty. What it does, let's take a look. It is going to fill all the random data for empty matrix. Okay, so let's see what it takes. It takes shape element and again data type, right? So I'm just going to provide shape as, let's say, 3 by 3. So in case you are going to it has taken 1 by 1, so that's okay. Let me take 5 by 5. So random value could be anything. So earlier it was giving 1, then now 0. It could have some other garbage value also. Okay, so it depends on the system. When you run, you may get some different values. Okay, guys, so this will be required when you are going to try something on, let's say 4 by 5 matrix, 5 by 4 matrix. Just generate random data, that's all. Or if when you don't care about any kind of data, then go with empty matrix. Okay, let's talk about transposing an array. So what basically transpose is? Transpose is nothing but, let's say you have any array where 2 rows, 3 columns are there, right? So you would like to convert row as a column and column as a row. That's where transpose will come into picture. Okay, so for this, I'm going to generate a matrix. So A equal to np dot random dot randint. So I'm going to create 1 to 20. I want to have, let's say, 3 by 4, that is 12 different random values between 1 to 20. Okay, and I'm going to reshape here only by, since 12 elements are there, so I can have 3 by 4, 4 by 3, 6 by 2, or 2 by 6, or 12 by 1, 1 by 12. Okay, so let me create 3 rows and 4 columns. Okay, yeah, so you see here 3 rows and 4 columns, correct? So this is the by default matrix. Now you would like to transpose, right? So we have direct function np dot transpose. What do you want to transpose? A. Okay, so see what happened. Earlier we have okay, so to understand better, let me just print A and its attribute A dot shape. Okay, so this is a matrix where 3 rows and 4 columns are there, and that's what is your shape, 3 by 4. Now after providing, let's say I'm storing in B and print B, print B dot shape. See here, so row got converted to column and column got converted to row. You can see here, so 11 14 9 4, 11 14 9 4. So earlier this particular list was as a row, now here list got converted to column. Okay, so that's what is the transpose. So you can, there are 2 ways to transpose. Either you can use inbuilt function, and there's one shortcut attribute called T. Okay, so you can also use v dot T, that stands for transpose. Let me just write for you. So whichever way is comfortable. This is my favorite because this is a short name, so I always use this. You guys can also use this. Okay, so let's talk about next modifying array values, right? So this is also very important thing because you will be using a lot of times modification of the values of a given array in machine learning or deep learning, okay, or especially in OpenCV for image processing. So I'm going to use np dot, I'll just take simple thing. Okay, so I just created array of random values between 1 to 20. Okay, so to modify array, if you guys remember, then list, right? In list, how we were modifying. Okay, so the best way is just use the index and assign some value, right? So same way, anyway, don't worry about indexing slicing. I'm going to cover it later, but just for you guys to remember, take the index. So I want to have, in NumPy we use in single bracket. Okay, so before comma, all row will be there and here column will be there. Okay, so I'm going to modify this 14 as, let's say, 1400, right? So first you should understand what is the index of this 14. So this comes under second row, that is, this is 0th row and this is the first row, that is second row. Okay, and column wise, this is first column and this is second column, this is 0 and first. Okay, so 14 is present in second row, or sorry, first row and first column, correct? If you are going to put, it is going to return 14. So now to modify this, I'm going to make it some assignment. After that, you print it. Okay, that's how you modify the value. It's pretty simple. Just you should know what is row and column and just give some value as assignment operator. Okay, so now let's talk about splitting an array. So this is also very important. Let's say you have very large amount of data in a simple array, right? And you want to process like first half and second half, row wise and column wise, right? So that's where we will get horizontal split and vertical split. So I'm going to take similar example here. Okay, so I'll take 3 by 4. Yeah, that's fine. Okay, so here how many columns are there? 2 column, 4 column. So this I'm going to divide horizontally, right? So for horizontal, same number of rows should be there. In case you would like to, let's say you don't have same number of rows, so what will happen? Let's try to do something, then you will understand. I'm just going to call a dot h split in 2 parts. Will it work? Let's have a look. Okay, np dot a. See here, missing one required positional argument, indices or section, correct? So let's have a look. It's an array and indices or sections. So I'm just going to divide into 2 parts. Will it work? Exactly. So 17, 7, 15. Okay, that's fine. And here 9, and yeah. So horizontally it has divided. So this particular part, let me use pen if I can use it. So this is your first part horizontally, and this is your another part vertically. Sorry, horizontally, right? So since equal number of columns are there, that's why it was able to split. Okay, so let's take a look at another one. I'm going to change the order, okay? Then we'll see what happens. Where is the mouse? Okay, so I'm going to give 4 by 3. So now this time 3 columns will be there and 4 rows. 4 by 3, and again I'm going to split it. Will it work? See here. It is going to throw an array. Why? Because array split does not result in equal division, right? So that is the reason it is very much important. Like you should have equal number of columns during horizontal split, Let me erase. Yeah. Okay, so remember guys, during horizontal split, same number of columns should be there, and exactly opposite for vertical split. Okay, so let's try to do vertical split. I'm going to comment it. So in this case, I'm going to take, because for vertical split, same number of rows should be there. So you see here, total number of rows are 4, which you can easily divide, right? So I'm going to put a dot vertical split, np dot v split a and 2 parts, right? Now you see here. So it will take the first, let me highlight once again. Okay, so in the vertical split, you are going to take this particular set of values, and another set of values will be this. So vertically it is going to be splitted, okay, in 2 parts, 2 equal parts. So since same number of rows can be done by using 4 number of rows, right? So definitely it is able to split. That's why you got 4 equal number of matrices. Okay, so let me erase it. Okay. Now, will you be able to split when you have 3 by 4? It is going to throw same number of same kind of error, right? So let's do that. 3 by 4, and here I'm going to split. It is going to throw same error, right? So that's how you understand about vertical split and horizontal split. I'll comment it, you guys can run it. Okay, so horizontal split, left to right columns, top to bottom rows. That's what we did here. Let me copy paste above. This was horizontal split, and now V split. Okay, so let's talk about stacking of arrays. So now you saw the split, right? Big array, you can split into either horizontally or vertically into equal number of arrays, right? Similarly, let's say you have 2 or 3 different arrays, right? How you can stack them up and make a single matrix, okay? So for that, I'm going to take small example, A equal to np dot array. And here I'm going to create a small array 2 by 2, and it is going to have 2 rows, 2 matrix, right? So I'm going to have 2 rows. So first row contains 1 2, and second row contains 3 4, right? This is my A, and B is exactly similar to this. So I'll take 5 and 6, 7 and 8. Okay, so here is your print, where it went. Yeah. Print A, print B. Okay, so A is 1 2 3 4 and B is 5 6 8. So these two are different matrices. I want to add both the matrices together, or stack them up and create a single matrix. Okay, so how you can do that? So there are 2 ways. Either you can do vertical stack or horizontal stack. So let's see the horizontal stack first. Horizontal is left to right. So we have np dot h stack A comma B. So what it does, okay, so number of argument has to be there in single. Okay, so you take left to right. So 1 2 3 4, that is first one. Let me highlight this one. So you see here 1 2 3 4, that is the leftmost, and rightmost will be 5 6 7 8. So the way you have written in that order, right, same order it will be stacking up. Okay, so let's take a look at vertical stack. Where is my mouse? Yeah, so all you need to do is instead of h, you just put v, vertical stack. So on the upside of the stack, right, the first array, whatever you're going to put, that is going to be put, and next will be your other array, right? So a will be on top and b will be on bottom. So you see here 1, 2, 3, 4, and 5, 6, 7, 8. That's how you're going to stack. So this will be helpful when you have large set of data divided into multiple part, right? So it is not just a, b, you can have multiple arrays. But remember, if you're having vertical stack, same number of columns should be there. If you are having horizontal stack, same number of rows should be there. Okay. Yeah, so other things we'll see tomorrow. Still lot many things are pending. So I have, as I mentioned, right, I'm going to break into 3-4 parts. Otherwise, in one shot, it will be too much for you guys. Okay, so I would suggest please complete this first, then let's work on other functionality. So we'll see tomorrow, like flattening array, repeat and tile, and other functions. I think we should be able to wind up tomorrow. Okay, guys, so happy learning. Thanks a lot for watching. So those who have not subscribed my channel, please do subscribe. Okay, and leave out the comment if you would like to see some other function, how it works, and what and all different examples you would like to see. Please comment on the comment box. Thank you. Bye bye. Guys, Pankaj here. Welcome back to my YouTube channel. In this video, I'm going to continue NumPy with part 3. So let's see where we left off and what we're going to have today. I'll share my screen. Okay, so in the last video, we saw creating a lot of different kind of arrays, then splitting the array, stacking up array, modifying arrays value. So in this video, I'm going to continue remaining topics. So we'll see how to modify different values or array of values or the range of value from the array. Okay, how to flatten the array, what is repeat and tile, append, insert. So whatever function I'm going to cover today, those are also very heavily and frequently used in the data science field. Okay, whenever it comes to machine learning or deep learning or data manipulation, these kind of things will be used heavily. Okay, so first let's see modifying range of values. So I'll create one simple array in p dot randint. You see here I'm going to use random again and again. Why? Because I don't want to write all the set of values manually. Random dot randint, then let's say from 1 to 50, I would like to generate 16 different values and reshape them with 4x4 matrix. Okay, let's print it. Okay, so what is the mistake? Sorry for the typo. Yeah. Okay, now we got one array, right? With 4x4. So here, let me use print. Okay, so this is 4x4 matrix and this is the shape. So in previous video, I told how to modify one particular value, right? So let's do a small revision here. So I would like to modify this particular value, right? So shop 20, I would like to have 22,000. Okay, so this comes under which row? It comes under first row, that is 0th row, and the first column, right? And you just do the assignment, correct? That's how you change it, right? Now 20 got replaced as 27. Now let's say you would like to change the range of values. So from this row, these 3 row and these 3 columns, I would like to replace. Okay, so let's say 31, 47, 19 and 31, 18, 18. This particular square matrix I would like to set as 0. So how to do that? Okay, so first you should know this comes under which row. It is coming in first row, right? So A of first row. So as I mentioned, let me just write here the syntax. Multiple values I'll mention. Okay, so here is your array, then here row, then after comma it will be column. Okay, so since you are accessing rows, so row is what? It list, right? So to access list or range of list of values, so all those methods will be applied here. Okay, so like you will have, what do you say, start, then end, then step size. So all rule remains same, whatever we have seen in the list. Okay, similarly for the column also. Okay, so we'll follow the same rule and let's do the modification. So this start from first row. So let's make from row first onwards. I would like to go with all the rows. So below 31, whatever rows are there, let's talk all. So I'll just mention this double colon or single colon, anything is fine. Okay, so my row is done. Now from column. So column is 0 and 1, right? So from first column, I want to consider all the column, right? So it will be considering this row onwards, every row, and from this column onwards, every column. Okay, I would like to make it as 0. Let's print it. Okay, so here I just mentioned one column. I would like to mention all. You see here, that's how you change the value. Pretty simple, right? So only thing is you just have to remember the syntax, how to access row and column. So I'm going to talk about more about this indices or indexing and slicing in the next session. Okay, now let's see next one, flattening an array. So how to flat the array? I'll create the same array here. So flattening array is nothing but you have a matrices, let's say, or matrix, which is having multiple rows, multiple column, right? So you got the matrix, you would like to make this as a single dimension array, right? Or you want to flat. So all the row and column will be combined together and it will form a single dimension array or normal list. So let me just print this array. So for this, we have one direct function called a.ravel. Okay, so this is a function. If you just make this, it is going to return the flattened array. Okay, so here if you notice, right, it by default it is row measure. So first it will take the first row 19, 31, 44, then it will go to next and next and so on. Okay, so this is called row measure. So I'll just mention default row measure. Okay, now let's say you want to have, so in another option, you can have column measure also, right? So how to do that? You need to give the extra argument. So I would like to get 19, 42, 149 as a first 4 element, then 31, 40, 31, 16 like that and so on. So here we have something called order, right? So you just mention order. If you don't remember, watch my previous video, I've talked about order. So by default, we have, I think it is Fortran style. Okay, so by default, it is having C style. Okay, so let me just mention. So to make it column measure, you just replace as C. C stands for C style, not the column style. Okay. You see here, it will take 19. Yeah, so by default, you already got. So to make it column, you need to have Fortran style. That is 19, 42, 149. That's what you see here. And after that, 31, 40, 31, 16, right? And so on. So that's how you flat the array. Now let's talk about repeat and tile. So repeat and tile is also very important function. So by which you can repeat one particular element or one set of array, the multiple array, and you can form the matrices using repeating the element. Okay, so I'm just going to create a dot. Let's say I have np dot repeat. So what it does, so repeat array. So my array is, let's say 1, 2, 3. Okay, then what it needs, repeats. I want to repeat them. Let's say I have only one element. Okay, I want to repeat them 2 times. See here, so 1 will be repeated 2 times. Okay, so this was single dimensional array. Let's say I have one array with 1, 2, that is first row. And second row will be, let's say 3 and 4. Okay, so see here what it is giving. If I repeat 2 times, so every element will get repeated 2 times. See, first row will have first element will be repeated 2 times, then second, then third, and fourth, and so on. Correct. So if you see here, by default, I'm not giving access, right? So by default it will flat the array and it will repeat all the elements, correct? So let's see some more examples here. X is equal to 0. Okay, so 0 is nothing but, okay, I'm going to talk about x's also later, but just remember x is 0 means column wise and x is 1 is row wise. Okay, so column wise like 1 2 1 2. So you see here it is like top to bottom. Okay, and if I give x is equal to 1, then it will be left to right, that is row wise. Okay, so first it will take 1. Okay, then it will take another, the second element is, so from second row first element is 3, right? That's why you see 1 3, another 1 3, then 2 4 and 2 4, 2 times it is going to repeat. Okay, so that's how repeat works. Now let's see the tile. Why it is not pasting? Okay, so let's go to the next. It is becoming slow. Numpy dot tile. Let's see this function what it does. So it needs one array and repetitions, right? So I have array of, let's say, I think there is a power outage. Okay, so tile, it needs one array, so I'm just going to create 1 comma 2 and I just want to repeat 2 times. Okay, so 1 2, the whole element will get repeated. It's not like earlier you saw, right? Okay guys, so let's see the tile now. So np dot tile, let's see what this function does. It takes one array argument, so let's create one small array, 1 2, and it needs the repetition. Let's say I want 3 times. Okay, see here, so in earlier example repeat was like it was repeating each and every element, right, with along with the axis. And here whatever array has been provided, first the whole array will be repeated those many number of times. Okay, so let's take another example. I'll take 1 2, then second row as 3 and 4, right, and repeat it 3 times. See here, 1 2 3 4, 1 2 and this 3 4, right? This the complete array one time, then second time, then third time. Okay, so let me just denote it. So if you're not able to see, this is what I'm talking. So first array got repeated one time, then second time, and this is your third time. Okay, so similarly, if you want, I can show you another one. Let me clear this annotation. Okay. So let's take another one. Okay, so 1 2 3 first time, then 1 2 3 second time, then third time, and so on. Okay, so that's how this tile work. Okay, so what else I can show here? Yeah, so tiling, you can do one more thing here. So right now we are just giving like these many number of repetition, right? So you can repeat with the help of a given shape also. Okay, so let's say I want to have 1 2 this matrix as 4 by 4 matrix, correct? See what is happening. So it is going to repeat 1 2 in such a way that you will be having 4 by 4 matrix. Okay, so 4 rows and 4 columns by repeating these element 4 times. Okay, so that's how you can do the tiling. Okay, now let's take a look at append, insert, and concatenate. So first we'll see append. So append, what it does, like list you have already seen, right? It will append only at the last. So assume that I have one p dot append. I'm going to create one array here, 3. Okay, so what it does, it will take the array. So I have already given array. It will take values, right? So I'm going to insert, let's say, since it is single dimension, so I can write one value only, right? I'll insert, let's say, 100 and axis none. So right now I'm not giving axis, so by default it will append at the end. Okay, now let's create 2-dimensional array. So I'm going to make 1 2, then 3 4. I hope it is recording. Yeah, so 1 2 3 4, and I'm going to append, since it is 2 dimensions, so I can give 5 6. Let's see what happens. So 1 2 3 4 5 6, since I am not giving any axis, right, so it will be flattened. Now assume that I am giving axis 0. So axis 0 is what? Column wise. So you guys can pause the video and guess and answer this. 1 2 3 4 5 6. All the input array must have same number of dimension. Okay. Oh, same number of dimensions. So I have to make it this. Yeah. Since this is part of two-dimensional array, right? So I have to make it dimension is 2. Otherwise, it is single array, right? Single dimension. Okay. So make sure dimension is always correct. Now let's say I make is row measure. What will happen? So all the input array dimension for the convention exists must match exactly, right? So what I have given, now I can insert it, append it at the 1 2 3 4, then 5 6, x is 1. So row wise 1 2 3 4. Oh, then I have to, because 2 rows are there, right? So I have to exactly make 2 rows. So 5 6, then comma 7 8. Otherwise, how you are going to append? Dimension has to, or shape has to be same, right? So 1 2 3 4. Then in the row wise I am adding, so left side by side 5 6 7 8. Okay, that's how we use append. So now you know x is 0 and 1 also. Okay, let's talk about insert. Insert values along the given axis before the given indices. Okay, so here it is also going to work same way the way we did in the list. So np dot insert. So let's see what and all it takes. It takes array and it takes object and the values. Okay, so insert values along the given axis before the given indices. Okay, so my array is 1 2 3. I want to insert values. So let's say at 0th position I want to insert 100. See here. So basically this object is nothing but it's a position of the index where you would like to insert 100. Okay, so let's take this was single dimension. I am going to take 2 by 2 now. So this is the first row element, then this is my second row element. Okay, and inside this I am going to insert, since it is 2 dimensions, so of course you need to insert 2-dimensional array. Okay, so 1 2 3 4, and I'm going to insert 5 6 as 0th position. Okay, so since I have not given axis, so of course it will be flattened array. Now I'm going to use axis. So x is equal to 0, that is column wise. See here, so 1 2 3 4, since I have given 0 position, so assume that you have not given any, this is the original array 1 2 3 4. So at the 0th index, this is the one which is existing, right? So now I'm going to insert something else at the 0th position. So what will happen? The original element, whatever is present in 0th position, that is going to be shifted by 1. Okay, so in 0th position now 5 6 will be there, and remaining array will be shifted by 1. Okay, now let's make it by 1. See here, So 1, 2, 3, 4, and I'm going to make it as row wise. So 5 and 6. That's how you are going to insert it. Earlier it was row wise. I mean to say column, and now it will be row wise. Okay, let's take the next one, that is concatenate. So join a sequence of array along an existing axis. Okay, so I'm going to define two array here. A equal to np dot array, let's say 1, 2, and I'm going to b, that is 3 and 4. Okay, so I'm going to use np dot concatenate. Let's see what it takes. It takes all the arrays, right? So all the arrays in the form of tuple a comma b. Let's see what it does. It will just concatenate, right? And what else we have? If you don't give access, of course it is going to flat the array. So in single dimension you are going to get 1, 2 and 3, 4. Now assume that I'm going to give access equal to 0. Of course it is single dimensions, you are going to get one flat array. And in case you are going to give x is equal to 1, see what happens. X is 1 is out of bounds of array of dimension 1. Okay, so let's make this as 2 dimension. 1, 2, 3, 4. Okay. Five, 6 and 7, 8. You see here. So 1, 2, 3, 4. So this was first row, this was second row. That's how we got it. And I'm going to add along with row, right? So it will be side by side. Now take the same example and make it x is 0. It will be top to bottom. Okay, so 1, 2, this is the first row, this is second row, and below that second axis, second array will come, that is b, 5, 6 and 7, 8. Okay, so that's how you concatenate. So let's see the next topic, that is arithmetic operation. Okay, there's again power outage. Yeah, so arithmetic operation. So guys, whatever mathematical operation you have done so far, right? Same thing you can do over list, n-dimensional array as well. Okay, so in this case it will be different, because whatever operation you are going to do on an array, everything is going to be done, that same operation is going to be applied over all the elements of the array. Okay, so let's create one array here, a dot array, say 1.2, sorry 1, then 3, 4. So this is 2 by 2 matrix. Okay, so I'm going to add print a plus 1. Okay, so let's say I'm going to add 1 to array a. So what will happen now? So 1 will be added to each and every element of a. Okay, so I'll print a, original a and second a. Okay, so is 1, 2, 3, 4. Now 1 will be added to each and every element. Okay, now let's take a look at subtraction. So 1 will be subtracted over each and every element. Okay, similarly you can do multiplication. I'll just multiply by 10. So every element will get multiplied by 10. Let's say you are doing division by 3. Okay, so this float division, and if you are going to do integer division or float division, you can use this. Similarly, you can use power. So you can do any operation. Okay, but remember, this is different than list. So whatever operation you are going to perform, it will be performed over each and every element of an array. Okay, so that is the beauty of n-dimensional array or Numpy array. Okay, there are a couple of other operations, so I would suggest you guys try that. Okay, like modulo, then any other operation if you want. Now let's see the indexing and slicing. How indexing and slicing works in the array. Okay, so I think this syntax I have already given in previous examples. So let's take a look once again. So you have array, and inside that, if you would like to access any element, you can do by this syntax: row number, comma, column number, then step size. Okay. So let's take one example. So I'm creating 1 to 10, test 16 element. I'm going to create 4 by 4 matrix. Okay, let's say you'd like to access the element, right? So of course, if you want to give 0, then what will happen? It is going to return me 0th element. So if you see here, right, if you are going to just create a list inside a list, right? So Numpy array is what? It is basically list, so many lists inside a list, right? So you see here, outermost square bracket, that is nothing but your single list. And inside that, I have so many lists separated by comma. Okay, so what will happen? Basically, this is the first element, right? That's why I got first, and which also tells first row of a given matrix. Okay, so that's why when you give 0, means it is going to return the first row of the array. Okay, so let's write another one, a 0, and if you don't give column, so by default it is first row, right? Now after comma, you can have column value, right? If I give 0, means from first row I want first column value, that is nothing but your 2. Okay, similarly, let's keep watching. I want, let's say, third row to second column. So what is my third row? 0, 1, 2, 3, and 0, 1, 2. This is the 4. That's what you got, correct? So I'll not repeat each and every element, but I'm just going to show a couple of more things. So let's say you want to access all rows in but second column. You can give all rows in second column. So what is all rows? Second column, 0, 1, 2. This is your second column. But in this, I want all rows. So 1, 2, 5, 4. From this column, all the row elements are getting extracted. That is 1, 2, 5. Okay. Similarly, I want all rows, all columns. Okay. Every second element from each row, every third element from each column. See what is happening. 2, 5, 9, 5. Okay. Now you would like to reverse the whole array. Then how you do that? Column, column, minus 1. The way you reverse the list. Column, column, minus 1. Okay. So first all row will be reversed. So bottom row will be going to top and like that. Okay. Then rightmost column will go to the first column. So here C 6, 5, 5, 6, 9. 6, 5, 6, 9. That was your original array, right? 6, 5, 6, 9. Okay. So first you shift all the rows, then you column. Okay, so that is the basic of indices and slicing. Okay, guys, so let's go to the next one, iterating over an array. So as I mentioned, an n-dimensional array is nothing but list inside a list, right? So if you would like to iterate over an array, so let me print A. Okay, so the best way is you just put a for loop. Okay, of course, we are going to use for loop only to iterate. So for, so since you are going to iterate over each row of the array, right? So I will just mention row in A, print row. Now run. See here. So from array A, I'm going to extract each and every row separately and just print it. Okay, and after that you put another loop. So from each row you are going to extract another element. So each element from each row. So how you can do that? For lm in row print lm. See here, 2819 like that. Then you do whatever operation you would like to do. Okay, so that is the basics of iterating over an array. Now let's see most important thing is statistical function. So guys, I'm going to talk about a couple of statistical function. I'm not going to explain the formula and how it works, which I'm going to cover under statistics video. Okay, so for timing, just bear with me and just have a look what exactly it is returning and how to use that function. Okay, So I'm going to create one array here, a np dot random dot randint. See how frequently I'm going to use this function, and it will be heavily used over statistical functionality and machine learning and deep learning. Okay, so 1 to 50, and I want to generate 10 values, and let's generate 15 values and reshape them. Let's say 5 rows, 3 columns. Print them. Okay, this is the value. So let's take a look how this works basically. So you apply your array and apply the min functions. Min function is like in general available. You can just apply. So what it does, it will find the minimum of the whole array. So out of these 16 element or 15 element, what is the minimum value of that array? That is what is going to be provided. Okay. Similarly, we have a dot max, whatever is the maximum value in the array. Okay, that's what is going to be provided. See the beauty of NumPy. You just apply the function and rest of the job will be done. Assume that it was a normal list, what we have learned earlier, and you have to find min and max. Couple of lines of code you need to write, right? But here you just write a function and it will do the magic. Okay, and let's see. Let's put it here. Okay, now we have a min and a max, right? Now under a min, okay, first let me write it. A min. A min is nothing but minimum of an array. So it is basically same what we have used, but this is like very specific to NumPy functionality. Okay, it is going to return me same thing. From NumPy, a min of a. Okay, so if you take a look at a min function, what exactly it is taking? What are some other parameter? So it has axis also. Okay, and leave these things. We will talk about this later because where and all I'm going to use separately. That has more meaningful detail. Okay, so let's talk about this axis. This is very important. So as I mentioned, if you use a min function, right, as a whole array, it is going to return what is the minimum value of that array, right? But what if you are interested in the minimum value of each row, or what is my minimum value in each column? So that's where axis will come into picture. Okay, so as I mentioned, if you want column wise, axis 0 to be applied. Okay, column wise. So in each column, what is my minimum value? So in this first column, we have 6. In this column, we have 4. In this column, we have 4. Correct? If you want row wise, what changes you have to do? Just give axis 1. Okay, that is row measure. So that's why you see 1, 2, 3, 5. 5 rows are there. So 5 different values you see. So from where it is coming? From each row, it is fetching the minimum value. So out of 30, 39, 46, we have 30 as minimum value. Then 4, then 4, then 21, then 6. Okay, so like that you can use axis. Now let's talk about another one, argmin. So np dot argmin of a. So what it does basically, it is going to return, you see here, see the help. Return the indices of the minimum value along an axis. Okay, so since you have not given axis, it is going to return me the position of the minimum value. Okay, so this position will be like 0, 1, 2, 3, and 4. The fourth row is having minimum value. That's why you are getting 4. Let's talk about max. Okay, so 7th value. What is my argmax a. So return the index of the maximum value along an axis. So we are getting 7. So where exactly it is? Maximum value is 4, right? So 3, 3, 6. So it is going to basically a flat the array. Okay, so 0, 1, 2, 3, 4. That's why we got 4th position. Okay, and 48 is the maximum value. So 0, 1, 2, 3, 4, 5, 6, 7. That's why you got 7. Okay, you can read here once again. Return the indices of the maximum value along an axis. Okay, if you are going to give x is equal to 1, so from each row it is going to find the maximum value and return the position of that row. Okay, so let's talk about the first row. What we have? What is the maximum value? 0, 1, 2. That is the second position. That's what we got here. Okay. Now in the second row, maximum value is in 0th index. That's why we got 0 and so on. Okay, so using an access, I can just put here. Okay, let's see mean, median, standard, and average variation. Okay, variance basically, not variation. Okay, so I'm going to have print A. I'm going to apply same thing. Okay, so A dot mean of whole. So it will calculate, it will sum all the element and divide by 15. That's what you got mean. Then we have what else? Median. Do we have median or not? So median is there. Okay, that is np dot. Did I write A? np dot median of A. Okay, so as I mentioned, this is globally available, right? You can use same way using np dot A. This should also work. Okay, so median is different. So I'll tell you how exactly mathematically it is working. So just remember that how to use the function right now. Then we have variance, right? So you can use standard deviation and variance. Okay, then we have variance of A. Okay, so that's how you get as a whole. Now, what if you want to do, or if you want to calculate standard deviation using x's along with the axis? So same way you can just put x's equal to 0. This will be column wise. If you give 1, it will be row wise. Okay, so that's about these basic standard deviation and all other statistical function. I'll be talking more about this in a different video, that is statistical video. There I'll cover in detail like how those functions work, what is their formula, and how to calculate it manually. Okay, now let's see PTB, what it is. np dot array. Let me create simple one. Random dot value between 1 to, let's say, 50. I want to have 10 values. Reshape 2 rows and 5 columns. Okay, now I can use a dot p dot ptp a. So what exactly it does, basically it is just difference between maximum and minimum value of that array. So max minus min to be returned. So what is my maximum value? 36, and minimum is minimum, do we have 0? Oh, 37. 37 minus 1. That's why you got 36. Okay. Similarly, we have percentile. So percentile also I'll explain later with the help of formula how it works. np dot, let's say we have formula called percentile. Then you can use the given array, right? Okay, so from percentile of which array? A, and I want, let's say, 50th percentile. What is my value? So in 50th percentile, you are getting 18. There is some formula to get the percentile. So I'll just prove it in the statistical video. Then you will understand what it is. Okay, if you really want to know now, then you just Google it. There is a small formula which will help you to understand. Okay, now let's talk about histogram. So basically, histogram is nothing but it just provides the frequency of occurrences of those value in a given array. Okay, so let's say you have a different color, different balls of different color, right? So let's say I have, out of 50 balls, you have 4 blue color and 10 pink color or 9 green color and so on, right? So you are basically creating a bucket of different color, and each bucket you are putting those colors, those color ball, right? So that is what is going to tell, okay, I have 3 green color, 10 pink color, like that. So similar kind of concept will be here, which will provide you the histogram. So I'm going to use a np dot ran int So let's talk about dice. Okay, I have dice between 1 to 6 number. I'll take 7 and I'm going to throw 10 times. Okay, and let's see what we are getting. Random dot randint. Okay, so out of this, I would like to see how many times we got 3. Let's throw a little more time. Okay, how many times I got 3, how many times I got 1, and so on. Correct. So for that, histogram will help you. np dot histogram A. See here. So if you see here, right, total values of what? 1, 2, 3, 4, 5, 7, and it is giving me the occurrences of those values. Correct. So this is nothing but because I have given by default bin sizes 10. You see here, bins are 10. So but I know in cubes, in dice, basically total 6 numbers are there, right? So I can divide them into 6 different bins instead of 10. Okay, so you see here, that's why 1, 2, 3, 4, 5. You will not see any number which is more than, let's see why it is giving 7. I think, yeah, that's okay. 1 to 6. If I give 4. Yeah, so in the 4 bins, so I'll have like 1 to 2, 2 to 3, 3 to 4, like that. Okay, so in different bins, this number is coming 10 times. Are we getting 10 times? So 1, 2, 3. Okay, so 4 bin, how we are going to divide between 1 to 7? I think I should take some other number that will help you to understand better. So let's say I have 1 to 10 number or 11. I want exactly 10 numbers. Okay, and histogram and give the 10 by default. Anyway, by default 10 it is here, and here I'm going to use 5. Okay, so earlier, since we are having 10 possible numbers, so I have created 10. So 1 to 2, 2 to 3, 3 to 4, like that, right? But if you give 5, right, so my bin size will be reduced. So I'll go with, like, earlier it was 1 to 2, now I'll go 0, 1 to 4, or 1 to 3, or 0 to 2, then 2 to 4, 4 to 6, like that. So total 5 bins will be there. In each bin, how many numbers will be there? So between 0 to 2, it may have like 1 2 times, or 2 1 time, like that, right? So in that way, we are going to get histogram. So I'll help you to understand this better by plotting the histogram in the matplotlib. Okay. So just remember these operations. Now let's talk about conditional function. This is also very important, and believe me, guys, this is going to be used very heavily in data science. Okay. Why? Because you have very huge data, and out of those millions of data, you would like to filter those values which is meeting certain criteria, right? So that's where this conditional function will come into picture. So one of the function is where. So let me create one small array. Randint. So 1 to 50, and I want, let's say, 20 numbers. Yeah. Reshape, let's say 5 by 4. Okay, so from this number, from this particular array, I would like to filter particular values which is satisfying the condition. Okay, so what you can do, np dot, there is function called where. Okay, so what it does, condition, what is my condition? Let's say a is greater than 20. Okay, and what else it takes? X and Y. So let's not worry about it. Return elements chosen from X and Y. Okay, so what it exactly does, you are going to just write a condition. So condition is, I have an array and I want to fetch those values which is greater than 20. See what it is returning. It is going to return me those values as well as their position, corresponding row and column position. Okay, the first value which is greater than 20, is it 20? No, it is greater than 20. Yes. So what is the position of this? It is there in the first row and first column. Oh, sorry, 0th row and first column. So that is what is 0th row, first column. Next value, is it greater than 20? Yes, it is meeting the criteria. What is the position? So this is there in the first, that is 0th row and second column, right? That's what 0th row, second column, and so on. Okay, so this is one way to filter it. Another way, or very simple way to filter, is use this one and store the output in, let's say, index. Okay, so this is what we got, correct? Now pass this index as a value or the parameter in the array. Okay, so this is very smart. It is automatically filter row and in a column index, and it is just going to return the value for which the condition is true. Okay, so if you remember, right, if you want to exactly get this value, what you do, basically you put in a square bracket and give the row indices and column indices, right? That's what it is going to do there. Okay, so let's see if we have any other way here to filter it. Okay, we have one more way. So instead of using where function and storing the row and column indices in the separate variable, what you can do, I'll just write out, put a and just combine this condition into single array. I would like to filter all the value of a where a is greater than, let's say, 30. Okay, this is another simple way to do that. Okay, so guys, let me just show one more thing here quickly. I'm going to plot this histogram. Okay, so for plotting, don't worry about the library which I'm going to use. I'm going to talk more about this in the matplotlib section. So in from as PLT. Invalid syntax, why? Oh, import. Okay, so you got it. So what I will do now, okay, I am going to use another function here, np dot bin count of a. Let me run this once again. Okay, so what it is returning? It is returning the count, right? X. Don't worry about this. Okay, count number of occurrence of each value in array in non-negative integers. Okay, so let's say I'll just store this as count and plt dot hist. I'll just give cnt. Then plt dot show. Okay, to make it more meaningful, now let me take some over 100 times. I'm throwing the dice with 17. Okay, now you see here. So since it is going to create 10 bins, right, differently. So what I will do now, here I'll give bin size equal to 6. That will make more sense. Okay, so don't worry about these numbers. These are nothing but the steps which is printed here, but you can just modify this later, which I'll show in the graphing. Okay, so you can get exact number like 0 to 1, 1 to 2, 2 to 3. So if you are throwing the dice, right, it is coming around 0 to 1, 1 to 2, 2 to 3, like 3 to 4. So that 3 number is coming very high. Okay, so if you count also, you will find 3 number has come so many times. Okay, so that's what histogram does. Yeah, there was a power cut. Let me share the screen once again. Okay, so we saw it, right, using where function or whatever row and column indices are returned, you can use them in the array. and filter a value where condition is true, or you can directly give the condition inside an array. Okay, so that's all about the where function. Let me see. We have something called this non-zero function np dot, let's say we have zero, right? Now we have something called np dot non-zero a. Okay, so what it is going to give, see here, 0 1 2 3 4 5, 0 1 2 3 4 5, right? So let's say I have some other zeros here. So it is going to return me the position of those value where values is not zero, okay, which is not equal to zero basically. Let me share it again. Yeah, so you can give np non-zero a. So it is going to return the position of where the value is non-zero. Okay, so 0 1 2 3 5 7, 0 1 2 3, then 4 is 0, so that's why it is not there. Then 5 is there, then again 6 is 0, then 7, then 0. Okay, so you can use non-zero also. So PTV, I think I have already shown you, so let me delete this. We have something called extract. Okay, so let's see how extract works. Okay, so here we are going to return, I'm going to use same array. A dot or np dot yeah, so what will be the condition? I have a equal to or maybe greater than, let's say 40, and what next? Array, right? So array is nothing but a. It is also going to do same thing. So whichever way you want, either using where function or direct condition inside an array, or using extract, or yeah, using non-zero, anything is fine. Okay guys, so let's see the next one, shallow copy and deep copy. I think still so many topics are remaining, so I think I'll wind up our copy, shallow copy and deep copy, then later we'll cover. Okay, let's say, I think shallow copy, deep copy I have explained in one of the Python tips and tricks part 1 or 2. You can watch there also, but let's say how it works in the Numpy array. So np dot, let's create that array 3 4 5. Okay, so here is your a, and let's say b equal to a I'm giving. Okay, so what will happen? B, if you see the array, right, what it does, copy equal to 2, it is exactly copying. So whatever changes you are going to make here in the B, same changes is going to be reflected in A as well. Okay, so let's change some value. Let's say B 0th row, 0th column, I would like to make this as 100. Okay, and print B. So print A, print B. Let's see what is happening. See here, you did modification only for B, but A is also getting reflected because it was copied, correct? Now, how to overcome from this problem? So let's say you don't want to modify, but accidentally it got modified, right? So we have something called copy flag, right? You make it just false, or you can do one copy. So this was shallow. This is known as shallow copy. So let me just write it here. Okay, so shallow copy means modifying array B will be reflected in A as well. Okay, so now let's say deep copy. So how to do that? So there are two ways to do that. I'll use B equal to np dot copy of A. Okay, then print B. Since I have already modified B, right? So now this time what I'll do, B, let's say 0th row, 0th column, I would like to make 500 and print B. So B got changed, but did we change the A also? It is still remaining the same. Okay, so that's how you can avoid modifying the original array by using copy option. And we do have option using copy true, but if you are passing an object, then it makes sense to use that. Okay, so I think that's all for today, guys. This is too much for now, and remaining topic I'll cover in the next video. Okay, I think very few are remaining, but I'll put more focus on these things, how to do that. I think it will not take much time. Okay, so that's all for today. Thank you so much. Hey guys, Pankaj here. Welcome back to my YouTube channel. Today I'm going to record last part of Numpy, that is Numpy part 4. So let's see what and all I have today. Yeah, so up to shallow copy and deep copy we saw, and linear algebra was left, right, and couple of more functions. Okay, so in the last video I showed how to modify the array range of array values, and one thing was left called ellipses. Okay, so this is something extra which you have not seen in NumPy as well as in the list also, right? It is supported only in the NumPy. So let me show you how to use that. So I'll create one array np dot int 1 to, let's say 20. I want 30 value dot reshape, let's say 5 by 6. Okay, so these many values I have, and A is the array. So let's say I would like to modify all the values of this, right? So there is a shortcut by using ellipsis notation. So how to use ellipsis? Just use square bracket and use triple dot. This means it includes all the rows and columns. Okay, and just do the assignment. That's all. You see here, this is very useful method, and whenever you want to use it, you can use. Okay, otherwise, if you want to go with row wise and column wise, so I have already shown you how to do that in this. Okay, so that is what is ellipsis. Okay guys, so let's start linear algebra. So linear algebra, we have a lot of matrix functionality. So I think we have already studied in 11th and 12th standard. So very similar thing we are going to show, we are going to see here today, but not all functionality, but very few functionality which is most commonly used in the machine learning and deep learning. Okay, basically most common matrix operation. So one of them is dot product. So first let me show you what is dot product. I'll just create small array. Three comma 4, then B is this. Okay, so guys, don't get confused. Dot product is different. Okay, and the other product which we do, like normal product operation, right? So how it does basically, let me print A and print B, then I'll explain. Okay, so if you are multiplying A and B, right? So normal A dot B operation, or maybe I can show A star B. This is your multiplication operator or mathematical multiplication operation. Okay, so what it is going to do, it is going to multiply one element or first element of first array and first element of second array, like one-to-one mapping will be there, and it's just going to multiply with that. Okay, that is what is your normal multiplication. Okay, but if you are going to do dot product, right? So there is a small formula here. Let me just show. So what it will do, it will just take the first row of first matrix and first column of the second matrix. Okay, so like here, let me just use pen. Okay, so the first row is nothing but this, right? In the dot product, first row of the first matrix and the first column of the second matrix, this will be taken, and this one will get multiplied with this one, then 2 will get multiplied with this, and addition of that will be the first element of the output array. Okay, similarly, first row will get multiplied by first column of second matrix will be multiplied by second row of the first matrix. Okay, and so on. It will keep repeating, and you are going to get exactly 4 by 4, sorry, 2 by 2 matrix. Okay, so if your input is 2 by 2 and multiplier matrix is also 2 by 2, then you are going to get 2 by 2 matrix. Okay, so basically a formula is like row, if you are having row, a number of column and number of rows should be similar. So m cross n equal to n cross n, like that it should be. So if number of rows and number of column is equal, then only you can do dot product. Okay, so let me clear annotation. I need to raise it. Okay, so we have direct formula for performing dot operation. So we have np dot dot, and it will take two matrices. Okay, that is A and B. So we have A and B. Just multiply. Okay, so I can just show you. So 1 multiplied by 1, that is 1, and 3 multiplied by 2, that is 6. 6 plus 1, 7. That's what you got here. Okay, then again 1 multiplied by 3 and 3 multiplied by 4. So 4 3s are 12 and 3 1s are 3. 12 plus 4. Sorry, there's 3 and 4, right? 1 and 3. Oh, sorry, 3 and 4. 12 3 15. Yeah, that's how you got 15. Okay, similarly you can repeat with other rows in other columns. That's how you do dot operation. Okay, now let's see eigenvalues and eigenvectors. So guys, remember eigenvalues, eigenvectors. So there are a lot of theory involved, but I'll tell you where exactly it is used. Okay, so let's say you have 2D plane and you have one particular, vector. Okay, or one particular point there, and you want to expand the point in a one particular direction. Okay, so definitely horizon is going to be increase or decrease based on the movement, correct? So let's say you have 2D plane and you're just moving the point from one direction to other direction, right? So eigenvalue and eigenvector will have like up to what magnitude you are moving and in which direction you are moving. So eigenvalues are nothing but the magnitude of the point, like up to what factor it is moving, and vector is in which direction it is moving, left, right, up, down. Okay, so I'm just going to show how it is getting calculated, and you can read the theory a little more so that it will be helpful for you. So I'm going to create one small array here. np dot array 3, 4. Okay, so let's say 1, 2, 3, 4 you have, right? So if you are going to move this point to a certain direction, then up to what magnitude, right? And what vectors are there? So we have something called np dot linear algebra, and under this we have eigenvalues. Okay, so Eig of A. Okay, so if you take a help here, right? So what it does, compute the eigenvalues in right eigenvectors of a square array. Okay, so it is, if you see here, it is returning 2 array. So basically 1 is nothing but your magnitude. Okay, that is nothing but eigenvalues. So I can give EV and eigenvector. I'll just give val and vec. Okay, so here is your eigenvalues, eigenvector. Okay, so this is about eigenvalues and vector. That's how you calculate it. Let's talk about determinant. So determinant is what? So again, I'll take one small matrix and I'll show you how it gets calculated. It's very simple operation, what you can call the formula. Okay, so for determinant, what will happen? It is going to take, let me annotate once again. Okay, so it is going to multiply this 1 with 4, okay, and subtract by multiplying these two. 3 into 2. Okay, so 4 ones are 4 minus 3 twos are 6. Okay, so 4 minus 6. Okay, so let's take a value of this, how much we are going to get. Okay, so let's go to next. NP dot linear algebra, then determinant of matrix A. Okay, you got 4, 1 for the 4 and 3 to the 6. So 4 minus 6, that is minus 2. That's how you calculate determinant. Okay, so similarly we have inverse matrix. So there is a property of inverse matrix. Okay, so what it is, the inverse of a matrix means if it is multiplied by the original matrix, it is basically dot product. Okay, original matrix, it results in identity matrix. So I showed you identity matrix, right? It will have diagonally once only. Okay, so I'll just take similar example. Okay, so let's calculate inverse. I'll just store in INV and np dot linear algebra dot INV of A. Okay, now what it is telling, if it is multiplied by the original matrix, what is my original matrix? A. Okay, so let's take a dot product of this. So INV np dot of INV then A. Okay, let me just change it. Okay, so yeah, so if it is multiplied by the original matrix, it results in identity matrix. Okay, so maybe I can just show you the help also. So given a square matrix A, return the matrix A inverter. Okay, yeah, I think that should be fine. So this is almost e raised to minus 16. So it is almost negligible value, that is 0, right? So you see diagonal values are 1 and 1. That's what is your identity matrix. Okay, so if you are getting identity matrix after taking dot product with original matrix along with the inverse matrix, and you are getting identity matrix, means you have got the right value. Okay, so that is what is inverse matrix, and this is the proof of this. Okay, next one is polynomial equation. So what is polynomial equation? So let's say I write 1x square or x square plus 2x plus 3. So this is my polynomial equation of order 2, because the maximum root of maximum square of that value I have is 2. Okay, so order of 2. Similarly, you can write, let's say, x cube plus 2x square plus 3x plus 4. Okay, so this is order of 3. Okay, so how this order is defined, basically how many x's you have or the factor you have. And similarly, you can calculate using the like what is the maximum power value you have. So here we have 2, so it's the order of 2. Here we have 3, so it's order of 3. Okay, and this will be in decrement order. Okay, so let's see how you can calculate it. So again, we have np dot only one dimension. Okay, so you see here it needs C stands for coefficients and R stands for root. So whichever you want. So if you are giving root, then root you can make it true. If you are not giving, that is coefficient. Okay, so assume that I am giving coefficient as, let's say, I'll take the same example. So I'm taking 1, 2, 3. Okay, so this is going to return a polynomial equation. So I'll just print P. Okay, you see here how you can represent x square. This is what we saw, right? 2x plus 3. So this x on top of x, you are seeing 2, that is nothing but x square. Okay, then you can have p dot c. So coefficient of p, we have 1, 2, 3. That's what we have passed, right? Now root of, do we have root? Yeah. So there is a formula to calculate, right? So I'm not going to explain the formula and all, but yeah, you guys already know how to solve the polynomial equation. So once you solve, this is what you're going to get. This is your root. Okay, so this is about this. Now there are a couple of other things. So I showed root equal to false, right? So in case you are showing root equal to true, so what is going to happen? You see here, p is nothing but your 3 2, okay, and this equation is going to be solved in this manner. So whenever you are passing this, then this will be like x minus 1 multiply by x minus 2 and multiply by x minus 3. If you are solving this, this is what you are going to get, okay, and this is going to return all the values. So coefficient will be returning this and root will be 3 to 1, and this is what you are proving, right? You are passing 1 to 3. That's what is your root. Okay, there is another thing in this. You can pass the variable. So by default it is taking variable x. You can pass another variable whichever you want. Okay, so let me just remove this. I can pass, what is the name, variable equal to, let's say I pass z. Okay, so in this case, how you're going to get the polynomial equation? You see here, instead of x you want to use z, so you can pass the variable name. Okay, so now let's say after generating the equation, you would like to solve the equation by passing some value. Let's say my z value is 5. Okay, so with respect to 5 value, what is going to happen here? So what you can do, you can just pass p of 5. Okay, so in this z, 5 z is going to be replaced by 5. So 5 square, that is 25, plus 5 into 2, that is 10. So 25 10, that is 35, then plus 3 30. That's how you're going to solve it. Okay, so that's all about, guys, polynomial equation. Let's see the next one. Yeah, so now we have sine and cosine value, right? So these things will be very helpful when you are going to do some kind of signal processing, right? Or any functionality where exactly sine and cos function is required. So we do have inbuilt sine and cos functionality. So let's have a look. So to calculate sine cos, I remember, if you guys remember, I have shown one function called linspace, right? So between, let's say, 1 to 2, I am going to generate 50 linearly spaced values. Okay, so how to generate it? A equal to np dot linspace between 1 to, let's say, 10. I want 50 values, right? Yeah, so now I'm going to get the sign of this particular function. So we do have s equal to np dot sign of a. Okay, so it is just taking each value as angle and it is calculating the value. Okay, so this doesn't make any sense to take a look, but if you plot, then it will make a lot sense. Okay, so sine 0 is nothing but 0 and sine 90 degrees 1. Okay, so let's see, we can visualize it. So I'll just take this as y value and x is your linearly spaced value, that is a. Okay, so instead of x, I'll give x. Okay, here I am going to give x. Okay, so let's plot it. So we have, for plotting, we have import as plt. Okay, let's plot it. So plt dot, don't worry about the plotting, I'm going to explain in detail when I talk about how to visualize the data. Okay, I'm just going to show how sine and cos you can represent. So I need x-axis and y-axis. Okay, then plt dot show. Okay, so this is your sine. So let's do a little more customization. Plt dot figure dot fixed size to 16 by 4. This is like your resolution. Okay, 16 width and 4 is height. Okay, couple of more customizations. So I would like to go with let's say diamond, or diamond with dotted line, and let's say color as red. Okay, Okay, and let's take another value here. So now I'm going to plot x. X is your sorry, y is your sign, right? And let's take a couple of other functionality here. So I'm going to plot, let's say, negative of this. So I'll just take y1 and negative of sin x. Okay. So I can plot it like this. I will give y1 and let's give as black, blue. Okay. And you can take different values differently. X. Okay, so that's how you calculate then sine and cosine. So you can use definitely cosine also. Let me add cosine functionality here. So I'll take y2 and let's take a cosine of x, right? And let's plot it here. You can plot as many as possible. So this is your y2 and this take as magenta color. Let's take it rectangle. Okay, so cos 0 is 1. So you may see 1 here. Where is 1? Did I give the right value? Oh, I gave the negative, right? So let's make it positive. Okay, now let's plot it. You see here, it is exactly starting at 1, right? So x and y2 is your cos x. Yeah, that's fine. Okay, guys, so that's how you calculate. And I think I have not given 0, right? So yeah, that is a problem. So let's start value from 0. Okay, then you run. So cos 0 is 1, sine 0 is 0, sine 90 is 1. So you see here exactly 90 degree, right? And cos 90 is 0. So you will see exactly opposite. Cos 90 is 0. That is your magenta color. Okay. So this is just for an example, a small example how you calculate sine and cosine of given value. You can plot, that will make more sense to visualize it. Okay, so now let's see next one, input and output in NumPy. So this is nothing but like whatever NumPy array you have created, whether you will be able to store in your disk or not. Okay, so let me show you how you can store it. So we can create np dot equal to np dot num dot rand int between 1 to let's say 100. I want 50 values and let's reshape them by 5 rows, 10 column. Okay. Okay, so how to save it? So we have direct function called np.save. Okay, if you save here, you can give the file name. So let's say array dot, you can give any name since it is numpy file we are going to create, right? So I can give npy numpy file. Okay, then what is the next parameter? That is array, that is your a. Okay, and these things you can just default. Okay, allow pickle true, whether you can access later or not. Okay, so let's save it. So now file is saved. Let's see whether it is saved. Array.numpy. If you open here, see what is happening. You cannot open. Okay, because this is in a binary format. So it is saved. It is created a file. So this will be very helpful when you are, let's say, creating a model where some kind of array is stored, right? So instead of creating again and again, you can save very huge array in the form of file. Okay, and load it whenever it is required. So it will save a lot of time and space also. So how to load it? np dot load. I'll give the path. So we have the file path. So I'll just give, you can give dot in the same directory array dot npy. What else we have? I'll go with the default. Okay. And what is my array? This is what is saved in this file. Okay. So that is a way to load it. Now we have something called saving in a binary format. So let's see how to use it. Saving in binary format. So what we can do now, save as text np dot save np dot save not as actually txt. Okay, so what it takes, basically it takes a file name and x is nothing but your array, and you have a lot of other functionality here, a lot of parameters which you can control. So let's see. file name or file ender. Okay, so if file name ends with gs, the file is automatically saved in the compressed zip file. You can compress the file as well. Okay, but having said that, you have to have .gs extension. X is nothing but your 1-dimensional or 2-dimensional array. Okay, so I'm just going to give mpy bin file dot, what is the extension? Will it take directly text, or you can give anything, right? So I'll give text, and what is my array? A. So let's save it. Yes, it is saved. Okay, so this is your binary format. Okay, now let's see how you can fetch the data back from the file. So we have np dot load text. So again, file name is what? This, correct? Dot text. That's all. So you can read it back. Okay, so I think by default it is storing in the float 64. That's why you are seeing the float value. I think data type you see here by default is class float. So what I can do here, maybe I'll mention data type equal to int 16. Let it be like this. You see here. Okay, so it is up to you. Whenever you have very large file, I would suggest please use it wisely. Okay, otherwise unnecessary you are eating a lot of space. Okay guys, so that's about saving in binary format. Now let's talk about a couple of other important functions: finding null, non-null, and nan values. Okay, so here I'm going to create a array anp dot array. So why this functionality is very much required? Because let's say you have very huge array and there are a lot of null values, that is 0 or nan values, right? So how you can find it? Like how many such non-null values are there? How many nan values are there? Nan basically stands for not a number. Okay, so which I'll be talking in the pandas videos also. np dot random dot randint. Let's say I'm going to generate some zeros also, so I'm going with negative values. Let's say -5 to 20. I want 30 numbers. Let's say reshape with 5/6. Okay, so I do have a couple of zeros. Let me give 10. Okay, I'll take 50, 20, 5 rows, 10 columns. So I do have a couple of zero. Yeah, that's fine. So how we can see whether some null values are there or not? There are multiple ways, but I'll use some inbuilt function. A dot all of A. Okay, so what all means? Do we have all values 0? No. So if you see here, test whether all array elements along a given axis evaluate to true. Okay, so a input array object that can be converted to an array axis, and definitely it is going to return boolean true or false. Okay, so definitely not all values are non-null. I can use another function that is nothing but any. So it means, do we have any value which is non-null? Okay, so yeah, we do have some value which is null. Non-null values are so many, but do we have any value which is null? Yes, we do have. Okay, so let me run more. I want some little more zeros so that I can show you the count also. Okay, now this time we have something. Okay, so you got the detail whether we have non-null values or not, right? But let's say how to count it. So there are two ways to count it. Let's say I have a where this I have already shown you, right? Equal to 0. How many such values are there? 1, 2, 3, 4. Then if very large values or large set of values are there in array and you would like to count, right? So you can directly apply, since it is going to return array, you can use size. That is one way to do that. Total 4 zeros values are there. Now you can have another function called length, which is basically used with list. Okay, so with list also it returns 4. Now there is another way to do that. So A equal to 0. What it does basically, it is going to find all the zeros wherever it is present, and it is going to return true. Wherever non-zeros values are, it is going to return false. Okay, so now this Boolean array I am going to store in B. You can do this and print B. Okay, so in this I can do B dot sum. See, this is another way to do that. So how this sum works basically, true stands for basically 1, that the Boolean true is 1, and Boolean false is 0. Okay, so how many truths are there? Wherever true is there means you have 0. So total 4 truths are there, that's why you got 4. Okay, so this is another way of counting the null values. Okay, this is what I showed here. Okay guys, so yeah, that's all I had for NumPy. I know you would have got a lot of details, and you would have definitely enjoyed learning this functionality. I would say please try in your notebook also, learn all the concepts, and keep those functions handy available. Okay, because you are going to use it heavily in either pandas or machine learning or deep learning. Okay, especially OpenCV also, because image processing is nothing but dealing with your NumPy array or n-dimensional array. Okay, so let's see a couple of interview questions. So I think I've already covered, but let's highlight them. Difference between normal list and NumPy array. NumPy is homogeneous or heterogeneous. That is one thing. Okay, what do you mean by deep and shallow copy? I have shown with the example, so please watch that particular section. Okay, how do you reverse whole array? So this also I have shown by help of slicing. How do you filter a specific element of an array? This is also very famous question in interview. So you can definitely use the where function or directly condition inside the array. Okay, so guys, I'm going to repeat a lot of functionality of NumPy in Pandas also. Okay, because one limitation is NumPy is array, so it is going to have homogeneous data. Okay, but what you have data set where heterogeneous data is there, a lot of string, integer, float. Okay, so those kind of value, how do you handle? And definitely in data science, we are going to handle a lot of tabular data, right? And table is not just going to stick to one format; it is going to have a lot of other formats. Okay, that's where pandas will come into picture. So we are going to see pandas in detail with a lot of hands-on, lot of examples, and a lot of functionality. Whatever you have seen in NumPy, it is going to be recapped in pandas. Okay, so it will help you to get it recapped. Okay guys, so that's all from my side in NumPy. I hope you enjoyed this NumPy session. And I know it was lengthy, but this is very much required. Okay, it is going to build the base for all the further learning. Okay guys, feel free to leave all the comments in comment box and reach out to my Telegram channel. I'll definitely help you guys. Thank you and have a nice day. Those who have not subscribed my channel, please do subscribe and like the videos. Thank you. Bye-bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. In last video, we saw how we used NumPy for handling scientific data, and how to compute a lot of matrix operations, right? And main thing about NumPy was it was handling only homogeneous data, correct? But what happened when you have heterogeneous data? A lot of different data types are contained in a table format, right? So NumPy will not be able to do that kind of operation. So to rescue that, we have another library called Pandas. Pandas stands for panel data. Okay, so we are going to see that library, and this is one of the best library for handling any kind of tabular data. Okay, and be it any format, this library will help you to manage all kind of operation, whatever you want to perform. Okay, so let's see what and all I have today. I'll share my screen. Okay, so here is the PPT for Pandas library. So Panda is basically a Python package for data analysis. Okay, so as I mentioned, this is one of the best Python library for handling any kind of tabular data. Okay, so you'll see the magic, like what kind of simple operation you can perform with whatever big data you have. Okay, it provides built-in data structure which simplify the manipulation and analysis of data sets. Okay, so Panda is easy to use, powerful, but with great power comes with great responsibility. Of course, a lot of responsibilities will be there when you are going to handle big data. Okay, So we cannot teach, yeah. So why we have mentioned this, because it supports a lot of functionality, and what and all I'm going to show, those will be very heavily used and very frequently used. Okay, so I will not be cover all functionality, but whatever I'm going to cover, that is sufficient. Okay, so once you are familiar with all the basic operation, I would suggest please go back to this particular documentation of Pandas official website, and you can read about all other operations what I have not shown you. Okay, then it will help you to understand easily. Okay, so what are the basics of Pandas? So we will be talking about series data type, data frame, that is nothing but table data. Okay, so believe me guys, this series and data frame is very important concept. So if you understood this, then believe me, or I can bet you, you can handle any kind of data, okay, using Pandas library. So whatever I'm going to show, whatever example I'm going to show, please listen carefully and keep trying parallelly in your notebook. Okay, we'll see how to create data frame from dictionary or from different data also. Select column, how to select columns, how to select rows. Okay, so why I'm calling select column and rows, because if you see the Excel sheet, right, so there what we have, let me just open Excel sheet just for example. Okay, where it is. Yeah, so if you open Excel sheet, right, in the top header, what do you see? A, B, C, D, those are nothing but name of the columns. Okay, and if you have, if you see the left side, you see all the numbers, right? Those are nothing but your name of the row. Okay, so let's say if I have some data here, 1, 2, and here let's say we have 3 and 4, right? So in B column, I have 2 and 4, and column A, I have 1 and 3. Okay. And if I talk about the rows, so in row, I have 1, 2, and another row, I have 3 and 4. So in general, what and all database you are going to maintain, or whatever big table data you have, right? So everything will have at least column and row combination. Okay, so each column or each row combination, whatever you see a set of element, right, those are nothing but your series of element. So that's why this as a whole, if you see, this is nothing but a table, and if you talk about individual row or individual column, that is nothing but a series. Okay, so that is what we are going to talk. So if you just talk about this particular data, this is a data frame, and if I just talk about column A or column B or row 1 or row 2, that is nothing but a series. Okay, so that is what we are going to see in this session. Okay, so this is what they are talking, how to select column and rows. So right now I'm selecting by holding the cursor, but same operation you can do using Python. Okay, so we'll see how to do that. Okay, so to perform any kind of operation on series or data frame, you need to have library that is nothing but Pandas. So in general, we import using Panda, and we give alias as PD. This is standard format or most commonly used alias. You are free to use any kind of alias. Okay. So as I mentioned, it is used for data analysis, data manipulation, and data visualization also. Okay, so let's see a couple of examples here. So this is your Excel data. So this is a raw data. Okay, so here I can represent the whole data. So if you remember, right, we have seen in Numpy, and Numpy matrix is nothing but 3 rows and 4 columns. Just assume about this example. Okay, so if you are going to add row header as well as column header, then that will become your Pandas data frame. Okay, so that is what is shown here. This is your Numpy array, and I'm going to transform array into data frame, and I'm going to show this with the help of program. Okay, so when you convert into data frame, automatically row index and column index will be added, and I'll tell you how to manipulate these data also. Okay, so let's see Pandas series and data frame. So Pandas series is nothing but single dimension, that is 1D, and data frame is 2-dimensional. Okay, because it has rows and header. Okay, and series is nothing but either row values or column values. Okay, series is 1D labeled index array and can hold any data type. So when I say any, means it is heterogeneous data. It could have integer, it could have all integer, it could have all the string, or it could have float, any value. Okay. Now data frame is a 2D labeled index matrix and can hold any data type. Okay, and mix of data. That is the beauty of data frame. Okay, so in the whole data you will have a mix of like integer, string, and float, and complex values. Okay, in the text values, that is nothing but string. Okay, so yeah, I'm going to show, just have patience, just read about this, like, basic concepts. So Panda is essential concepts. A series is a name with Python list, dictionary with list as values. So you know how to define dictionary, right? So this dictionary I can convert into series. Okay. So what it will do, basically, it will take all the key as a name of the index, and the values will be your series values. Okay. Similarly, if you're going to create data frame out of dictionary, then all the key will be taken as a column names. Okay, and their value will be your series of column values. Okay, so similarly, now once you have data frame, you can do you can fetch one particular column or one particular row the way you did in the Excel. Okay, by using the index. So there are a couple of different methods. I'll show a couple of tips and tricks also. Okay, similarly, once you have data frame, you can filter all the values. How to filter, again, this kind of condition we have seen in Numpy, right? So basically, Panda is nothing but extension of Numpy with some enhanced functionality. Okay, so these kind of things you are already familiar in Numpy. We can put the index inside a index notation bracket and fetch the portion of the table by satisfying the condition. Okay, so how to select particular column? So yeah, you can definitely, all columns are treated as a key of the dictionary, right? So you can just refer as a key, and definitely you can use the square bracket notation. So this is one way of doing that. Another way, like, you can just using a dot notation also, you can do like df dot x1. Okay, so that will also return the column value. Selecting multiple columns, yeah, so if you are going to select multiple column, or if you are to fetch multiple columns from a given data frame, you pass all the column in the form of list. Okay, yeah, so let's see the example. This is not only limited to these particular topic what I just showed in the PPT. We have a lot of things to cover in the video. Okay, so let me close this. Okay, so let's import the library. Now from this video onwards, you will see I'll keep importing a lot different libraries. Okay, so in Pandas, we are covering NumPy as well as Pandas. The next we'll see visualization. So there are also another 3-4 library I'll be importing. Similarly, if you see in the machine learning, another 5-6 libraries I'll be importing. Okay, so let's import this. Import NumPy as NumPy NP, import Pandas as PD. Okay, so let's print the version of this. So I have 1.3.2. You will also have similar. I think this is the latest one. Okay, now you can print all the supported function of PD. The lot of functionality. So we will be seeing almost half of them. Okay. So first comes with data series. Okay, so let's see how to create series. So remember, guys, when I'm going to give the variable name address because this is series PD dot. So here, whatever function we are going to use, right, it is case sensitive. So the first letter of the function, that is series, will be capital, rest will be small. Okay. Yeah. So PD dot say specify data type. Okay, I'm not defining data type, that's why it is giving the warning, but that's okay. So this is how you create the empty series. So what it has a series data type, which is empty. Okay, and what is the data type? Float 64. This is exactly same as what we saw in the NumPy also. If you don't define any data type explicitly, it is going to take float 64. Okay, so let's create series with some list data. So I'm going to define a list called 1, 2, 3, and 4. Okay, so I can pass this list object in the series. So s equal to pd dot series, then l, then this. Okay, see what is happening. So this is my original data 1, 2, 3, 4, this series. Okay, so it is going to visualize as vertical. Okay, it's not like a horizontal list. It the visualization of data frame or series will be always in the vertical form. So series is one dimension, so that's why you see the data in one dimension. So what about this 0, 1, 2, 3? Okay, from where it is coming? So guys, this is nothing but your row header. That is what you see here. So in Python, we have starting with 0, right? That's why it is taken from that. I'll just put 1, 2, 3, and 4. You see these series value is having some row header, right? Row name, that is nothing but row number 1, 2, 3, 4. But this is Excel sheet, it is starting from 1. But if you talk about Python, it is always starting from 0. Okay. So in case you are not defining any row header name, then by default it is going to start from 0 to n minus 1. That is length of the value. Okay. So I'm just going to give as a tuple also. Okay. So it doesn't matter whether it is list or tuple, it should be series of values. Okay. Similarly, I can give, let's say, 4. So what will happen? As I mentioned in the previous video also, in Numpy data type object, if any of the data is having let's say you have all integer and except one value, that is string type, so everything will be casted to string type. That's why you see data type is object, but here it was integer 64. Okay, so that's how you create a series. Let's see how we can create series using Numpy array. So here also it is simple. I'll create a np dot array. Let's say I have 3 and 4. Okay, print a. This is your Numpy array. Now I'm going to create series pd dot series a. See here, exactly same. Okay, so that's about using Numpy array. Let's see how you can use the dictionary. I'm going to use a equal to, let's say, dictionary. I'll just mention d and a colon 1, then we have b colon 2, c colon 3, print s, sorry, it is d. Okay, that's how your dictionary looks like, right? Now let's create a series out of dictionary d. See here what is happening. So whenever you pass dictionary, right, dictionary is having key and value pair, right? So all the key will be fetched separately and that will be used as a row header. Okay, and their corresponding value against each key. That's how you get it. Okay, so this is like by default whatever operation you can do. Now let's see how to create series using index names. So by default we saw if you are not going to give index name, it will be 0 to length minus 1. If it is dictionary, all the key will be used as the index name. Now what if user wants to give their own index? So let's say I have one list equal to 3, 4. I'm going to create a series using list, but here we have one value or one couple of parameters. Okay, so let's talk about index. So index means user wants to pass the index name. Okay, and this index name will be exactly, user supposed to pass exactly same number of names as the length of list. Okay, so let's say I want to pass a, I want to pass b, c and d, because 4 elements are there. Okay, so if you don't pass, then what will happen? It is going to take 0, 1, 2, 3. If you pass, then it is going to take those names for the row header. Okay, now let's say what happens when you pass list number of index name. It is going to throw error. Length of values 4 does not match length of index 3. Okay, so I'll just comment it. Now let's say what happens when you pass more number of elements. Okay, so length of values 4 does not match length of index 5. Okay, so this also throwing error. Now let's talk about another condition here. Assume that I am just having one element and I'm just passing this. What will happen? This is correct. Now if I pass more, it is exactly same as previous condition. Okay, but there is one special condition where you pass only one value as a scalar. Okay, I think I'm going to cover here. Yeah, with the scalar. So that will be this condition. So when you pass similar kind of element, but rather instead of list or tuple, if you are just passing as a scalar, that is nothing but single value without any bracket. Okay, let's say I pass 40, but here I know I'm just having only one element, right? But let's say user is passing more than passing index names more than the given value, right? So what will happen? It is going to broadcast that single or scalar value to those many number of time, whatever number of indices are passed. Okay, so this is the beauty of with scalar value when you create a series. Okay, so of course you can pass data type also. So t type equal to integer 8. Okay, so this is again same as whatever we saw in the Numpy. Okay, so that's how you create different kind of series from different kind of elements. Okay, so now let's see how to do indexing and slicing in the series. So I'm just going to create again. Let's say 10, 20, 30, and 40, and 50. Okay, so my series is going to look like this: pd dot series A. Okay, and I'm not going to give any index name. Let it be by default. Okay, so I got 10, 20, 30, 40, 50. So how to access it? So whenever you have S, you just pass the index name. S0 is your 10, and S, let's say 3 is your 40. So that's how you do indexing. Okay, let's say in case of in case user is passing the index values. Okay, so I can, instead of writing this, right, I can just write this also. B, C, D, E. Correct? Now in this case, how you can access? S of A. See here. So there are two ways to access always. In the series, you have either index choice or using the index name. Okay, so if index name has been passed, you can use name also. But now let's say my S is now having index name, right? If I pass 0, then what will happen? Okay, this is very smart. So what it does internally, a series or data frame, they also maintain internal number. Okay, so that is nothing but your default number of indexing. Okay, so if index name is existing, it is well and good. If it is not existing, it is having default number, that is 0 to length minus 1. That's how you are able to access the first element of the series by using A or 0. Okay, so let's see other thing. If I want to access multiple element, so multiple index name you have to mention. So let's say I can mention A, then whatever order you are mentioning, in the same order it will be returned. Okay, so A, C, and D. You can get 10, 30, and 40. Similarly, you can give, let's say I want 0 onwards. Okay, or I want 2 onwards. This is also possible because now this is the index value you are accessing, but here it was index name. Same is not true with index. Let's try that. What happens? Of course, it is trying because everything is in serial. It is going to return all the element of the series. Okay, from A onwards. And remember one thing, guys. Here I was using index. So C, D, E. Correct? So let me show one more example. What I'm trying to show here. Let's say 2, 3, and 4. So if you remember the rule of indexing in list in Python, end index will always be excluded, right? So see here, 2 and 3 only getting printed. That is C and D, but not 4. Correct? So 0, 1, 2, 3. Okay. Now, but in this case, I can mention A to D. You may think D will be excluded. No, it's not like that. This is the index name. So A to D, whatever is coming in between, everything will get fetched and it will be returned. Remember that this might be asked an interview also. Okay, this is very important concept. Okay, so that's how you do indexing and slicing in the series. Okay, so let's do the next one, that is data frame. Okay, this is my favorite topic. I love data frame and handling or manipulating data using data frame functionality. Okay, so let's see how to create data frame. So data frame is nothing but, as just shown in the Excel sheet, it is just a tabular data which is having row header and column header. Okay, so how to create empty data frame? So I'll create a df equal to, so let's use this variable name df, that stands for data frame. Okay, so pd dot data frame df. Okay, so this data frame is empty and there's no column, there's no index, correct? So let's create something else using default option to create data frame. So I need to have some data, right? So now here random library will help you to create some random data, okay? And using Numpy Array. So I'm going to use a equal to np dot random dot rand int, let's say 1 to 50 or maybe 1 to 10. I want to have 15 numbers and let's reshape them by 5 rows, 3 columns. Okay, and let's print it. So this is your Numpy array. Now let's pass this array. Okay, I could have shown this earlier. Okay, I'll use this later. Let's go with simple one. Okay, so a equal to, let's say I have 1 2 3 4, df equal to pd dot. So again guys, here we are having data frame function, right? So d will be capital and f will also be capital. Okay, so here df a, then df. See what is happening. Now it is going to print a table. This table is nothing but having only one single column. So that is nothing but a 1 2 3 4. You see here. So this is having row header as well as column header. Okay, so my row header is 0 1 2 3 and column header is only 0 because I have only one column. So here how it names the row and column header, in case user is not passing any specific name explicitly for row and column, it is going to take length minus 1. Okay, so 0 to length minus 1, that will be the name. Okay, similarly we can have using list or tuple. I think this I already showed here. Okay, so I can create simple one also. pd equal to pd dot data frame. I can pass 1 2 and 3 and just give df. This is also fine. Okay, so that's about normal data, then list and tuple. Now let's create from Numpy array. So Numpy array, now I'm going to have 2D. Okay, it is 2-dimensional. So multiple rows, multiple columns. Now let's use this array. df equal to pd dot data frame of a, then print df. You see here. So 0 1 2, I have 3 columns. Okay, you see here 1 2 3 and 5 rows. Okay, 7 5 3 8 5. Okay, so if I'm going to write same thing here, let's say 1 3 4 5 6 7 8 2 4 4 and let's say 5 6 9 8. Okay, so this is my 3 by 5 array, right? Or 5 by 3 array, 5 rows and 3 columns. Exactly same thing I have. So my ABC is nothing but your column header, and here 1 2 3 4 5 is row header. But in case of Python pandas, we have 0 1 2 and 0 1 2 3 4 row header. Okay, so that's how you do that. Now in case I am going to create using same number whatever we have, so I will use ABC for column. So here we have two different parameters, that is index and columns. Okay, so index mostly we don't rename because let it be by default 0 to length minus 1, but most of the cases we do renaming of columns. Okay, so I have A, B and C. Let's use list. This is my way of creating list of ABC. You can write in a square bracket also A comma B comma C, anything is fine. Okay, A, B, C, this is my column. That is what you see in the Excel sheet, A, B and C. And I would like to go ahead with default for row header. Okay, and that's how you create the data frame. Now let's create a data frame using dictionary. So I'll create a dictionary of this column A, B. Let's take small one, okay? Then df equal to pd dot data frame d. See here what it does. It is giving error if using all scalar value, you must pass an index. So in this particular case, you need to pass the index also. Okay. So only in this case, when you pass a dictionary to create a data frame. So I'll pass index as how many values? 1, 2, 3, right? So I'll just pass, I can pass any number, right? My indexing will start from 100, 101, and 102. Okay, you see here. So A, B, C will be taken as key because in data frame, column name will always be treated as keys. Okay, and yeah, index header will be started from 100, 101, and 102. That's how you create data from dictionary. Now let's see the next one, attributes and methods of data frame. This is also very important. A lot of functionalities or methods or attributes are added for data frame to get a lot of internal details about data which user is using. So I'm going to create A equal to np dot one to, let's say, 50 or maybe 20. I want to have 30 values. Reshape 5 by 6. Okay, let's create a data frame of this A, pd dot data. Guys, be familiar with these functions. Okay, why? Because see, when I started learning pandas, right, I was feeling very, low, like, okay, I don't have data, how to create data frames and manipulating, right? So better you keep using random function very frequently so that you will have all the data available in handy. Okay, so that you just quickly create data, numpy matrix, convert into data frame, then you apply all the function. Okay, and later you just get the real-time data. Okay, that also I'll show how to get the real-time data or some sample data and read into data frame. Okay, so I'm just going to use A, and here I'll use columns equal to list. Okay, so this is my table A, B, C, D, E, F, 6 columns and 5 rows. Okay, so let's see what and all we can fetch from this div. So df, we have d types. Okay, so this d type is nothing but it will tell what kind of columns we have of what kind of data. Okay, so each column is of what kind of data type. Okay, so right now we have only integer, then you are seeing integer 64. Okay, let's say a column A is having integer 64, column B is having string type, so it will show A integer 64 and B equal to object type. Okay, and let's say column F is having float data, it will show float 64 as well. So I'll show once I manipulate the data. Okay, so D type is one thing. Then we have size. Size 30 is nothing but 5 into 6, that is total 30 elements are there. Okay, then let me put everything in one name. Print D types, size. Then we have values. So using values, whole data frame can be can get back into numpy matrix. Okay, that's what values does. Now we have, do we have D type? No. So since data frame is two-dimensional, that's why we have to use data type so that all column data can be written. Okay, now do we have shape? Yeah, shape is 5 by 6, means 5 rows, 6 columns. Okay, what else we have? Do we have item size? Yeah, items are nothing but your exactly a matrix. Okay, so this will create a generator or iterator by which you can iterate over it. Okay, that is one thing. Then we have something called df dot index. So index is going to return like what kind of values you have for your row header. Okay, since it is in serial, that is 0 to 4, so that's why it is giving start from 0, stop to 1 to 5, and step size is 1. Okay, you can have rows. I don't know row is there or not. Let me just check. No. So we have index, then we have columns. This is very important, columns. Okay, so I'll tell you why it is important, because whenever you want to iterate over each column, right, then better you get columns and you iterate using for loop. Okay, so this is not a function, that is the attribute. Okay, that's why you see index object is not callable. So it is not a function, it is just an attribute. Now similarly, we have one more function called keys. Keys is a function. Okay, so it is going to return me exactly same. Either you can use keys function or column attribute. It is going to return me the name of all the row column header. Okay, then we have something called describe. It's a function. It's a very important function. So this is also known as, or you can use a summary also, kind of. So what it does basically, it will take each column, okay, and it is going to return different kind of attribute detail. This is very important. Those who are going to do a lot of statistical analysis for a given data, right? This is the first thing you should run after cleaning your data. Okay, so I have how many values on each column it will show, including, sorry, this is excluding those number which is not a, or let's say, so what I mean to say here, let's say you have one column where 1 4 2 4 8, then it is empty, then something is 10. Okay, so if you see total size of this column is nothing but how many elements? Total 6, right? 3 4 5, including this empty, it is 7 values, correct? But in this particular count, only those numbers will be counted which is non-null values. Okay, so in Pandas data frame, this particular empty value is known as NaN, not a number. So this is also the one of the beauty of Pandas library. It automatically treats all the empty data as NaN. Okay, so please remember that NaN stands for not a number. So I'll show all those things when we deal with the real-time data. Okay, what is the mean value of each column? 9.8. How to get it immediately? That also I'll show. So if you see right at the end, describe is nothing but it is giving one data frame where my row header name is these kind of functionality, that is count, mean, standard deviation, minimum, then interquartile range, that is nothing but 25%, 50%, and 75% in the max. Okay, and column as it is, the name of column A, B, C, D, E, F. Okay, so we'll talk about this little more when we talk about real-time data. Okay, so describe is another function which you should be knowing it very well. Complete table data. Okay, now let's see the next one, setting name for rows and columns. So assume that what is my DF here? ABCDF, right? I would like to change name, one particular name of columns or rows, right? So how to change that? We have df dot rename. Okay, if we talk about rename, it gives a couple of attribute or parameter. How you can do that? So the best one is, let's say I would like to modify only the index row, index header. So you just pass index and pass the mapper, that is in the dictionary. So wherever I have one, I would like to make this as 100. Okay, wherever I have 4, like whichever row name is there, right? Only those things you can change. I want to make it as, let's say, B. Okay, so is it doing that? Yes. So I see whenever I get row name as 1, it is going to replace 1 as 100. And whenever I have row name 4, it is going to replace as B. So it is up to you how you are going to use it. Similarly, in the same function, I can give columns also. Columns equal to, so again, I will pass a dictionary. So I'm just mapping. Whenever I have A, I want to make this as ABC. Okay. Whenever I have D, I would like to make this as any name you use, DF. You see here. So my first column name is renamed as ABC and D renamed as DEF. Okay. So now another thing to about this function is, so whenever you do this functionality, right, it is going to make a copy of it and return the modified array. Okay. But what about this in case you would like to modify the original array itself? So let me do one thing. I'm going to print both df, okay, df and print and df again. Okay, so this is my original array, this is modified array, and again original array, right? But now let's say I would like to modify original array itself. So here we have something called in place true. Means internally I don't want to copy the whole data frame. I would like to modify original array itself. So by default it is false. That's why it is making copy. If you make in place true, means it will just modify the original array. Okay, but be careful while using this because you will be losing the original data. So when you are very sure you are going to do or you are going to update the original data, then only you should make it true. Okay, so now you see here in place. What is this? Sorry, I did not comment it. Okay, so since I'm going to modify, it is going to return none and it is going to update the original array. That's why you're getting this original array and after modification MCDF. Okay guys, so yeah, that's how you create the data frame and you update the column name and row name. Let's see the indexing and slicing. So I'm going to create the same array here. And df equal to pd dot data frame A. A, B, C, D, E, F. Okay, so for indexing and slicing of data frame, you should know how you can access it. So by default, whenever you take data right, even a normal human also, whenever you read the Excel, right, you will be reading all column wise data, right? So columns are nothing but your actual entity. Okay, in that entity, what kind of data you have, right? So in Pandas also, in Python Pandas also, whenever you read by default, right? So whatever name you are going to provide in df, let's say I'm providing A, right? So it assumes that you are trying to access column. Okay, so that's why, so each column is nothing but series of data. That's why it will be written as a series. You see here 11 9 8 5 16 and their row header name. Okay, this is one way of accessing. Another way is whenever you have name of the column, right, you can directly access using dot notation. So I'll just mention using dot notation. Okay, and this one is nothing but bracket notation. Okay, it is up to you guys. So I'll tell whenever we iterate over all the columns of the data frame, right, you may not be able to use df.a directly. Sometimes it happens, right? So that's where you have to use bracket notation. But if you just want to analyze the data of a given column, you are free to use anything. Okay, so let's see how to access multiple data. I'll use df dot, let's say I have A as well as C. Okay, so all the column names should be going inside as a list. Okay, so I want to have A and C. Okay, so what else you can do? See, by default it is accessing all the rows, right? So what if I do, let's say 0? Will it work? See here is an invalid key. So what is happening whenever you are accessing using bracket notation, you cannot pass the row header name, okay, or row header number, whatever you are using. Okay, for this particular thing you need to use log. or ilog. Okay, so LOC is nothing but it is like row or index header name, row or column header name, and ILOC is nothing but index based location. Okay, so let me show you how to access that. So for this df.ilog, LOC. Now, whenever you are using LOC, you can use A and let's say 0. What happened? Why it is not working? Okay. Oh, sorry. So first of all, whenever you use LOC, right? Let me just write the syntax here. So LOC, then I'll just mention data frame dot LOC, then bracket, and here it will come as row header name, row index name I would mention, okay, because this is label based. Okay, and after comma you will have column header name. This is your syntax. Okay, so now let's follow the syntax. So first will come 0. So 0 is my row header and A is your column. Okay, so you got 1. That is, so from first column I want first row, or from first row I want column A only. Okay, so that's how you access. Now let's say I want multiple columns in a different order. So I want column A and D, but only 0th row. Okay, so it is going to return A and D 0th row. Similarly, you can have, let's say this is also fine, because now this is nothing but your row level, correct? And as I mentioned in the series, in the row, since 0 index and all those things are maintained as a internal level, right? So 0 column, those kind of things you can use. Okay, now let's say I want only 0, then 3rd and 5th, then 4th row, or maybe 0, 4th row, or in any order, right? So what happened? Do we have, oh, 5 is not there, right? Yeah. So 0th row, 4th row, and 3rd row, but I want from column A and D. Okay, so this is another way to access. Now, can we access a column? Yes. Okay, because everything is in series, so you can just mention A till all the columns. Okay, so that's how you use LOC. But remember, guys, LOC, as I mentioned, it is location label based, right? So you need to use exact label. If you don't have label, then it is going through an error. Okay. So what if user doesn't, let's say you have data where your row and column headers are so big name, right? So this doesn't make any sense to use label based, because user will be tired to write all the names for the row as well as column. Okay. So to rescue that operation, you have something called ilog, that is index based location. Okay, so where is my df? Let's do that, df.iloc. Now here I'll be forced to use only index, not the label. Okay, so let's say I want 0th row and 0th column. Okay, that is my first value, that is 11. So what if you use, will it work? No, because we are forcing user to use index, not the label. That's why you see a location based indexing can only have integer slice. A start pointing is included and end point is excluded, because it is going to be index based. Okay, so let's talk about this. I want 2 to, let's say 5. Will it work? Yes. So 2 to 5 is nothing but your 0, 1, 2. 2, 3, 4, and 5. 5 is excluded. So CDE. That's why you got CDE. And from which row? That is 0th row. That is 9, 17, and 17. Okay. Similarly, whole data frame, if you would like to reverse, you can use column -1, the way we did in the list. This is also fine. Okay, Can we do transform? Let me see if we have. Yes, you can do that. So row will be converted to column and column will be converted to row. I'll just mention, sorry, not transform, transpose. Okay. So slicing I already showed. You can use direct way, the way you did. What else you can do? You have this, then what else? Slicing using label also you can do. Okay, but you need to use LOC. In case you're using ILOC, then I can use, let's say, 1 to 5 every second one I want. Every second row I want 1 to 5. Okay, and here I want 0 to, let's say, 4 every second row, every third row. See what will happen. Okay, so you can do some maths here why it is happening, but this you guys already know, like in list we have already seen, right? Every second row from 1 to 5 and every third row from starting till fourth column. Okay, that's how to do that. Okay guys, I think this is good enough for today because we have lot of functionality in pandas. So it is also going to be divided into 4 or 5 parts. Okay, so don't worry, I'm going to cover each and every pieces of pandas, and I'll make sure that you are perfect in pandas data handling. Okay, so tomorrow we'll see a couple of data frame visualization options which by default comes with pandas library. Okay, then a couple of other functionality. Yeah, and we'll see how to read the external data whichever is there in the like .text file or .html, or reading data from HTML web page and extracting the table. Okay, that also we'll see. This is very interesting. So those who are going to take the real-time data from the web page, right, that will be helpful when you understand this particular part, and how to export in a different file. Okay guys, so that's all for today. I hope you liked it, and please subscribe my channel if you have not done. And those who are not able to understand any of the part, then or whichever part you are not understanding, please leave the comment in the comment box or put your query in the Telegram channel. Okay guys, that's all from my side. Thank you. Have a nice day. Bye bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. In this video, I'm going to talk about Pandas part 2. In previous part, that is first part of Pandas, we saw how to create series, how to create data frame, what are various techniques for applying methods and attributes on series and data frame. Okay, so let's see what and all I have today. I'll share my screen. Okay, so after creating data series and data frame, let's talk about a couple of other functionality which you can apply over data frame. Okay, so we'll see how we can fetch top rows and bottom rows from the data frame. What are various visualization attributes? Okay, then what are other basic operations we can perform over data frame, like renaming columns, adding columns in data frame, adding rows in data frame, how to filter the data, using condition, using filter functions, what is the difference between size and count function, what are various descriptive statistics functions available. Okay, so let's see everything in detail. So first I'll show you how to see top rows and bottom rows. So why this particular things are required, because let's say when you have very big data set, right, and millions of rows and columns are there. So instead of scrolling through all the data manually or watching through manually one by one, right, it is going to take a lot of time, and it will be very tough also. Okay, so to overcome from that issue, what we have, there are a couple of functions by which you can just visualize top 5 rows, which is by default, and you can give, like, let's say top 10 rows also, and bottom 5 or bottom 10 rows. Correct. So let's have a look. So as usual, I'll just import numpy as np, import pandas as pd. Okay, now let's create some random data for our analysis. So I'm going to create one array, np dot random dot randint. let's say 1 to 50. I want to have 25 data, and let's reshape them with 5 by 5 matrix, that is 5 rows, 5 columns. Okay, and I'm going to create a data frame, df equal to pd dot data frame. Then what is my array? And let's give column names equal to list A, B, C, D, E. Okay, I think I should have a little bigger. So I'll add little more rows. So let's have 30 rows, 30 rows and 3 columns. So total 150 data set, sorry, 90 data set I want, right? So between 1 to 50, let's create 90 data and convert them to 30 rows and 3 columns so that I will have bigger data and visualize top 5 and bottom 5 rows. Okay. So sorry, I reduced the number of columns, right? So let's have ABC. Yeah, so these many rows, 30 rows and 3 columns, correct? So when you have, let's say your data set has grown up, right? So instead of displaying all the data set, right, it is going to occupy the full screen, as well as it is very tough to visualize, right? So what you can do, df dot head, we have direct function, so which is by default going to display top 5 rows. Okay, similarly you have tail, so bottom 5 rows you see here, 25, 6, 7, 8, 20, up to 29, and 0 to 5, 0 to 4. Okay, so by default, if you see, right, it is going to display top 5. If you are not giving, by default it is 5. So let's say you want to display only 2, just give 2, top 2 rows. And similarly here you want bottom 2 columns, bottom 2 rows, so that is also possible. Okay, so this will be very handy when you are going to have very large data set and you want to have quick glimpse of what my data set contains. Okay, let's see the next option. So again, when your data set grown up so much, right, so there are a couple of things which will be limiting your data visualization, right? So to unlimit data visualization, you have a couple of options. So let's see that. Let me correct this spelling. Okay, so we have a couple of things here. I'm going to create one data set again. Oh, let's have df only. So df dot get option. So first let's see what and all is set. So here basically you will be able to control like how many default rows and default column you like to visualize when you have very large data set. Okay, so get options, get option display, these are the attribute display dot max rows. Okay, is it options or option? Sorry, not df, actually pd. Okay, so by default it is going to display 60 rows. So what will happen when, let's say you have 100 of rows, right? So it is going to just display 60 rows. In case you want to display all 100 rows, right, so you can just change it. Okay, so similarly you can have max columns. So by default it is going to display 30 columns. Okay, so if you have large data set where 200 or 500 columns are there and you want to visualize all, okay, of course it is not a good idea to display all columns because it is going to occupy whole screen, right? So unnecessary, or maybe system or browser will become very slow. So better to go with some number where it is not affecting your performance of data visualization. Okay, so let's change some number here. So similar to get, we have something called set option. So this just give display dot max rows attribute, and here you pass the values. Let's say I want to just display 10. Okay, so 10. So 10, and now if you get the option max rows, let's run it. Now it is 10. Okay, so in case you want to display here, see what will happen. So I want to display only, okay, it is 10 rows, right? So you see here, automatically it has taken top 5 and bottom 5 rows, correct? Assume that you have given max, let's say 5 rows I want to display by default. See what will happen. It is going to display only max 5 rows. And this dot dot is nothing but continuation of all the rows. Okay. So that's how you change the option of max rows and columns. So similarly, you can change with columns also. I'm not going to show, but it is exactly same. Okay, guys, so that's all about data frame visualization change. Now let's talk about a couple of other basic operations with data frame. So we'll see how to rename the column. Okay, so I'm going to generate one data here. df okay, it has become slow. What I'll do, I'll just create a new array. Let's take default one with the small values. So I'm going to take 25 and 5 by 5. 5 by 5, and let's have DE. Okay, so now how to rename the column. So I think I have already shown it, but let's talk about this once again. So df dot rename. So here I'm going to rename column name, right? So I can just give columns, that is the parameter, equal to, and you just provide a dictionary. So I would like to rename A as, let's say, name, and print df. Okay, so it is going to make a copy of it, right? So what you can do, you can just take df1 equal to this and print df1. So now you see my column name A has been changed to name. Okay, similarly, if you want to change index, that is nothing but row header. So in my row I have 0 to 4, right? So I'm just going to give the index name, and I'm just going to give, let's say, row underscore 1. Okay, you see here. Similarly, let's say I want to give 1 as row underscore 2. Okay, so whichever way you want, you can do that, and you can pass simultaneously also. So not only just index, you can pass columns, just have the mapping. Okay, so I want to pass A as, let's say, name underscore 1, and similarly I want to have B as name underscore 2. Okay, so yeah, like that you can rename. It is pretty simple, but it will be very handy. And why this is required, basically, when you get the raw data, right, from someone and you are going to analyze, right? Sometimes what happens, people use very long name for the given data set, right? So in that case, you write a function to convert all the name with short name or abbreviation. Okay, so in that case, this will be very helpful for renaming the column and row header. Okay, now let's talk about adding columns in data frame. So right now my df is this data frame, right? Okay, so let's say you got some data, and after that you would like to add some more number of columns. Okay, so right now I have A, B, C, D, E. Let's say you did some processing, and after that, that processed output you would like to add in the given data frame. Okay, so as I mentioned, whatever column name or column header you have, right, it is treated as a key. So in dictionary, how do you add the key? Just write the key which is not existing. If you add the existing one, it is going to override the value of that particular key, right? The same operation is going to be applied in the data frame also. Okay, so let's see one example. So df, let's say I have column as z. Okay, and in case you don't have those many number of element, whatever is present already in the data frame, so it is going to be broadcasted or going to repeat in the same number of element as the length of the given series. Okay, so let's say assume that I have 100. Okay, so if you take any series, column series, right, you are going to have 5 elements, right? But here for adding new column, you are just adding 1 element. So what is going to happen? It is violating the rule, right? So what will happen? It is just going to be broadcasted or going to be repeated same number of time whatever you are presenting. Okay, so after that you just write df. You see here, so data frame is created and new key or new column has been added. Okay, that is one way of doing that. Now if you, let's say I'm adding another column as x. Okay, instead of 100 I am going to have 100 and 200. What will happen in this case? See here, length of values 2 does not match length of index 5. Okay, so either you give 1 so that it can be broadcasted to all number of rows, or you provide the exact number of element. So 100, 200, 300, 400 and 500. Okay, so let me add it, and so that you can understand why it is going to throw error. So I'm just going to comment it so that later you can run, and this is the way to handle it. Okay, so that's how you add the column. Now let's see the next one, how to add the row. So let's say now you have df as this. So to adding row, as I mentioned, by default whatever index you are giving in the square bracket, right, or bracket notation, it is going to treat it as a column. So to manipulate the row, you have to use ILOC or LOC. Okay, so df dot LOC, that is label based. So I'm going to add label, let's say row underscore 1. Okay, so here also it is going to apply the same rule like the way we did for column. So if I am just going to add, let's say minus 10, and after that I'm going to use df, it is going to add all minus 10. It is going to be broadcasted or going to repeat same number of element as you have in the one particular row. Okay, that is one way of doing that. Another way is use the same number of element. Let's say I have minus 10, minus 20, minus 30, minus 40. How many are there? 1, 2, 3, 4, 5, 6, 7, right? 40, 50, 60, and 70. Okay, so in this case, what I did, I used the same row, right? So what is going to happen if this particular column or key is already existing, it is going to modify the given values. Okay, if it is not existing, then it is going to add it. You see here. Okay, this is your one. Let's change another element as this. And this one I'm going to write. Okay, so you are going to have row 1 and row 2. That's how you add row and column as a new entry in the given data frame. Okay, so let's talk about how to filter data from a data frame. So there are two ways to filter the data from data frame. So one is like using the condition for given element. Okay, so you have data frame, all the rows and column, right? So row and column contains what element, right? It could be anything. It could be a string, float, or integer, or whatever. Correct. So put a condition to apply your element. Another way is use filter function to perform filtering over index and column. Okay, so let's see what I mean to say here. So I have df as this. So in this I'm going to filter using condition. Okay, so there are two ways to do that. Df. Okay, so I'll put a condition. Okay, so you remember in the numpy what I did? I was using where function or putting condition inside a square bracket, right? So that it will get the rows and index column indices. So based on those indices, whatever values are there, that is going to be filtered. So here I'm going to use df. So df where df is greater than, let's say, 20. Okay, so it is going to run a condition df where greater than 20 elements. So only for those rows and column where condition is meeting or satisfying, it is going to filter those number of rows and columns, and it is going to return those values. Okay, see here. So what is happening here? The first one is 47, that is greater than 20. Yeah, true. Second one is 20 for first element of column B. So what is happening? Is it greater than 20? No. So wherever condition is not meeting, it is going to put a attribute that is nothing but NaN. It stands for NaN, that is not a number. Not number. Okay, so this is how Panda is going to visualize the data which is empty or not meeting the condition. Okay, so that is one way of doing that. Another way, so what I'll do, I'll just use, let's say, df. See what will happen. So wherever it is, in case you are not applying the true condition, or the given condition is false or true based on that to the given data frame, it is going to return Boolean true or false. You see here. So returning Boolean true or false wherever condition is true. Okay, and this is what you are going to apply over this data frame. So internally it is putting true false for the given row and column, and wherever true false, it is going to return the value. Okay, so that is one way of doing that. Another way, so we have something like df dot where df is greater than, let's say, 20. Okay, so you can use the where function, so anything is fine. So but the best and short way is put a condition inside a bracket function, same way the way we did in the Numpy. Okay, so that's how you filter the data. Okay, let's see another one. Let's say you want to filter a data based on the index and column level. So you may have different kind of labels. Okay, so here we have something called, let's say, df dot filter function. Okay, let's see what it takes. So it is going to take items, okay, and like regex different kind of parameter. Okay, so subset the data frame rows or column according to the specified index levels. Okay, so specify index level. Let's say you are putting only what we have, A, right? So what will happen? So whatever label you are putting, if it is found in the data frame, only that particular thing will be returned. Okay, so let's say I have A or X, maybe what I'll mention, X or AB, just okay. So whichever is matching, X is also matching, A is also matching, B is also matching, right? So it is going to take that. If you mention XAB also, so whichever is going to match, it is going to return those columns. Okay. Similarly, you have, let's say I'm going to mention ROW. ROW, do we have? Yes. So wherever it is going to find ROW, it is going to return exactly that particular column. So in this particular column, there is nothing but your what do you say? Only the index column, right? Only index header. That's why it is going to return. Okay. So what other way is to do that? We have something called, let's take a help. So items are what? List like. Okay. So I can mention A, and let's say, do we have C? It is going to return AC. What else we can do? Okay, so we have something called axis also, right? So assume that you are not sure AC can be anywhere, right? So if you see here, I mentioned ROW also, right? So ROW name may contain in the column header as well as row header also, right? So what is going to happen in this case? It is going to return both, right? But let's say you want to restrict that particular search only in the given axis. So if I just mention x is equal to 0, it means wherever I have column, only in that case it should be returned. But I don't have, right? That's why I'm getting empty data frame. If I'm going to give x is 1, guys, these things are very important, because once we do exploratory data analysis, like these things we need to play. Okay, so don't worry what and all function I have going to explain, or whatever I have explained so far, almost 90% of those will be repeated in the EDA part. Okay, or from now on it is going to be repeated, because I'm going to explain EDA as well as some case study or some project, right? So everything will be repeated. Okay, so x is 1, what I have, ROW and ROW2, correct? So what else we have? So regex you can use for regular expression also. Let's say you have very big name for row and column header, right? So there you can apply the regex. In this example also we'll see. Okay, so let me take this kind of example. So 1, 2, and 3, right? So I'll just create another data frame. df equal to data frame. I'm going to have one dictionary here. 1 equal to 10, 2 equal to 20, and let's say so I did some random name, okay, 30, so that I can apply a regular expression function. Okay, so what is my df here? Let's remove this. Okay, so I need to pass index also, because as I mentioned, whenever you are creating data frame over index using dictionary, you need to pass the index also. So I'll just pass 0, 1, and 2. Okay, so 1, 2, this, and maybe I'll just pass ROW1, ROW2, W3. Makes sense. Okay, now apply regex. Df dot filter regex equal to, let's say I want to filter only those. I mean, I want to get a data frame where this particular label is matching. So let's say I have BBI. Okay, do we have something? Yes. So it is going to filter exactly that particular column where BBI XYZ is matching. Okay, this is what I gave, right? So let me add one more column here so that you can understand how this particular regex is working. So I want to have BBI, let's say 1. Okay, but when you are running this, it is going to match only BBI. Okay, so it is having BBI and BB1, right? But let's say I have here, it could be I or 1. So I can just put I1. Let's see what it gives. Okay, so those who doesn't understand how this regex is working, please watch my regular expression video. Okay, so what exactly it is doing? It is going to match B and B 2 times exactly, and after that it could have either 1 or I. Okay, so in my data frame, exactly two kind of column headers are present, that is BBI SYZ and BB1 SYZ. Okay, that's why both are getting matched and both are getting returned. Okay, let's give OR. If I give ROW, or exactly I want ROW, what will happen? See here. Okay, so this has been matched, that's why you are getting this. Or in case you are giving ROW, let me take another example. Because first whatever you are adding in the OR condition, right, whichever is matching first, that will be returned. So ROW is not there. Is it 0 or okay? Yeah, this is fine. Now let's talk about this. We do have ROW, but I did not give the index, right? So what I can do here, okay, I need to give an axis, right? So by default, it is taking this one. I can give x is equal to 1. Okay. That's fine. Yeah, so while giving x is equal to 0, you see here ROW is matching, that's why you're getting ROW. Okay, in this particular case, first condition is meeting true, and that's why it is giving column wise. Okay guys, so that's how you apply the filtering. So we saw two kind of filtering. One is like index wise, so index level or column level, and one was element wise condition. Okay, so whichever is required based on your need, please use that. So now let's see very basic thing about size and count function. So you may get confused sometime, like if I provide a size attribute for a given data frame, it is going to return total number of elements. Yeah, that is true. It is going to return total. When I say total, means it includes NaN, that is not a number. So let's say you have one series or complete data frame, and let's say out of 100 values, only one value is non-null, that is any number which is a number. Okay, and rest of the 99 values are NaN, that is not a number, means it could be empty or it could be a string also, or it could be just NaN on the not a number, or it could be empty data in the data frame. So when you apply size, it is going to return exactly 10, but when you apply count function on that data frame, it is going to return exactly 1, because count by default counts only not a number, which is basically non-null values. Okay, so let's see the example here. I'm going to create. Okay, so df dot, let me create a small matrix here. 1 to, let's say 30. I want to have 25 numbers. You guys see how many times or how frequently I use random.random. Okay, because I want to have random data. 5 by 5. df equal to pt dot data frame a, columns equal to list, then a, b, c, d. Okay, so I'm going to add some more NaN values here. So let's do that. And how to do, I have already told how to manipulate the data. Okay, so I want to manipulate this particular data. Let's say, so this comes under third row and second column, right? So let's go with the label wise. LOC, what is my row? 3, and what is my column? That is B. I want to have NaN. So you can have NaN variable by using np.nan to set NaN. Where is B? Oh, sorry. Okay, so let's change one more time to something else. So I want to have, that is 0th row and column E. Okay, so now you see I had total 5 row 5 columns, total 25 value, right? So let's talk about size and count. So guys, first you remember that size will see what it shows. It is going to show total number of element. Okay, so if you talk about overall data frame or overall table, right, you have exactly 23 values and 2 are basically empty. Okay, so whenever you want exactly total how many entries are there in the data frame, remember how many entries are there in data frame, use size. Whenever you want to see how many exactly non-null values are there, use count function. Okay, so let's see. Okay, so this clearly tells in column A I have 5, column B I have 4, but in column B also I have 5 values, right? But why it is being 4? Let's talk about the help. What it tells. Count non-NA cells for each column or row, means count only non-null values. Okay, counts, I'll just mention counts only non-null values. Please remember that this may be asked in the interview also. Okay guys, so that's how you differentiate between size and count, and this will total number of entries in data, or I would say data frame, including NaN. Okay, so I hope it is clear, and please be firm on this. Okay, Whenever you want total number of elements, including NaN, use size. Whenever you want to have only those elements to be counted, where non-null values are there, use count function. Okay. So let's see descriptive statistics. So a lot of functions are there which you are going to use very heavily, and I'm not going to explain the formula running behind the function because I'm going to cover under statistics. Okay, so let's see how to use and how to understand those functions. So I'm going to have df that is already there. Okay, so let's talk about minimum. So minimum is nothing but it is going to return minimum value of each column. Okay, so you can use df dot min, so it will be applied over the whole data frame, and for each column it is going to return minimum. Okay, so a minimum values, what is that, 2. For b we have minimum as 1. For c what we have, it is going to ignore nan. Okay, you may think okay nan is a 0, it's not like that. So minimum value is 1. But if you take a look here, skip na, right? By default it is none. And what else we have? Can we set true? Yeah, it is boolean, right? Let's talk about this. So what happens if you are going to set skip na as false? Does this value going to change? Let's talk about this. You see here, so nan basically definitely it is kind of treated as null or 0, so that's why you are getting none value. But by default it is true, so it is going to return, sorry, it is going to skip nan and it is going to return other values, minimum of other values. Okay, so similarly we have df.max. Okay, so you are going to get these value by default as column, because that is what mostly our data set contains, all the column like feature name, and from that feature what is my minimum value. But let's say you want to have or you want to get counted all the minimum or max from the row side also, right? In case there could be some scenario where row wise also you would like to count, so for that you need to control the axis. So by default it is axis 0, you give axis 1. Okay, now you see here, so for first row that is nothing but this row. In this we have minimum value is what, 8. Do we have 8? Oh, I'm counting max, right? So what is my max value? 29. And the next row I have maximum value is 25, then 20, and so on. So 29, 25, 20, and so on. Okay, so but remember guys, these things are required only when you have very specific data where row wise also you would like to have some operation to be done. Otherwise 99%, or I would say 98%, it is going to be performed under column. Okay, so count I already told you guys, but let's see once again. So we have df. So let's say you want to count on a particular column, right? So what you can do, df dot a dot count. Okay, so earlier we used df dot count where it will be default, by default it will be returning for column wise count. But in case you are interested on one particular column, use df dot a. Another way to do that, df dot a dot count. So I have already explained about dot notation as well as square bracket notation. Okay, now let's talk about min. Df dot, sorry, not min, mean. Mean is nothing but it is basically summation of all the given values and divide by those number of values in a column. Okay, so column wise it will sum all the values and divide by 5 because 5 elements we have. So df dot mean, and let's say I want to have mean of a, you can just use df dot a. Exactly this is what we got, right? Okay, so based on the need we'll be using either our whole data frame or one particular column. Similarly, we have median. So I'll explain about what is the difference between mean and median in my statistics video. So df dot, we have median. Okay, it may be exactly same as mean, but there is a significant difference. Okay, theoretical difference is there. I'll explain about it later. Similarly, we have df dot standard deviation. Now we have variance. Df dot, it is square root of standard deviation. So where, okay. Now covariance, let's see what is covariance. Okay, so 40, 62. So this is basically, again, there is a separate formula. Let's not talk about that. It is not the agenda of this video. So just remember these functions are available, and just remember those things because it is going to be used heavily in the machine learning classes. Okay. Now, similarly, we have correlation. So what is the correlation between, this is also you are going to use very heavily whenever we talk in the statistics video. Okay, let it finish. We don't have big data. Why it is taking more time? Okay, this is done. Similarly, we have mode. So mode is nothing but which particular element is occurring more frequently or more often, correct? So tf dot mode. Okay, so let me just print df. Okay, so in this particular column, which particular element is coming more frequently? I think everything is unique, right? So it is just going to print this. Now in B column, we have 20, almost all are same, right? Similarly, in this, we have two values. So if you have unique values, it is going to print all unique. If it has some repetition, it is going to print only that particular value. So if you see column C, we have one value which is getting repeated. So 25 is the most frequently occurred value or most commonly occurred value in the column C. That's why you got 25. Okay. Similarly, we have 16 two times, so we got 16. And here nothing, so everything is common. Okay. So this also we are going to use very heavily once. Basically, I'm going to show this in the EDA part also. Now let's talk about cumulative sum. So df is this. So cumulative sum is nothing but, so it is going to be added with the previous element. So before that you don't have any element, so this will be 13. Now in this is going to be added with 14 plus 13. Similarly, 3 will be whatever is the output of previous for sum, right? So this plus previous sum, this plus previous sum, or this plus all previous sum. Okay, that is what is your cumulative sum. So this, let's talk about df dot cum sum, that is cumulative sum. You see a 13, then 14 plus 13 27, 27 plus 3 30, 30 plus 2 that is 32, 32 plus 15 47, and so on. Okay, similarly we have df dot cumulative min. So how does it work? So let's print df first. So it is going to be cumulative minimum value. So 13 plus previous, nothing, right? So only 13 is the minimum value. So 14 and 13, what is the minimum value? 13. 13 and 3, which is the minimum value? 3. Then 3 and 2, which is the minimum value? 2. And 2 and 15, which is the minimum value? 2. That's what it is going to put. Okay. Similarly, we have df dot max. So I'm showing almost all the functions because these things you cannot get rid of it. Every data set will definitely you are going to use it. Okay, df dot cumulative max. Okay, so here like previous and current value, what is the max? Same thing the way you did in the minimum. Okay, now cumulative product. So current and previous value of product. So product of previous and current value. So df dot cum prod cumulative product. Okay, so definitely it is going to be incremental, right? So once you visualize this data, you will see gradually it is increasing. You can see here also. Let's talk about absolute value. So here I'll manipulate some values so that you'll see what exactly it does. Okay, so let's modify some value df dot loc. So I want to modify 0 and a as, let's say, minus 100. Okay, so df, when you print, what is going to return? 100. Now if you take df dot absolute value, so absolute value of df means all positive value. Okay, and whichever is negative, it is going to convert to positive. So you see the difference, negative has been removed. That's what is your absolute value. Now let's talk about product. So df dot prod. So it is going to multiply each and every value of that particular column. It is going to return that. Okay. So that's all, guys, about these statistical functions. This is very important because in every data set you are going to use it very, very frequently. Okay, so please practice and play with different data set. You will understand how it works. Okay, let's see data frame transformation function. So why this is required? Because let's say again, you have very huge data where millions of row entries are there, correct? And you want to transform the data. So how will you transform? So definitely in Excel sheet, if you're doing manually, you may put some formula or you may modify it manually, correct? But that is very cumbersome when data set is very huge. So for that, we have something called apply and apply map. So let's see how it works. So I'm going to create again some data set. Random dot int in 1 to let's say 20. I want to have 12 values. Let's take small values only and reshape with 4 rows, 3 columns. Okay, df dot pt dot data frame a columns to list. So 3 columns. So let's say A, B, C. What is missing? Okay. A, then columns A, B, C. Oh, sorry for the typo. Data frame. Okay, so now let's see how to use apply function. What exactly it does. So df dot, okay, so df dot apply. Now let's see what it does. It takes one function argument and whichever axis you want. Okay, so what is my function? My function could be, let's say I have some function. Okay, so what it does basically, it is going to do sum of those values. So a, and it will take all the values and do the sum and just return it. Okay, so that's what it does. So it is going to be applied over each and every column of the data frame. Okay, but let's say you don't want to apply over data frame. You don't want to apply over each and every data of a column. You would like to apply over each and every element of the data frame. So there's a basic difference. Apply means it will apply over each data, like combined data of one particular series of a column, or apply map will work on each and every element of the data frame. Okay, so let me just show the difference here. So df dot, let's see what if you are applying sum, then what will happen. Apply map sum. Okay, so it is going to throw an error. Why? See here, try to understand. Int object is not iterable. It is not going to iterate over it, all the integers, right? Because apply map means it is going to apply over each and every element. You just see here, apply function to data frame element wise. Okay, but sum needs what? Set of element, right? Okay, so it is not going to iterate. That's why it is throwing an error. So in this case, what happened? It makes sense to create a lambda function. So let's say I want to do power of 2 of each element, right? So I'll create one lambda function here, lambda, then take one element, and you guys know what is lambda function, right? If you don't know, then please watch my playlist where I've talked about specifically or explicitly lambda function. Okay, 2. Okay, now instead of sum, I'm going to apply lamp because it is going to take one single element. Okay, now let's apply and see. So see here, 19 to the power 2, 361, then 14 to the power 2, that is 196, and so on. Okay, so this is the basic difference between apply and apply map. So if you see the function here also, apply function along an axis, okay, to the data frame. So by default anyway, it is going to apply over column. If you want this to be applied over row wise, then you just mention x is equal to 1. That's why you see row index 0, 1, 2, 3. Okay, guys. So any function which takes a single element can be used in the apply map. If you don't have any such function, then use lambda function. You create your own function. Okay. So lambda we created. Now let's talk about custom function. So how you can apply custom function? Def, let's say I'm going to take divide by 2. Okay. So divide by 2. This is my function. Okay. It is going to take one element and it is going to return x by 2, floor division. Okay, this is my function. Now I can call this function df dot apply map. Guys, why I'm showing this particular function? Because whenever you have text data, right, so you have to do a lot of manipulation of the text, be it regular expression or maybe converting lower to upper, upper to lower, making title of millions of data in one shot, right? Their apply map is going to be very helpful. Okay, so please remember that. So in apply map, I'm going to use divide by 2. That's all. See here. So my original data was df. Okay, so this floor division, that's why you got 19 by 2, that is 9. Okay, and 14 by 2, that is 7, and so on. Okay, so if you do this, then it is going to return float values. So whichever you want, you can use it accordingly. Okay, guys, so yeah, that's all I wanted to show today. In next part, I'm going to talk about sorting, merging, or maybe some other topic. A lot of functionalities are there, so definitely another 2-3 video will be there in Pandas. I want to make sure that you guys, go through each and every pieces of Pandas and become expert on that. Then you can definitely handle any kind of data if you remember all the small function whatever I've shown you. Okay, because be it integer data, float data, or complete text data, unstructured or structured data, these functions you are going to apply very heavily. Okay, so yeah, let's pause for today. That's all, and I hope you guys are understanding it properly. If you're not understanding, please leave out comment in comment box. Okay, and those who are not subscribed, please do subscribe my channel. Thank you. Have a nice day. Bye bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. Today I'm going to talk about Pandas part 3. So those who are watching this video first time, I would suggest please was part 1 and part 2. Okay, then come back to this video because all the basics and couple of very heavily used functions I have already explained in the previous video. Okay, so let's see what and all I'm going to cover today. I'll share my screen. Yeah. So just to recap, we saw Pandas series and DataFrame and a lot of common functionality which is very heavily used. We have already covered in part 1 and part 2. Okay, and descriptive statistics also we saw in the previous video. In today's video, we'll see how to use a couple of other functionality which is also very heavily used in data analysis. Okay, so I have already imported Pandas library and Numpy. Okay, so import Numpy as NP and import Pandas as PD. So let me run once again. Okay, let's go back to the section. Okay, so I'm going to start with info function. What exactly it does? This is very useful function because whenever you are getting large data set, as a quick glance, you can have a look like what exactly the data is. Okay, so let me create some random data. So np dot random dot random between 1 to let's say 30. I want, let's say 20. I want 30 values. Reshape them between 5 to 6. Okay, or 6 rows, 5 columns. Okay, let's create data frame. PD dot data frame from A, columns equal to list. Yeah, so this is my data frame. Now, if you remember, I showed one function called describe, right? So what exactly describe does? Let me just run it and I'll explain once again. Okay, so basically it gives me a couple of summary of the whole data, right? So all the columns will be there, and for each column what is the number which is coming more number of times, right? So total number of basically the element. So total count is 6, which is common across all the columns. Total 6 elements is there in each column. Okay. What is the overall mean value of each column? What is their standard deviation? What is the minimum of each column? 25%, 50%, and 75%. That is interquartile range. And what is the max value? Okay. Okay, so let's see what exactly this info does. So df.info, if you do so, if you have a look here, right? So what exactly does it belongs to Pandas class, okay, which is data frame. And what is the range index? So index is ranging from 0 to 5. Okay, total 6 entries. And data column, so total 5 columns. And each column it will describe like what is what is their index header, what is their column header, and what are their values types. So total 6 non-null values are there. Okay, so basically there's no NaN. If you guys remember, I told, right, NaN is what? Not a number. So if you talk about Excel sheet, there are a couple of cells which is empty, right? So in data frame, it will treat empty cells as NaN. That is not a number. Okay. So you see exactly 6 values are there. There's no such entries which is empty or which is null. Okay. And what is their data type? So each belongs to integer 64 class. Okay. So total integer 64, that is 5 column. Okay, and what is memory? This is very important, guys. Memory information. Okay, so when you deal with very large data set, this is going to be very helpful. So why I'm telling this, because when you get, let's say, 1 GB of data which is in Excel sheet, right, and later once you start analyzing the data, you will find out like all of 1 GB data which is not at all required, right? So unnecessary, it is consuming 1 GB of memory. So how you can reduce the data? So that's where this data type will help you. So let's say I have a range of values between 1 to 255, right? So do we really need integer 64 data type for each value? Of course, no, right? So you can reformat or do the typecasting from integer 64 to integer 8, and significant reduction of memory you will see. Okay, so you guys should be very much familiar with this function, and I'm going to show this under case study also. Okay, then you'll see how we can reduce the memory size from 1 GB to, let's say, 200 MB, and do further analysis on data. Okay, so that is about info function. So let's see dropping column rows, and what is the reason behind why to drop column and why to drop rows. So let me talk the history behind this, or maybe theory behind this, why exactly we need to drop. So again, when I talk about this, right, I always consider very large data. Okay, so let's say you have very large data, and there, let's say, 1,000 of columns are there. So do we really need those 1,000 columns or not? Okay, that is the first question. So this will I will be covering under exploratory data analysis part. Okay, so if you don't need data, then you are going to drop those columns. So what is the reason behind dropping them? Again, a lot of theories are there, so which I'll be talking more in the EDA part. Okay, and that is one reason, to save the number of features. So column is basically considered as feature. So let's say your name, age, gender, and all those things, right? So each column is nothing but a feature. So do we really need name column? No. Okay, because maybe I don't care about the name. I just care about the data for each particular user. Okay, so I'm going to drop the name column. Okay, now let's say you have some column where a lot of entries have been left empty. Okay, so if you guys remember, or maybe you would have already participated some of the survey in the online program, right? So in survey, you may not disclose your gender, you may not disclose your name, you may not disclose your salary, right? So what happened to those data, or what happened to those entries? Basically, that will be recorded as an empty data. Okay, so that's where, let's say, user is not at all filling all the data. Then once you get the raw data from the your customers, what will happen? You'll see a lot of data which is not at all filled and which is shown as entry. Okay, so let's say out of 1 million row, let's say 50 million rows are empty. So do we really need to care about that particular data? No, right? Maybe I'll just go ahead and drop those particular row, or drop that particular column where more number of entries which is empty. Okay, so these are the theory behind this, and due to that reason, we are going to drop them. So let me just create one data frame here. We already have data frame. So what I'll do, I'm just going to insert or inject some NaN values. Okay. So how to insert those values, I've already told you. Let's talk about row 1 B column equal to np dot NaN. Okay, row 5, and let's say row E np dot NaN. Let's have one more, or maybe row 2. Okay, right. Okay, so what happened? My bad. So I'm going to going ahead with label based, right? So I need to use LOC, and that I forgot to mention. Dot LOC. If you don't mention, it is going to be treated as what is it? Separate column. Okay. So I'm just going to remove this first, or I'll run this once again. Okay, now let's try. Okay, so I have a couple of column entries that is having NaN values, right? So that's how we replace the values also, right? So this is one. Okay, so this is my data frame where a couple of columns are there where NaN has been inserted. So now let's say you want to replace the data. How you replace? So we have like one is like df dot replace, and here we have a couple of ways to replace, like which value you want to replace and by what value you want to replace. Okay, so you can go ahead with these parameter also, or you can give the a dictionary format. Okay, so I want to replace np dot NaN with, let's say, since it is not a number, right? So let's have some, very low negative values, so that user will get to know this value doesn't make any sense. Okay, then after that you press. What happened? Sorry, which value you want to replace and by what value you want to replace. That is one way to do that. Okay, so remember guys, this is always going to return the copy of it. Okay, so original data will not get modified. That's why you are seeing a separate data. Okay, so this is internally making copy of df and then replacing and putting in the value. So if you want to modify original data frame itself, so right now my original data frame is intact, it is not at all changed. You see here, I still see NaN. So one way to do that, we have something called, let me just add df dot replace. We have something called in place. Just make it true. So I think this I have already talked in previous video also. Most of the function will have in place equal to true or false. Okay. So when you are sure you are going to modify original data itself, then you use this value. Okay. I'm not going to run it, otherwise I lose the data. Okay. So this is to replace all the values. So you can replace the whole data set by using this method. Okay. So same way. Okay, so for column or feature wise, so here let's see how we can do that. So let's say instead of replacing over all the places, right? I want, or I am interested only in the column B. So what you can do, df dot b dot replace. Then I want to replace np dot NaN. Let's go with different way. Okay, so I have already shown what value to replace and with what value you want to replace. So I'm going with this mapping. Okay, so wherever I'm having np NaN, replace with, let's say, minus 20,000. Okay, and wherever you have something else, so let's say I have some other value also, right? I am having, let's say, test. It could be some integer value, sorry, string value also, right? I want to replace them with minus 10,000. Okay, then see the value. Okay, so whichever is meeting the criteria, right? Test is not there, but we have NaN, right? So NaN is going to replace by 20,000. Okay, that's how you replace in the column wise. Okay, if you see here, same kind of things are mentioned. Okay, next we'll see regular expression also. So for regular expression, let me insert some of the strings. So df dot loc, and let's say I'm going to have, okay, I'm going to insert some column. Okay, let's say there is another column called f, and its value is PyCSR. Okay, and there is one more column called z PyCSR2. Now let's talk about df. Okay, so we have two columns, and assume that this could be similar entries, like similar string entries are there, maybe single as a single element in any of the column, right? But I just, to make it more simple, I am just adding into a different column. Okay, so how you can use regular expression to replace one particular string in the whole column data set. So we have df dot replace. So I want to replace, let's say, PyCSR. Okay, so we have two kind of PyCSR. One is PyCSR, one is with some number, right? PyCSR2. So now here we have something called regex equal to true. So by default it is false. So once you make true, right, you can write exactly a pattern here. Okay, so let me just show you what exactly it does. So I'm going to replace PyCSR with, I did not give any value, right? To, let's say, minus 99. See what is happening here. So wherever I see PyCSR, everything is getting replaced. Even though I have PyCSR2, that is also getting replaced. Okay, so in this case, what you can do, you can write exact pattern. I want to have only that particular string which is ending with, let's say, some number. Okay, so let's say it could be not just PyCSR, it could be any string. So my pattern goes like this. I can have any word character, including number, and I want to make sure that the string which is present in the data frame, it is ending with some number, right? Just single digit. Okay, so only that particular pattern I'm going to replace with minus 999. Now see the magic. See here. So plus w, w plus is nothing but all the word characters. So PyCSR, and I'm making it mandatory, like it must end with $D. Sorry, D, that is digit. Okay, and it digit can be anywhere, right? A start or end. So let's make it more specific to end. It must end with D, that is digit. Then only it should replace. Okay, so when you make regex true, then only this pattern is going to work. Okay, that's how you replace the values in the data frame. Okay, let's do some reindexing. So reindexing is nothing but basically whatever index labels we have, that is going to be changed or not. Okay, so I'm going to have two data frame here. So let's say df1 equal to let's say 10 values, 5 rows, 2 columns. Okay, and here I can give columns equal to let's say CD. df1, df2. Let's remove this. Okay, so this is my df1, df2. Now you want to do reindexing, right? So let's see how you can use it. So pt dot reindex or df1 dot reindex. So I can have label, right? So instead of having 0, 1, 2, 3, 4, I want to have index labels as, let's say, range 100 to 105. Let's see it works or not. Okay. 100, 102. Oh, it is not taking. So reindex level column access. Okay, let me just try that. So df let's see one example here, how they are doing it. Okay, so this is this one, and so reindex new index, right? It could have taken. Okay. New index. Okay, that's fine. Maybe I'll pick up this example, then I'll show. Okay, so here is index, data frame. Okay, let's see what is example now. Df dot reindex. Okay, new index. Okay, so see here, you just randomly give the number, right? Whatever index row headers are there. Okay, so earlier it was Firefox, Chrome, Safari, i10, and Conquer, right? Here I just gave new values, right? So whichever is coming, you see here Safari was there, yes, so it has taken. Ice vessel, this was not there, right? So that's why you see this is something new row index has come, right? So it will take the name, but entries will be NaN because there is no such index which is already existing in the data frame. Okay, Komodo dragon, is it there? No, so that's why you see not a number. I10 is there, so it has taken 404 and Chrome. Okay, so that's how reindexing works. Okay, so I can take one more example just to make you understand. Let's say I give here, okay, and maybe it's not like you have to always give at the end. I can give at the beginning also, right? So if opera is not existing, it is going to add the labels, but values will be NaN. Okay, that's how reindexing works. Okay, so let's see how to do use of fill NA, that is fill not a number. Okay, so wherever you see NA, what value you can fill in. Okay, so I'll take my older data frame, that is this. Okay, I need to create once again. Okay, I think I lost it. Let me create once again. Okay, so A equal to P dot random dot int 1 to 20, then 20 values. We say 5 by 4. df equal to pd dot data frame. E columns equal to okay. Now let's add some missing values here. So df dot loc, then let's say 0th column, then d equal to np dot nan, some more. So let's say third row and c column. Okay, so this is my data frame. So I want to replace nan with some value, right? So we have direct function called df dot fill na. You see here what value you want to fill. So wherever it is going to find nan, it is going to replace with some value. So I want to fill them with minus, let's say 9,000. Okay. You see here it automatically got replaced. Okay. So what happened basically, as I mentioned, in Excel sheet, you will have a lot of cells which is empty, right? So to treat an empty value, nan will automatically get filled by data frame, or you are free to use any value. Okay. There are some situations where, let's say, you have exactly 1,000 entries and out of 1,999 values are there. Okay, but because of one value, you don't want to drop that particular row or column, right? So you will infer the value. What exactly value can we put there? So mostly people go with some statistical reference. Okay, so let's say whatever value is coming very frequently, I want to put that value and fill the NA. Okay, I want to take overall mean value or median value and fill with the and fill in place of NN. Okay, so that is this. And now what we can do, so I want to replace, let's say, C column with mean of this. So how we can do that? Df dot C dot fill NA, df dot C dot mean. I have already shown you how to use this function, right? Mean, another statistical function. See here, so column C is replaced with mean value of 8, 3, 4, and 2. Okay, so wherever NN is there in C, it will be replaced with the mean value of overall values. Okay, similarly, you can put, let's say, median. Okay, so whichever value you want to fill, you can use that function. I want to fill standard deviation with that value. It's just example, you will not be using exactly standard deviation, but you are free to apply any function. Okay, so that's how you do. And don't worry, I'm going to use this again with the case study also and with some projects. Checking missing values using various methods. Okay, so I'm going to use same data here. So believe me, guys, this is also very important function, and you cannot get just rid of this particular functionality. Okay, so whenever you get data, this is, I think, first or maybe third or fourth step, you are going to use this particular functionality. So I have millions of rows and columns. I want to validate, like, or I want to quick check or have quick glance how many empty values are there, or how many NN values are there in each and every feature, that is each and every column. Okay, so the best way is use null function, is null. So is null basically tell, do we have null values in the data frame? df dot is, so what it will do, it is just going to iterate over each and every column, find out which is NN and put boolean true. Okay, so you see here, these are not in none, so everything is false. And wherever true is there, only that particular value will be true. Wherever NN is there, that will become true. And similarly in D first value, that is true. Okay, so get that. Now the good thing is, since it is putting boolean true and false, right, you can easily get some of those values. So boolean false is 0, boolean true is 1. So now I can get total count of those NN. The df dot is null, and I'm just going to apply sum. See how easy it is. So in column A and B, I have 0 NN, column C, I have 1 NN, and column D, I have 1 NN. Okay, so this is going to be very helpful. Similarly, we have is not null. So df dot, actually it is not is, it is not null. Okay, so it is just going to put how many true, how many values are there, which is not null, right? So accordingly, it will put true, and wherever a null value or an is there, it is going to put false. So to get how many such values are there, just apply some function. So total 5 entries, and C and D you are having 4 entries because of one NN. Okay. Similarly, we have is NA function. So df dot is NA. It is exactly same as is null. Okay, so wherever NN is there, it is just going to put true. Rest will be false. And later you apply sum. Okay, so this output and this output is same. So it is up to you which one you want. Mostly I go with is null. That should be good enough. Okay, so using some values. Yeah, I think this was part of your fill NA. Okay, and using statistical inference, this was, I think I already shown you here. Taking standard deviation or whatever you want to have, right? That is here. Okay, so let's see the next one. Now we have something called typecasting. Okay, so this is also very important. Why? Because let's say you have an Excel sheet, right? And Excel is in one of the column, all integer values are there. So visually it looks like integer, but internally user who has filled the value, right, they might have used string type. Okay, so there are a couple of data formatting or cell formatting in Excel. Due to that, it has become string, which is very challenging. By like human eye, you cannot interpret it as integer or string. By looking at the value, it will definitely look as integer, but internally it is stored as string. Okay, so when you do analysis using pandas, it is going to return the value as object type. Okay, so let's see how to handle that value. Okay, so we have df. Okay, so as I mentioned, if string is always high priority, right? If I convert any one of the value as string type, everything is going to be typecasted as string type. Okay, so I'm just going to convert one value as string type so that I can show the example. So 0th row and column A. Okay, first I'll show the data type. df dot a dot d type. It is integer 64. I'm going to replace the value as, let's say, 10. Okay, so now you take df. See here, do you make any difference here? It exactly looks like integer only, but the moment you take the data type, see here, it is showing object type, means it belongs to integer. Sorry, it belongs to string type, not an integer type. Okay, so that's where problem comes. So when things looks like integer or float or exactly a number, it is not a number, it is basically a string. Okay, and since it is a string, you cannot apply any of the mathematical operation over those numbers. So what you have to do, you need to do as type. Okay, so what I can do, df dot a, I'm going to replace with df dot a dot as type. What kind of type I want? I want them to be as integer 8. Okay, and after that I'll check df dot a. Okay, how you see, now it has become integer 8. Okay, so that's how you apply or you use as type functions of pandas data frame to do any typecasting. Okay, so this is very important because, as I mentioned, right, once though it looks like integer type, but it is not integer. Okay, so since it is string type, you cannot apply any mathematical function. Let's say I want summation of all the values. Will it work? df dot a dot sum. See here, this is the error I'm getting. Okay, so I'll just comment it so that you guys can try. Now after doing as type, let's have a look whether it is taking sum or not. Great. Okay, so that's about as type. Let's see how to iterate over data frame. So for iterating our data frame, we have three functions: iter items, iter rows, iter tuples. Okay. So items are nothing but your row and column combination. So let's have a look. Df, this is my df. So what I can do, df dot iter items, what it gives. So it returns what? Column name and series, right? So basically column header name and series, it will be returning. Okay, so that is what your item. So I can get column name as series. I can just give the sort name for column name and series in data frame. Let's print C, what it is. So it is the column name, correct? Now what is my S? It is the series. So if I'm going to print all column name as well as series, it is going to return everything. So in column A, I have these values along with their row header. In column B, I have these values along with their header. Okay, so I think I'll just put in a nicer way. For A, this is a value. For B, this is a value, like that. Okay, that is what iter items did. Now let's talk about iter rows, what it does. So whichever way you want, I think based on the need, you can use iter rows, iter items, or iter tuples. So df dot iter rows, what it does, it is returning index and series. So iter item was our column and their respective values, and iter rows will be, of course, as the name suggests, it is going to take the each row. Okay, so for row and their column name, that is nothing but index, and their row, in this print index, that is a 0, 1, 2, 3, and print r, that is our each value of the row for given column. Okay, and similarly, if you want to print index row. Okay, so for 0th row, I have these values for each column. For first row, I have these values for each column, and so on. Now let's see what tuple does. df dot iter tuples. So what it return? Iterate over data frame rows or name tuple. Okay, so it is going to iterate over each row. For r in this print r, you see here. So each row is nothing but your column header, right? Row header, that is index 0, 1, 2, 3, 4. And for each row, it is going to return individual element, that is column A is 10, column B is 1, at per 1 particular index, that is 0th row or first row. Okay, so whichever way you like, I think you can use based on the need. Okay guys, so yeah, that's about this. Now let's see how to apply sorting, joining, and merging over data frame. Okay, so first we'll see sort. So I'm going to create one particular data frame here. So A equal to random dot randin, then let's say between 1, 2, or -1, or minus, let's say 5 to 20. I want to have, let's have a small one. Okay, 5 rows, 2 columns, so 10 values dot reshape 5 rows, 2 columns. df equal to pd dot data frame columns equal to a. Okay, so basically sorting will work on row or column values. Okay, so let's do that. Sort row and column labels. So first we'll sort by labels. So label here means A, B, and 0, 1, 2, 3, 4. I'm not sorting for values. So how you can do that sorting? So let's say df dot sort index. Sort index, that is the function we have. So it needs axis, right? So take a look at what it does. So it provides axis. So which axis? So if you want to access row, then it will be this one, axis 0, and column, that is axis 1. Then what label you want? So label right now we don't need because we have just 2 dimension. and ascending, whether it should be in ascending order or descending order. Okay, in place means original one you want to modify or not, so we will make it false only. Then what kind of sort? So by default let it be quick sort. Okay, whether you want to ignore index or not, those things you can use. So let's go with the default value first. So df.sort index. Okay, so which one it is taking? By default x is 0. Okay, now if I make ascending equal to true, so by default it is true. Now if I make it false, what happens? You see here. So by default it is taking row index and it is sorting by descending order now. Okay, similarly, let's say you want to apply this over column, right? So you can just make x is equal to 1. Okay, so you see here by column level it is going to sort. So in ascending it will be A and B, and descending it will be B and A. Okay, that's how you sort over labels of row or labels of column. Now how to sort over row and column values? So again I'm to take same data frame. So we have df dot sort values. Okay, so sort index was like either row index or column index, sort values by based on the axis. Okay, so if you don't give anything, what it is happening? See a sort value missing one required argument by. So by what you want to sort? So I want to sort by A. So you see here it is already sorted by ascending order. So it will take the column A, and whatever values are there, it will be sorting in the ascending order. Now I want to sort them by descending order. So what we can do? Ascending equal to false. So topmost value will come first. Okay, and when you are sorting over A, by default automatically whatever mapping is there, right? So like 3 belongs to this particular row, right? So it will be sorted accordingly. Okay, so column B value will also get changed. You see here it's all jumbled because the highest value is 17. Okay guys, that's how you apply sorting over rows and column. So similarly, if you want row wise, so I can do x is equal to by column 0. Okay, so it is not taking, right? Why? Because x is already it is taken as column wise. Now I have to make it row wise. So x is equal to 0, 1. Okay, so if you see here row 0, that is 7 and 3, ascending equal to false. Okay, so similarly you can apply your ascending equal to true. So now 3 is lower and 7 is higher. Okay, so I hope you understand. I think you guys just play around different values and follow these parameters. This is very important. That's how if you play more, then you'll understand better like how exactly sorting works over row and column header and row values and column values. Okay, so now let's see how to merge two data frame also. So why this merging is required? Because let's say you have data set which is spread across multiple data sets, right? So you want to combine them all together and make one single data frame. That's where your merge will come into picture. Okay, so I think let's see tomorrow or maybe in the next video, because I think it is too much for today. I'll be explaining this again with proper picture so that you can easily understand how merging is. Very simple concept, but the only thing is you have to understand like those who know set theory, right? They will be easily grabbing it. Or those who know SQL, like inner join, outer join, and left join, right join, cross join. So if you understand that concept, then you can easily understand merge, joining, and concatenation also. Okay, so let's wait for next video for understanding merging and joining. So that's all for today, guys. I hope you are understanding all the concept properly and you are trying it in your notebook as well in parallel. So those who are not understanding, please leave out the comment in my Telegram channel or in the comment box in the video. I'll definitely help you guys. Okay, thanks a lot, guys. And those who have not yet subscribed, please do subscribe my channel and spread the love. Okay, thank you. Bye-bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. Today I'm going to talk about remaining function. in Pandas. So let's see what and all I have today. I'll share my screen. Okay, so this is Pandas part 4. In this video, I'm going to talk about how to do data frame merging, joining, and concatenating. And let's say if you have data frame with some text data, right? What and all text operation you can perform over it. After that, we'll see group by operation, then Pandas default plot, and couple of windowing function in data frame, then how to do aggregation, and one more very important functionality, that is time and date functionality in data frame, which will be very heavily used for time series analysis. Okay, so let's start without wasting time. So I'm going to load those libraries first, that is NumPy as NP and Pandas as PD. Okay, so those who are not having any idea what I'm doing here, so I think you should watch previous videos, then you come back to this. Okay, so this is my PD version, and what is my NumPy version? Let me see. Yeah. Okay, so as usual, I'm going to create some random data, random n-dimensional array, and converting that n-dimensional array to data frame. Okay, so let's create some array equal to np dot random dot randint. So let's create from 1 to 20, and let's say 15 data set, and reshape with 5 rows 3 column, or 5 rows 2 column, and let me generate 10, or maybe 30. It should be okay. 5 rows 2 column. Okay, I'm going to generate in the data set, that is B. From this, I'm going to generate df1 equal to data frame A, columns B. So let's have this as df2, and it is coming from data frame P. Okay, so okay, let's run. df1, df2. Okay, so let it run. Meanwhile, let's talk about what is merging. Okay, so those who know SQL or maybe set theory, they will understand what exactly this is. So whenever you are having multiple data set, right, maybe it is spread across multiple data frame, right? So how you can merge them together and bring one single data frame. Okay, so that's where this merge functionality will be used. So there are multiple ways to merge it. So let's say left circle is df1 and right circle is df2. Okay, so you can merge those two data frame based on inner join. Inner join is nothing but whatever particular data is common between both the data frame. Let's say when I say common means, let's say you talk about the feature or the column name, right? If any column which is common across both the data set, you can merge with that. Okay, similarly left join data frame is it will take first left data and whatever is common between left and right data frame. Okay, similarly right join is nothing but it will take all the right data, all the columns or all the features of right data frame, and whatever is common between right and left. Okay, and similarly outer is whatever left and right and whatever is common. Okay, so that's what is merged. So let's see how we can perform this operation. So this is my data frame, and remember guys, whenever you have data frame merging, right, using merge, so it clearly tells you should have some commonality between those two data frame. Okay, so right now let's say I have A, B, and let's assume that in second data frame I am having D. Okay, so if you're trying to merge df1 and df2 without having any common column name, then let's see what happens. So I'm going to take df1 dot merge df2. Okay, so it is going to throw error like no common columns to perform merge. Okay, so remember, whenever you are applying merge, at least one column should be common across the data frame. Okay, so I'm going to modify this. So let's say first data frame is having A and B feature, and second data frame is having B and D feature. Okay, so let's run it again. Now you apply merge. Okay, so see what kind of output it is giving. So I'm getting A, B, and D, and some couple of values, right? So what happened to other values? So if you take a look at help of this merge, right, what it is telling. So here I've given left, and inside right is nothing but the second data frame. Okay, and how parameter tells like how you are going to merge. This is what I showed you, right? Inner, left, right, and outer. So by default it is inner, means whatever is common between two data frame, only those data will be taken. Okay, so let's go back to data frame and see what and all is common. So B and yeah, B column is common, and in B what and all values are column. So we have 16, 1, 8, 4, and here only 4 is common and 16 is common, right? So these two particular row will be picked up. Okay, so this is nothing but your third index. So you see here 16, B 16 and 11, that is this 16 and 11. Okay, now what is the next value? From B and D, what we are getting, A, B, and D, right? 4 and 4, right? So 4 is common. So where is 4? Yeah, this one. So 1, 4, and 4. That's what you see here, 1, 4, and 4. And earlier 16, 11, and 11, right? So where is 16? This 11, 16, and this 16 and 11. That's what you are seeing here. Okay. So if you want to have a look once again, then let me generate again some random data and print df1 and print df2. Okay, so we are merging over column B. So let's see what and all is common across B. So we have 2 is also there, no. So we have 16, 10, 16 is there, then 10 is not there, 2 is not there, 17 is not there, 4 is not there, right? So only one value is common, that is 16. So you will see if I merge, then only 16 will come. Okay, so wherever 16 is there, only that particular row will be picked. So that is nothing but your 2, 16, and what else? 16. In D also we have 16, right? Yeah. Okay, so that's about default merging. Now let's do some more merging. Okay, so by default it is inner, so you can just give how equal to inner as well. Anything is fine because by default it is inner. Now if I give, let's say, left, what it will do? It is going to pick whole data frame of left side and whatever is common. So if you take out left, right, whole data set or whole data frame of left and whatever is common between left and right. So whatever is common, that is B, correct? So only B data, whatever is common, that will be picked. Rest will be set as NaN, that is not a number. Okay. Similarly, if you want to pick right, so all the data frame of right and whatever is common between left and right. So you see here B and D, that is from right data frame, and whatever is common between B, that is 16 only, right? So only that particular data will be picked, and rest of the thing will be filled as NaN. Okay. So next one is outer. So let's talk about outer now. Okay, so outer, what it does, all left, all right, and whatever is common. You see here, all left data, that is B, and since we don't have 5, 6, 7, 8, right? So it is automatically going to set as NaN, and it is going to, basically it is concatenating here. We'll see how concatenating works. Okay, so there is power cut. Let's wait for a couple of minutes. Okay, so power is back now. Yeah, so it is going to merge A and B as well as whatever is common, right? So you see here, B, whatever was in the first data frame, 16, 10 up to 3, 16, 10 up to 3, and it is going to take other data also. Okay, that's what is outer. Okay, so if you're not able to understand, right, we have one parameter here called, let's say I'm going to set as left, and how the data is coming from left and right, right? So we have something called, it is very useful parameter, I think you guys should use it. Indicator equal to true. By default, it is false. So what it is going to do, it is going to tell you from where data is getting merged. Okay. So this is coming from both. Why? Because I have mentioned left, right? So all the left data and whatever is common between left and right. So this is common. That's why we got 16. So it is coming from both. Okay. And since rest of the things are NaN, that's why it is telling only left side. That is left only data. Okay. Similarly, I can do, let's say, outer, or let's talk about inner. Inner is whatever is common between both, right? That's why you see both. If I give outer, you see, so outer is nothing but, you see here, left as well as right and whatever is common. So you see in the indicator, it is coming from left, right, and both, whatever is common on both the data frame. Okay. So that's how you can do merge. There are a couple of other parameters also. So I think I would suggest you guys should use it and just play around with that. But concept is same. Okay. Now let's talk about joining data frame. Okay. So guys, merge data frame works on all the elements, whatever we saw, whatever is commonality between both the data frame, and at least one column should be common across both the data frame. But in case of joining, we will see it can be done over levels of index as well as column. Okay. So now let's say I have df1, df2. Okay, so here one column is common, right? So I'm going to do what I'm just going to do reindexing of column value. Okay, so df2, I'm going to change columns equal to, I'm going to have ab, and c is not there, t is not there. Okay, fine. And yeah, so here also function is exactly same as what we did in the merge. So I'll take df1 dot join df2. Okay, so let's see what it does. Okay, so it has directly joined. And how it is joined? Because 0, 1, 2, 3, 4 and 0, 1, 2, 3, 4 both are having this index, right? So it is going to take all the data of AB and all the data of C and D. Okay, so in case you are not going to provide by what column you are going to merge. Okay, so since, okay, let's take a look at this help. So on we are not giving, so that is none. So by default it is going to merge or join all, right? So string list or string array like column or index level. So I have not given any level. So what it does, otherwise join index on index. If multiple, that is fine, can pass an array. Okay, fine. So this is by default. Now let's go with another parameter. On equal to, let's say I want on A. See what happens. Okay, so what it is going to do, it is going to take the A value and whatever numbers are common with the index, right? Only those index value will be taken. Okay, so you see here value of df1 on A. Where is that? Yeah, you can take from here also. So 2, 1, right? So you see these two value, 2 and 1 is there in the index as well, right? So this is your 2 and this is your 1. So mostly 14, 17. This is the data which we are going to get. Okay, but by default, how is nothing but your left. If you see here, by default it is merging on or joining as a left data set. So in case I'm going to put as how equal to inner, then you will understand what is happening. Okay, so the moment you give inner, so it is going to take column A value and whatever value is going to present as index. So it is present as 2 and 1, right? So this is your 2 and this is your 1. So only this particular value is going to be taken. Okay, so let's go back to this. So where is the F1? Two and one. This is this. Where is the F1? Yeah, 2, 16. That is this one. and 1 3, that is from left data set, and from CD of course we have 16 16, and we have 5 and 2. Okay, so that's how you are going to get it. So you have only left and inner option, I guess. That is the only option provided on. Okay, we have right and inner also, right? So you can give a try using right as well. Okay, so let's check what right does. So it will take all the right data and whatever is common between DF and DF2. So what is common? That is 4 and 0 is present. So in right data, if you see, that is DF2. So 4 and what is present? That is 2, right? Yeah. So this is your right data. DF1, right, on A. So A we have 1 and 2. Let's go back to DF1. Yeah, 1 and 2, right? So 15 2, everything is there on right data set. And from left, it is going to take 1 3 and 2 16. So from where it is coming 1 3, because 1 3 and 2 16. This is the only data frame we have which is present in the index. Okay, 1 and 3. 1 3 and 2 16. Yeah. So remember, merge will work on data frame elements, and joining will work on the index value, whatever is common across column and index levels. Okay, so that's about joining, and inner and left and right and outer, which you have already seen in the merge. So this will also work as the same concept in the join as well. Okay, so let's talk about next one, that is concatenation. So we have df1, df2, a b c d. So I can use df dot concat. So concat will take basically 2 arguments, or panda concat. Yeah, it is going to take all the objects, right? So I'm going to present all the data frames in the list. So df1, df2. Okay, so if you're not going to provide like how you're going to merge, right, either left, right, or top to bottom, so by default it is going to add in the column side. Okay, so this is 1, and then you can just provide in x is equal to 1. Okay, so all the values. So AB first, it is like you have seen, right, horizontal stack and vertical stack, right? So it is going to act as a horizontal stack, the way we did in the Numpy array. Okay, so first it will take left data set and right will be right data set. Okay, now if you are going to merge with 0, that is what we saw in the default. Okay, so one thing you will notice in concatenation, it is repeating the index 0 1 2 3 4 0 1 2 3 4, right? So how to get rid of this? So we have something called ignore index. Just make it true. So what will happen? It is going to ignore and start from 0 to length minus 1. Okay, so total 10 elements are there. That's why you see 0 to 9. Okay, so yeah, a lot of other parameters are also there. So based on your need, you can just use whatever you want. And if you have something called common data frame, so we have something called, no, not here, it is there in the join. So join, I think I did not show you. Let me just add. There is something called left suffix and right suffix. Yeah. So let's say you have 2 data frame which is common, right? So you can just add left suffix as underscore or any character. So if you have 2 common column names, then second column will be always added with the suffix. Okay. So that's about concatenation. Now let's see the next one. Yeah. So far we have been dealing with all the integer or float value in the data frame, right? What you have, if you're going to have a lot of text data in the data frame, and of course you are going to have when you do text analytics, right? So what and all operation you can perform. So if you have seen my string video, right, there we have talked about multiple string related methods, right? So same kind of method you can apply over a data frame as well. So only thing is you need to convert data frame series in the string object. Okay, so let's see how to do that. So I'm going to create one data frame. So just thinking what, okay, I'll just give pd df equal to pd dot data frame. So I'm going to add a couple of names. Let's say cache. Okay. Okay, assume that I'm just going to have only one single column, right? You may have multiple columns, that's fine, but operation is going to be same. So in this particular data frame, I have one column A, which is having couple of text data, right? So what and all operation you can perform over it? Okay, so first is like length. Okay, so to do that, we have something called df dot a dot. So whichever column you're going to take, just take that column and convert into string data object. Okay, by using str. Then you give length. Okay, so what it is going to, this is very helpful. Okay, so remember those things and keep this as handy functions available. Okay, so what it does basically, it is going to iterate over each and every element of this index or this particular column and apply the length function of each and every string. Okay, so you see here it is going to return length. Okay, similarly, if you want to convert df dot a dot to lower, okay, so this will also be very helpful to convert every string into the lower cases. So when you are going to do some text analytics, right, I'll be talking about this natural language processing, so there you can use it. So why it is going to throw error? Because I have not yet converted to a string object, str dot lower. Okay, so everything got converted to lower, then we can have upper as well. Okay. Yeah. So let's see how to use strip function. So to show strip, what I'll do, I'm going to add one element of that column with a lot of spaces, right? So df dot, let's say 0 is what? Df dot a dot 0. And this should be okay, right? So I can use a lot of spaces. Okay. Now I'm going to print df. So it has a lot of space. If you print like this, then you'll understand. Okay, so default it was truncating it, so let's not worry about it. So if I'm going to use df dot a column, it is going to return me exact element whatever is present. You see here unnecessary spaces are added. Okay, so how to remove unnecessary spaces? So what we can do, df dot a dot, again convert to a string object, then use strip. You see here it has removed all the leading and trailing edges from first value, and everything is reformatted. Okay, now let's talk about get dummies. So get dummies, you may not get it right away, but once I talk about machine learning and one hot encoding, right, then you will understand. So what is basically get dummies? Let's say you have three categories, right? So let's say you have animal, and or maybe let's say in one column you have dog, on another column you have, or maybe in one column you have dog, cat, and let's say um, maybe leopard. Okay, so there are a lot of values along with these three category. So what you can do here, you can convert all the data into dummies. So what happens basically, wherever dog is there, it is going to put 1, wherever cat is there, it is going to put 1, and wherever leopard is there, it is going to put 1, and remaining value will get filled with 0. Okay, so how you can do this, so df dot a dot, I will show this once we deal with real-time data. Okay, str dot get dummies. Okay, you see here, I have these 4 categories. I talked about dog, cat, and leopard, right? But instead of that, I have some different name. So each name will be treated as a single category. Okay, so wherever I have this particular category, right, it is going to be put as 1 in each row. Okay, and remaining value will be filled with 0. Okay, so let's say if you talk about this Pankaj string, right, it is present only in 0th row, right? So that's why it is 1, and remaining row it is filled with different values. That's why I'm getting 0. Let's say it is getting repeated somewhere else also, right? Then you'll see same number will be there in the different column as well. Okay, so if you're not getting, then what I'll do, I'll just add df dot a dot, let's say -1 to same value. Okay, now get dummies again, then you'll see that difference. DFA, why it is not listed? Maybe you give 4. Yeah, so 0th value and 4th value is Pankaj, right? So now I'm going to take df dot a dot str dot get dummies. Okay, so yeah, you see here this name and this name, right? So it is present only at the last row, that's why you see 1. Okay, and it is present in the first row also, that's why you are getting 1 in the first row. Okay, and what else you can do with get dummy? Separator is not required. Yeah, so this is good enough to understand, and this will be required only when you do a lot of categorical data analysis, and you are going to predict the data, right? So for prediction, data prediction, or in machine learning, algorithm only will understand the numerical value. Okay, not the text value. So all text needs to be converted to numerical value, and that's where these get dummies and all will be helpful. Okay, let's talk about next df dot a dot str dot cat. Cat is nothing but concatenate. How you want to concatenate? Let's say each word or text of that particular column I want to add with underscore. Okay, so what is happening here? Oh, I think there is something called separator, right? Separator equal to underscore. You need to identify, put that value. That's why it will come. Okay. So this is coming because underscore is still there. I have not yet replaced the original value. Okay, and remaining value you see underscore is added. So is upper, is lower, let's say a couple of values you have, and whether it is lowercase or uppercase, you can just get it. And it is going to return boolean true or false. So df dot a dot str dot is upper. So everything is like having mix of upper and lower, right? That's why you are getting it false. Let's say we are having lower, all false, right? Now let's change one value, df dot a, let's say 0, and I'm going to make it complete lowercase. Okay, now let's check this, what it returns. It is going to return true because all the character of that particular text is lowercase. Okay, so yeah, a lot of functionalities are there related to string. I think these basics are good enough. You can do find all using regular expression, using find also. You can do what do you say, split also, like the way we did concatenation, right? You can do the split also. Okay, so once you understand this basic, probably I would say go with the advanced function, then you just give a try. Okay, let's go with group by operation. So group by is nothing but, let's say you have data, right? In Excel sheets you have seen data. Let me just show that. I'll show with example, then you will understand what exactly group by means. I'm sure you would have used that functionality, but let's have a quick recap. Okay, so let's say I have A here, then B, then C. Okay, I have some value here. It is mix of string and integer. Okay, so let me increase the size so that you can understand. Okay, I think I'm not sharing the screen. Let me just share it quickly. Okay, so let me recenter. Yeah, so you have these three column, right? Okay, and these different values, set of integer and text as well, right? So what happened, I want to filter the data with particular thing, right? So let's say I'll just give some common name here, t1, and let's say t1 here also, and t1. Okay, so I want to group the data by column A, column B, or column C. Okay, so whenever you group the data, right, so what exactly this means is, so whatever based on value, right, so S is present where in column A is present, and wherever else it is present, it is going to form the group. Okay, but in case you are going to give single value only, it will be talking about column A. But let's say I'm grouping column A and B. Okay, so what will happen, I want to find all the values wherever, let's say one more here, I will mention t2, and let's say make this as t2 and t3. Okay, and maybe as t2 and some value. Okay, some values are there. So in case I do grouping between A and B column, right, so what will happen, it is going to form a group. So S with t2, S with this, S with this, and this. Okay, similarly 2 with t2, S with t2, 5 with this particular value. So for each value, it is going to form a group, and for that group, whatever other values are coming from column C, right, it is going to be present as different value. Okay, so if I am going to filter these things, right, let me apply filter. So let's say if I filter with this, see what happens. So wherever S is getting present, it is going to form this, right? Now wherever T2 is present, or maybe this S is present with T5, just example. Okay, so I have made a group with A. Now I'm including group B as well along with A. Okay, so I want to make sure that wherever S is present, I want to make sure T5 is also present. Okay, so what is happening now? Wherever A is S, B is T5, return with the value, and this is what is the value. Okay, so like that you can form the grouping. Okay, so using this you can do a lot of other operations also in the data frame. So let's create that and see how it is working. So I think we already have df1 and df2 is also there. Let it be there. df2, maybe I'm going to merge or concatenate. Okay, so pd dot concat df1 df2 and make df3. Okay, so I'm just going to make x is equal to 0, 1. Yeah. So now we have the new data frame where ABCD is there. Okay. So once you have data frame, right, what you can do, we have something called df3 dot group by. And this function is going to take by what you are going to group. Okay, so I want to group by A. Okay, so once you perform the group like the way we did in the Excel sheet, right, same way. Okay, so now I form the group of A. It is going to create one object, that is panda group by object. Okay, so let's give this name as group. Okay, now once group by is present, now what you can do, group dot this attribute will return all the groups. Okay, so how it is forming, it is forming let's say A is what, 1, so 1 is having 4, it is present at 4th index, right? So it is going to return me the indexes of all the value whichever is present in A. Okay, Now 2, where it is present, 0th index. It is basically sorted one. Okay, after that we have 14, it is present at what location? First row. 17th is present in second row, and 19 is present in 3. Okay, so do we have similar value? Let's see. Okay, let's make group by D. So that I can show the difference, what is basically happening. Okay, so this will be your group 2, print group 2. Now group 2 dot PS. See here, 2, now if you see here, right, so in D, if we are grouping by D, right, so couple of values are there in column, common rows, right? In some rows value is common, right? So see here, 2 is present 2 times. So what is happening? It will make group 2 wherever it is present, 0th row and first row. That's what it is going to return, indices of list of indices of all the value wherever it is present. Okay, similarly to other values. So once you have formed the group, then you can easily get one particular group by fetching group 2 dot get underscore group. And which group you want, you need to pass the exactly key of that particular group. So I have the key as 2, just pass exact name. Okay, so it is 2, just get. Okay, so from the data frame, I want to fetch the value wherever 2 is present. It is going to return me those particular data frame wherever in the D 2 is present. You see here, this is one way of filtering the data. Okay, so just understand the concept of group by, and we will be using this heavily in the data frame once we talk about the case study. Okay. Yeah, so this will also be helpful for plotting whenever you are making a data with different groups and you iterate over each group. Okay, so how you can iterate, because now you got the groups, right? So let me just run iterating over groups. Okay, so I can mention, let's say temp equal to this, right, is a group. Or what you can do, instead of doing this, for key and value of group 2 dot groups, print k. In this. Okay, so group 2, sorry, groups is returning dictionary, right? So in dictionary we have something called keys. Okay, so it is going to return all the keys, right? So you can just use this. Okay, so these are the key, and for each key, what is my value? So what you can do? Okay, this is the way to get key. Now from each key, I want to fetch the value. So print grp2 dot get group, and what it needs, key. What is my key? Key. Oh, this is method, right? So okay, yeah. Okay, so for each key, it is going to return me the data frame of wherever the grouping has been done. Okay, so that's all about group by. So let's see Pandas default plot. I'm going to talk about plotting in detail using matplotlib and Seaborn, but you guys should understand how Panda is plotting, or how Panda is having different default plots. Because sometimes what happens, you don't have to really write very lengthy code to do the plotting. Panda will do that job in a single line. Okay, so what I can do, let's say I have df1. Okay, I want to plot all the data of this, right? So how you can do, df1 apply the plot function, and in this plot we have something called kind. What kind of plotting you want? Okay, so we have these kind of kind support, this kind of plotting supported in the default plot. So we will go with line bar. Let's see. So all I'll mention kind equal to, let me create some user data, then you will understand. So df equal to np dot random reshape, let's say 25 rows to column, right? And df equal to pd dot data frame A and columns equal to A and B. Okay, this is my data, and now I'm going to plot with this df, right? So just give, okay, let's make it more beautiful. So figure or fixed size, that is figure size, 16:4 ratio, so that it can look better. Okay, so this is my data A and B, and that's how your data is plotted. Okay, similarly, you can have bar plot. You can give bar with all the values plotted in the bar plot. Okay, let's see what we have. We have something called kernel density estimation, that is KD. Let's plot that also. So don't worry about this. I will be talking more in the statistical video. Okay, then we have horizontal bar. This is pretty simple. Okay, then by default vertical bar is there. Let's see what else we have. We have something called histogram. Hist. Okay, what else we have? Then we have area, then pi, scatter. Okay, let's talk about scatter. X, will it work? Is it hex bin or hex? No, it is hex bin. Okay, it might have some other dependency also. That's why I'm not plotting it. But don't worry, I'll be showing this in the matplotlib video. Okay, so let's plot scatter. Okay, for scatter also it has scatter requires an x and y column. Okay, so right now we have only one column, right? So you need to provide that, then only it will work. Okay, what else we can plot? Default. Box, very important plot. This is also known as 5-point summary plot. Okay, so don't worry what is 5-point summary. I'm going to talk more in the statistical video. Okay, so this is a box plot. Why it is called 5-point summary? Because it shows 5 different data. Okay, this is min, max, median, and interquartile range. This 25%, 50%, and 75%. Okay, so that's all about this default plotting. This will be very helpful whenever you are, have a quick look of the data instead of writing multiple line of code for just plotting some data. Better you go with default pandas plot. Okay, so let's see the next one, windows function. So what is window function basically? So window function is nothing but if you see the line plot here, right? You see here what is happening. It is plotting each and every point of the data, right? Sometimes what happens, you really don't need this kind of data. You may have to smooth it. Okay, so to smoothen the curve, you may go for windowing function. So what basically it does, it will take few data points, calculate the sum of those 4 points, and just plot a single point of those 4 points. Okay, and it could be standard deviation, it could be variance also, covariance also, it could be mean also. Okay, so whichever way you want, you can do that. So you have multiple values, you are cutting the point with 5 point, 30 points, or 20 points, taking the calculation and putting that as a single point. Okay, that's how you can smooth the curve. Okay, so let's take example here. So I'm going to generate a number df1 and df. Okay, now I'm going to plot it. So what you can do before plotting, you need to create a window function, right? So df1 dot, we have something called rolling function. Okay, so roll is nothing but you have this data set from top to bottom, you just roll your window. So let's say first three value you want, calculate something, get the output and do whatever you want. Okay, move the window to next 3 point, calculate it, get the output and do something, whatever you want. Okay, so in the rolling function, we can define a window. You can see here the window, right? So window could be of any integer value. I want, let's say 3 value. So these values are basically nothing but, so if you talk about business related data, right? So they talk about, let's say, monthly forecast, quarterly forecast, yearly forecast, right? So if I have, let's say 50 value, I can go with, let's say, weekly forecast, every 7-day value I want. If you have very huge data, every quarterly value you want. So let's say quarter means total 90 days, right? So 90 days window size, you can set as 90. Okay, every single day or every 2 day you want, so you just put the value based on your window size. Okay, so in this window, I want to plot window 3. I want to take sum of it. Okay, so what it will do, I have given window as 3, right? So first two value doesn't qualify the criteria, right? 3 window. So the first 3 value will come in the third row only. So first two will be set as nn, and first, second, and third will be added together and put the sum. So you can see here. So first, second, 21 plus 122, 22 plus 38, that is, I think, 60. So your third row value will be 60. That's what you see here. Okay, so now you understand it by just plotting it. Then you will understand why this window function is required. So df1 dot plot kind equal to line. Okay. Okay, so now I'm going to plot this value again by taking the, by applying the window function. Okay, so df1 dot, let's say, rolling window size equal to, let's say, 3. Okay, so this particular part is going to reply or provide a data frame, right? So on that data frame, I'm going to apply plot function. Just put plot. Okay, now you see. So rolling window, and after that, I'm going to apply some function on top of the data frame, right? Use some function. Now you see. So see the difference or significant difference between these two plots. So earlier here, every point was getting plotted. Now every third point is getting plotted by taking previous, by taking sum of previous 3 values. Okay. So if you want to smooth it further, let's say I want data of every 10 days. See here, further difference. I want data of every 20 days. See. Okay, so that's where rolling function will be helpful. Similarly, you can use a standard deviation of, each 3 days, how my data is varying. Okay, so that's how you can play around with this data and apply the window function whenever you need. Okay, those who are going to talk about purely financial data, right, these things will be very helpful. Okay, now let's talk about aggregation. So now window function you saw, right? So here we are applying function on a whole data frame, right? But what if you want to apply your multiple function on complete data frame or set of column values? So for that, you need to create object of window function. Okay, so I'm going to take df1 again and just apply df dot rolling. Let's say same function we'll use, but it is going to return an object. Okay, so since it is rolling, so I'm going to create one object called r window equal to 3. Okay, now if you take r, see here. So it's a rolling window where window size is 3, center false, x is 0, method single. Correct. Now, once you have the rolling object available, right, so you can apply aggregation on that. R dot aggregate. So, and apply the function. So if you see here, aggregate take function, right? So I'm just going to apply numpy or np dot sum. So what it will do, it will take the sum of all the value of every 3 values. Correct. Now let's talk about something else. So let's say I want to apply sum function as well as standard deviation. Okay, so multiple function you can provide in the form of list and separate by comma. So np dot standard deviation. So what will happen it will take each column of that particular data frame and apply 2 function on that and return as a data frame. See here. Okay, not only 2, you can add any number of function, np dot, let's say, variance. Okay, so 3 function for each column, correct? So whichever way you want. So this is like applying over a single data frame, right? Now you can take this as a single column also. So I want rolling of, let's say, column A only, and apply this. Just give this. Okay, so same way, whatever you got as a whole data, you can just apply over one single column. That is what is aggregation. Okay, so let's talk about the last functionality for today's video. How to apply, time on data, what is it, label for the given data frame. So again, this is going to be helpful only when you are going to do a lot of time series data analysis. Okay, so for that you should have data where all the indices are set as time data. Let's say I want monthly value, right, from January 1st till January 31st, right, all the values. So every value you are calculating, or you are giving some business related data, right? So it will be having some timestamp, right? So day wise timestamp, correct? So how you can do that? So we have something called pd pandas dot date range. This function will help you to create the date. Okay, so start, you can put in any format, standard format. So like date, then month, then let's say year 2020. Okay, and this will need what is your end date. If you don't give, just don't worry, you can give periods. So how many period you want? Let's say I want total 10 period, means 10 days, right from 1st January. Okay, so you see here, it is going to return me all the dates. Okay, and frequency is nothing but, if you talk about frequency, it has a lot of business related frequency available, like you can have like every day, then quarterly base, weekly basis, work week, non-work week, like that. So if you see here frequency, we have every 5-hour data. So if you just mention 5-hour data, let's say if it takes or not. Okay, let's forget about it. So total 5 days I want, let's say total 50 days I want. If you crossing 50 days, then what will happen? It will automatically move to February next month, because everyone cannot have more than 30 or 31 days, right? So of course it will move to next month. Okay, so this is period I was talking, right? We have something called frequency. So we'll give 5 hours. See here. So with every 5 hours, so we will have in one day, we will have 3 or 4 5-hour window, right? So those particular window will be there. So from 00, like midnight, till 5 a.m. Okay, then next one will be 5 to 10, 10 to 15, 15 to 20, like that. So whichever way you want, you can just do that. Now how to use this? So let me create one data frame again, equal to, or maybe I already have data, right? So how many values are there? We have 50 days, right? So instead of giving 0 to 50 series, that is like normal number, I can use df dot index equal to, so pd dot date range. I want start date. So start is nothing but, let's say you can have right from 1st January, from 2022, and periods I want 50. Okay, then talk about df1. See the magic. Okay, so you can consider this as like next 50 days data of data frame, right from 1st January till it will go to February 19th. Okay, so it has a lot of other functionality also, but yeah, just to know the basic of time functionality or date range functionality of data frame, I think this is good enough, because mostly you are going to deal with data which is having either index, or if it is business related data, mostly you are going to have timestamp. If it is not there, you can add by creating the timestamp series using date range. Okay, so I think that's all for today. If some other functionality is required in a couple of case study or project, Along with that, I am going to show some different functionality also. Okay, guys, that's all for today. And few topics are remaining, which is very important, and I'm going to cover in the next video. That is going to be final video of Pandas. Okay, so there we'll be talking about file IO using DataFrame. Okay, reading different file format, saving data to different file format, and getting data from HTML. It is kind of web scraping. So I'll tell you how to fetch from data from Pandas data frame and convert into desired data frame. Okay. So that's all, guys. I hope you like this video. A lot of technical details, but yes, it is required to handle any kind of data. So once you are familiar with each and every function, whatever I've shown you, right, then you will realize like how beautifully you can handle any kind of data and how much important are those functions. Okay, guys, so that's all from my side today. And those who have not watched previous video, please finish it, then come back to this video, and please do subscribe my channel. Thank you so much. Bye-bye. Hey guys, Pankaj here. Welcome back to my YouTube channel. So this is the beginning of 2022. So I wish everyone a very happy new year and very happy learning. Okay, so I want to make sure that you guys learn a lot of new things from my videos and you become a successful Python programmer and become very good in Python data science module. Okay, so in this video, this is going to be a final chapter for Pandas. And I wish you have already learned a lot from NumPy and all previous videos of Pandas. Okay, so today we are going to see file handling, that is file IO of Pandas module. Okay, so let's see what and all I have today. I'll share my screen. Okay, so these are the topic which I'm going to cover here. So as I mentioned, this is file IO. So we'll see how to read the file either from drive or from the web page. Okay, and how you can import different files and how you can export to different file and different format. Okay, and one more thing we'll see like how to read very big data. That like file could be, it could be like CSV file or text file or any kind of file format which is more than 1 GB. Okay, so this is something like a lot of people will have question like how to read this kind of big file and without affecting our performance or computer performance. Okay, so let's see. So before that, I wanted to show one topic which I think I missed, or maybe I'm not sure I have shown or not, but let's cover it once again. How to drop the columns or rows where NaN is present. Okay, so as usual, we'll import the libraries NumPy and Pandas, and this is the version I'm using. Okay, so let's create some random data. Randint 1 2, let's say 50 20 and reshape. Five rows or maybe 10 rows. 10 rows, 2 column, or maybe 3 column. I'll give. Let's generate 40 values. Okay, so this is the data frame I have, and let me insert a couple of NaN values in somewhere in the row and column. So why I want to insert, so that you will have some data where like empty values are there, right? And as I mentioned in Pandas, empty values will be represented as NaN, that is not a number. Okay, so I'll say df dot loc. Let's insert this value as NaN. So that is 4th row. And let's say column B. Okay, and B dot N. Similarly, I want to insert in column C as well. So let it be 9th column and column C. Okay, let's print df. Why P is getting typed as so. Okay, so this is NaN and column C also we have NaN. So now assume that you have got some third-party data and a lot of NaN values are there, and you think, okay, maybe your client or someone says wherever you see empty value, let's drop it. Okay, so mostly we're going to drop that feature. Okay, not the row, or maybe you can drop the row also based on the need and based on what client or customer says. Okay, so whenever you are going to drop, right? So we have something called tf dot drop NA. Okay, so it has a lot of parameter here. So it says, and how you want to throw threshold subset in place. Okay, so let's drop in and see what basically happens. Okay, so if you notice here, wherever NN is there, right? Basically for each feature you have particular entity, right? So let's say column is nothing but your username. Okay, for this user, couple of fields are there. In that field, one of the field is nothing but NN, that is not a number. So that particular entries for that user will be omitted or removed from the database. Okay, so that's what drop NA works. I mean, it is by default going to drop the row entry or entry for a particular user. Okay, so in this case, what is happening, wherever NN is present, right, only those row is getting dropped. That is 4th row and 9th row. You see here, after 3, there's no 4th row, and after it, there's no 9th row. So that's what by default it works. Now let's say you have decided to drop the complete feature itself. That is nothing but feature B and feature C. So feature B is having NN and feature C is having NN. So in this case, you need to give X is equal to 1. You see here? So it is up to you guys. So based on the need, you need to choose the axis accordingly. By default, it is row wise. And if you want to make column wise, you need to give x is equal to 1. Okay, that's how you drop it. Okay, so I think I could have written it here. Drop columns, and default is drop rows. By default, I'll mention. Okay, now let's talk about this dropping column rows of user choice if column feature is not very important. Okay, so I think this one I have already talked in my, I think, second or third video. So this is something like, whenever you have multiple columns, let's say more than 1,000 or 2,000 columns are there, and each column is not at all contributing, like a lot of columns are not at all contributing to your data set, right? So which is like not at all important. And when you process the data, unnecessarily those columns will also get included, right? So in that case, you decide whether this column is really required or not. In that case, you decide to drop them. Okay, so we have something called, let's df. So in this case also, I'm going to decide B and C and D also. Okay, so we have something called df dot drop. Earlier we saw drop NA. So wherever NaN is there, only those values is going to be removed. Okay, now in this case, I'm going to put a choice of those column which is not required. Okay, and this will also be helpful during your PCA analysis, that is principal component analysis. I'm going to talk about this in more detail when we talk about machine learning. Okay, so here it needs labels. So which label you are going to draw? So by default, x is 0, that is nothing but row wise. Sorry, column wise. If I'm going to define the label here, so since that is first parameter, so I can write all the labels of column which I'm going to do. So B and C and D. Okay. Now if you drop, what is happening? B, C, D not an axis, right? So why it is not present in axis? Because by default it is trying to get those labels from x is 0, that is row wise. So in this case, you need to explicitly mention x is equal to 1. Okay. Yeah. So B, C, and D are dropped. That's how you left with column A. Okay, so since it is making a local copy, so your original database or data frame will still be intact. Okay, so if you want to modify, if you are very sure you are going to drop from original data itself, you put in place equal to true. That is this one, this particular value. By default, it is false. So it is going to make a local copy and modify and provide the output. Okay, guys. Yeah. So now let's see importing external data to data frame. So here, whenever you are going to read any file, right? So the good thing about Panda data frame for the file IO, they have very unique, or what to say, uniformity is maintained over across the functions. Okay, when file IO comes into picture. So if you talk about df dot read, sorry, pd dot read, and let me just open dir. Okay, so here we have something called, let's read. Yeah, all functions start with read underscore, then the file format, like read underscore clipboard. This like control C if you do, right? That is nothing but a clipboard. Okay, so if some data is present somewhere and I just want to make this a data frame, so I just press control C or just right click and see. Then you can convert the whole data into data frame. That is nothing but read clipboard. Then we can read CSV, read Excel, read feather. I don't know what is this feather. And FWF, then GBG, then Hadoop data file system, that is SDF, then HTML, JSON, ORC, a lot of formats are there, you can see. Okay, and when once you read the file, then it will create a data frame. Similarly, you can transfer to exactly similar format, that is nothing but your to. So if you see here, after R, we have something called to number, to pickle, to CSV or something, whatever data you want to save it. Okay, so let's see one by one. So pd dot read CSV. Now, in this case, there are almost more than 50 or 60 parameters. Okay, so I'm not going to show everything, but whatever is very important, right? So first one is file path. So wherever your CSV file is present, that file. So let's say, do I have some CSV file? Okay, let's say I have Titanic dataset CSV. Okay, so if you open this, it is nothing but comma separated value. Okay, it has some values. So this data you can get from internet also, or also a lot of sources where you can get this kind of toy data set. Okay, so these kind of data set will be used when you play around with data frame. Okay, so I'm going to use the same file name, Titanic dataset .csv. So give the full path or wherever it is present. So right now it is present in root directory. I can give like this, or I can give like this also. So let me write this first. Since it is present in root directories, I can give this as well. Or you can give the full path also, like C colon, whatever folder name. Okay. So okay. So if you read the data file, then directly it is going to create a data frame with some default value. You see here, it has already read the whole data and everything is present and it is just printing it. Okay, so after printing the like top 5 rows and bottom 5 rows, it will show like how many rows and columns are there. Okay, that's how you read the file. Now there are a couple of other things here to note down. Let me walk through a couple of parameters. Okay, so we have separated. So CSV is already separated by comma, right? So default is comma. Okay, any delimiter, like say any special characters are present as delimiter, that also you can provide. So it will automatically split them with delimiter and provide the column wise data. Okay, names are nothing but like what exactly name you want. Okay, so this is basically a column name. Okay, index column, your index column starts from where? So right now, okay, I'll show you. Right now there's no index in this, so that's why you see by default 0, 1. Otherwise, let's say this is my index column, right? So I can give index equal to p class. So automatically numbering will start whatever value is present in p class. Okay. Now we have something called use column. So while loading the data itself, you decide to load only those columns, you can give use columns. Okay. Otherwise, mostly I suggest not to do this, because first you read the data directly, understand what and all are present, then accordingly you do that. Okay. Then this is not required right now, prefix not required. Data type. So if you want to read the data with some default data type, right, you can mention that also. This you can leave it. Skip rows. So how many skip rows you want to exclude, that also you can mention. Okay. So I mostly don't suggest to use these kind of parameter at one go, right? First you load the data completely, understand like what kind of data is present in the data, then you decide. Okay, then chunk size is very important. So this is the parameter which will help you to read any data which is more than 1 GB or 2 GB. Okay, because this creates a iterator of that particular chunk. Okay, so a lot of things are there. I think you can definitely read more about those data, but more frequently I'm going to use bit default. Okay, so once this is done, then you can read the CSV file, and yeah, you can just print df dot head, top 5 rows, top 5 column. So I'm going to use all those things later also. Okay, so when I talk about case study. So this is about reading the CSV file. Okay, now how to read very big file with which is more than 1 GB data. So right now, I have given one link. You guys can download data from there. Let's see what is present. Okay, so these are the file. It is giving what kind of item it is, like what is some description and how many rows are present. So whichever row is more, so you can probably download the data. Okay, so it may not be more than 1 or 2 MB, but let me see. This is having little more data, so let's see how much. It is just 1.4 MB data. Okay, so what I can do, there are two ways to do that. Either you download and give the whole path, or I can just copy this link and give it here. That is also fine. Okay, but that will come under, let me just open that. I'm just going to path. I'm just going to pass that whole path. Okay, so let's see if this works or not. Since it is CSV file, .csv separator is already present, I think it will read and just return the data. Yeah, it has read it completely. Okay, so see how many what to say rows are there. Almost 25 lakhs, right? 2.5 lakh rows are there and 9 columns are there. Okay, so you can have some data which is really literally 1 GB of data. So assume that this is also 1 GB data. Okay, so how you can read it? So for reading that, what we have something called, as I mentioned in previous line, chunk size. So you just define chunk size equal to, let's say, every 1000 row I want to process. Okay, so this is going to return a iterator object. So I'll just show you what exactly it returns. See here. So Pandas IO, that is input output parser reader text file reader. Okay, so now once you have this reader, right? So if you remember, guys, in the list and iterator video, what I showed you guys. So once the iterator object is created, right, it is going to take only that much required size, whatever structure takes. Okay, if it is a list, almost close to 42 or 48 bytes it takes. Correct. Similar, even though it is 1 GB data, it will just take, let's say, assume that one structure takes 1 MB of size, right? It is just going to consume only 1 MB of size. That's all. Because since it is iterator, so whenever user needs data, only that particular time, next set of sequence will be generated. Okay, or next set of data will be fetched and returned to the user. So how to iterate for? I'm just going to show you the data. Okay, so for, let's say, D in df and df dot shape. Okay, let's print it. So this is very huge data. So I'll just read this one. So every data frame will have 10,000 rows. Okay, let's do that and check the shape. Okay. It's not taking. Oh, sorry, not df. Df is your iterator object, right? It should be D. Okay, you see here. So you see here, it is reading first 10,000 rows and total 9 columns are there. And I'll keep reading 10,000 and remaining data will be only remaining the rows will be there and 9 columns. Okay, so that's how you can read. So if you check the size, right, it is not reading the whole data frame in just one object. It is just reading 10,000 rows first, do the processing, and again go ahead with the next 10,000 rows. Okay, so that's how you can keep reading. No matter it is 10 GB or 100 GB file, you can just read like that. Okay, so that's how you can keep reading and understand like how much exactly size will be taken. Okay, so I can just show for D and DF and D dot info. Oh, I have already read it later, so it is already over. So let's run it again and run this. Okay, so for each data, it is going to present like how much size it is taking. So every 10,000 row will occupy almost 703 KB. Okay, so like that, and the last one is going to take 327. It has less number of rows. Okay, so I'm just going to comment it so that you can run later. Okay, let's talk about reading XLS file. So I'm going to generate some Excel file. Let me check if I have any file. So I'll do one thing. I'll just open this Titanic data and I'm going to convert into XLS file. Okay, so let me share. Okay, I'm just browsing the file, so no need to share that. Once I open, then I'll share the file. Okay, not this one. Okay, let me save it. Okay, so I hope you guys are able to see this is my Excel sheet. Okay, so in this Excel sheet, what I'm going to do, I'm going to see, I have saved original data itself in the Excel sheet format. Okay, so I'm going to create similar data in a sheet as well. So let's create, so that I can show you how you can create multiple Excel sheet with multiple sheets also. Okay, so move and create a copy, and I'm just going to give sheet name as sheet 2. Okay, let's save it and run the file. So for this, we have direct function called read Excel and give the file name of Excel sheet. So what is the file name? Titanium dataset. So I'm going to upload this dataset also, so you guys can take it from Jovian or GitHub or Google Drive. So dot xlsx df. So watch index 0 is invalid, worksheets found. Okay. So sheet name. Why it is not taking worksheet index 0 is invalid. Okay. What I'll do, sheet 1 I'll mention. It should read by default. So let's see. File contains an invalid specification for tidying data set. This will be removed. Okay. Specification. Let me give different name then. This one. And this MacBook creates some kind of ambiguity while saving CSV to Excel. So what I'll do, I'll just copy the whole thing and create a new Excel sheet altogether. That should work. Okay, so let's save it. Any data. I hope this is going to work. Data. Okay. Yeah, I think it is working. Yeah, so it is a problem with the format conversion. So I think for you guys, if you are using Windows, it is going to work very flawlessly without an issue. Okay. So by default, if you talk about this Excel sheet, right, it is taking sheet number 0. So no matter what sheet you have or what number you have, it is going to read it. Okay. So you can give the sheet name as well. I'll just make another sheet here. So sheet copy. I'll just give sheet 2. Okay, now it is saved. So here you can just give what is sheet name equal to sheet 1. Okay, that is also going to work. If you are going to read by default, let me just move to this. So by default, it is going to read this, sheet 0. And if you're going to give sheet name, so you can give sheet number 2, it is going to read sheet number 2. So let's say you have got data from your client or customer, right? It is having hundreds of sheets. And each sheet you are going to merge. So put a for loop and keep reading all the sheets, join them together, merge them together, and generate a single data frame. Okay, so this will be very helpful. That's how you read it. Now let's talk about reading HTML file. So I'm going to create. So this HTML file is nothing but, let's say you have got some data or your client customer has provided data in their website, right? And that website is nothing but a single page where one big table is there. In that table, a lot of features, and for each feature we have a lot of entries. So thousands of rows are there and thousands of, maybe 100 of columns are there, correct? So how to read such data? So let me take one example. So what I'll do, I'm just going to open a wiki page where a lot of tables are there, right? So let's say Africa population. You can type anything, okay? I just want some data where table is there. So mostly wiki page contains a lot of table data. So let's go with this. Yeah, I think this is the best example. So I'll just copy this particular website, just put it here. So df equal to ed dot, see how easy it is to read any data. And this is nothing but internally it is going to HTML web scraping. Those who doesn't know web scraping is nothing but read the complete HTML data. So a lot of tags will be there and you need to do a lot of text processing. It could be using regular expression or a lot of string handling. So instead of doing that, you just use this function. Internally it will do all your job and return the data. Okay, and just get the page. That's all. DF. Okay, so this is my table. So what it is going to do, it is going to return all the tables in the form of list. Okay, you see here list start with square bracket, and it is going to denote the number as well. Okay, 0, 1, and here you may see a couple of other data also. Okay, so what I'll do first, so length of df. So how many tables are there? See, it is having total 3 tables. Okay, so what it does basically, it is going to read the whole data from HTML page on, and it is going to find all the existing table in the page, and it is going to return a list of those tables. So this is my first table. This complete thing you see, this first table. And do I have another table? I think it is only one. Okay, I don't know if it is considering this also as second table. And this may be third table. So let's read it, what and all it has. So I'll go to the table now. So I'll take df.0. This is the first table. Parts of article. So where is it, part of article? I think this is taking as a first table. Okay. Now what is my next table? Let's talk about this. This is your first, and this is my second table. Yeah, so it is starting with countries, then official date of last figure and source. So this table is what table? Let's see. I think this is your second table. Third table could be this one. Okay, so let's get that also. 0, 1, 2. Yeah, this is your second table. Okay, so that's how you do web scraping of HTML data and fetch the table data accordingly and create a data frame. Okay, so you have a look internally, iterate over each list element of that data and figure it out which is most relevant data frame for you. Then you take that. Okay, so looks like 0, 1, 1 is the most relevant data for me. This is what I was looking. Then I can just do the processing. So df.1, this is a data frame. I'm just going to use df.head. And let's say top 3 rows I want. Okay, df dot then tail bottom 3 rows, df dot describe. Okay, so this is all data I have. So by default, describe takes all numeric, only those columns which is having numerical data. How to read others also I can show. I will show in the case study. Okay, so that's all about this reading data from HTML page. Now let's see. Once you have read the data, right? What next? So after reading the data, you are going to do a lot of data cleaning. So what and all cleaning we have to do, I'm going to show under case study or under the project, not here. So assume that you have done all the cleaning and everything is perfect data. Correct? So perfect data you are going to give to those engineer who is going to apply machine learning or statistical model on that. Correct? So before giving data, you need to have the data clean and save it in a proper format. So how you're going to save? That's where exporting data frame will come into picture. Okay. So let's say this is my clean data, df0 or df1 dot head file. Okay, so this is the data which I already got it clean, and I'm going to give it to a statistician or machine learning engineer who is going to do a lot of further analysis or apply the model and infer a lot of internal details from the data. Okay, so to give the data, you have something called df.toCSV. That is one thing. Give the CSV name. You can see here pd.csv. Why it is not coming? Sorry, df1, right? df, or I can just maybe what I will do now. df1 I have chosen because it is having relevant data, so I'm just going to save it df1 and df.head. Okay, now I'm going to read or export to df.toCSV Yeah, you see here which path you want to save, what are the separator and other things. So those things, again, it is not required. First you drop the data completely to a some file format. Okay, so I want Africa population .csv. That's all. Okay, you just saved it, and I'm going to get the data that is nothing but Africa population. Okay, similarly, this data can be saved to an HTML also. I'm going to show that, so that HTML. Okay, so HTML, what it needs, just again file. So all the file format, whatever you are going to save, right? It just need the file format. That's all. Okay, now let's open that file and understand how it looks. See here. So I read the whole data from here, and I transform it and populate it to HTML format. You see here how nicely it looks. Later you do whatever processing you want. And this looks very nice also whenever you are going to give this data to your statistician or machine learning engineer. Okay. So similarly, you can have SDF5 format also, that is Hadoop data file format. And mostly you're going to use either CSV, HTML, Excel, or JSON. That is the very common or heavily used format, file format. So I can use JSON file. JSON is nothing but JavaScript object notation. So where everything will be stored in the form of dictionary. Okay, so let's use that as well. So let's open JSON file now. So how to look like, you see here, whole data into a dictionary format. Okay, what else we have? So again, I wanted to tell you, right, about another format, that is clipboard, right? So clipboard is nothing but, let's say you have the data. Where is that? Yeah, so only this particular data you want to convert into data frame. So just select it, this part, do copy. So now when you click on copy, right, everything is going to be stored in the form of clipboard. Okay, so we have something called pd.dataframe, sorry, read clipboard. That's all. See here. This is also very sometimes very helpful. Like in case you are not able to fetch complete data from the HTML page, right? Just select the whole table and read clipboard. Okay, so it is going to read from the clipboard and convert it into data frame. Then you can save it or export it to wherever you want. Okay, so what I can do, it is still there in copy. So I can directly save it also. pd dot, not this one. df1 equal to this. Okay. Now df1 dot to underscore HTML and clipboard.html. Okay, let's open this file from clipboard. You see here the whole data. This is what I just copied from this particular table. Yeah. Okay, guys. Yeah, so that's all about file handling or file IO operation from Excel sheet or CSV or HTML. Okay, importing and exporting. So once up to here, if you're able to do Pandas data frame, what do you say, operation over these kind of data, then rest of the job will be very easy. Because rest of the job, what you are going to do, I'm going to tell you like right now. So you have learned string, you have learned dictionary, you have learned list, and you have handled all the NumPy kind of data, right? So these are the whatever methods available on those kind of topics, whatever we have seen so far, everything you are going to use now. Okay, now NumPy is over, Panda is over. I'm going to show data visualization in the next couple of videos. After data visualization, we are going to take some random data. Okay, so random data could be any kind of toy data set, and we are going to do a lot of EDA part, that is exploratory data analysis. Okay, so in EDA part, we are going to use all the tools and techniques, whatever you have done so far, be it Python basic, be it Python advanced, or NumPy, or Pandas methods, whatever you used so far. Okay, so everything we are going to apply. And after data cleaning, so why I'm telling cleaning, because once you get raw data, right, as I mentioned, a lot of empty values will be there, that is treated as NaN, correct? So you need to do a lot of data cleaning, because whenever you're going to apply statistical models or methods on top of data, or machine learning models on top of data, it is not going to take raw data. Your data has to be very clean and it should be in the uniform format. Okay, then only you can apply those models. Okay, so data cleaning part is very important. And believe me guys, almost 70 to 80% effort will go on data cleaning, because this is something which cannot be automated. You or human has to automate. Okay, maybe robot one day it will be able to do that, but it cannot be done 100%. He or she, that robot might be able to do 50 or 60% data, but again remaining percentage human has to do that. Okay, so learn this part very perfectly, then only you should be able to do any kind of model building, or machine learning model building, or statistical model building. Okay, so I hope you like this video. Please try that. Go to any website, fetch the data, do the cleaning, read it, convert to data frame, and dump it to whatever data format you want. Okay, then you will definitely enjoy this Numpy and Pandas. Okay guys, so see you in next video. Hope you like this video. And those who have not subscribed, please do subscribe, leave the comment. If you still need any help or any info or any help on any of the topic, please leave out in the comment box. I'll definitely help you guys. Thank you so much. Bye-bye. Have a nice day.